So good morning, everyone. I think in the paucity of time, we will start. Those who join us later can take the back seats. So welcome to this 127th edition of the Zak World of Façades conference. My name is Ahmed. I'm part of the organizing team here. I'll quickly want to introduce you the Zak World of Façade conference series, and then we'll get straight into the proceedings. Can you switch the screen? Right. So we've been organizing the Zak World of Façade conferences since 2012. So this is edition 127, I have said. As I've said, so we've been very proud of the growth in the last 10 years with this conference series. It's a one-day event, as you know. We talk all things about facade, from design, engineering, execution, what are the new trends, what are the challenges in facade design and engineering. We've been doing this event in almost 36 countries, and by end of the year we should touch around 40 countries. So it's spread all across the globe, right from New Zealand up until Canada. So it's been a great experience for us organizing this event. Every region is different. We've got different challenges. We've got different ways facades are looked at, designed, installed in different parts of the world. So it helps us bringing new topics from one region to another region. So that's something which we've been great. But today's Hyderabad event, we've kept it very simple. We've kept it simple glass box facade design engineering. We've not gone into embodied carbon or any of the other sustainable aspects too much into detail, which is actually the trend in other parts of the world. I think there's still time for that to do so in India, but you'll definitely hear from a lot of people referencing to low carbon design, sustainability, and a lot many more things. So this is what we've done in 2023. This is our 2023 lineup. So this is what we are doing. We've finished 50% of it. We've got a few more left. We've right the halfway mark of the year. So the events are spread all across, and it's always a great experience to go to new regions, to go and host events in non-English language countries, especially for my team who doesn't have expertise in all that. So it's a good learning curve, and we hope we can share that experience to you today through our speakers. I'd like to start off by thanking our event partners, without whom this event wouldn't have been possible, starting with our presenting partner, Schuko. So Schuko is a global leader in aluminum door, window, curtain wall systems. We have a very strong and long-lasting relationship with them. Our premier partner is Alstom. Alstom has non-combustible aluminum composite panel, and now they've got other variants to composite panels in their portfolio. Our networking partner is Aluplex, one of the leading facade engineering installation companies in India. Then our associate partners, Coil. Coil is one of the leading anodizers around the world. So anodizing is coming back into fashion. It's again a high-tech anodizing solution, not the ones we are used to. So they are represented by their local partner, Diamond Engineering Corporation. Cotswold is a British manufacturer of hardware solutions for doors, windows, and facades. Danpal is an Israeli company. They've got polycarbonate cladding for light architecture, for translucency, for roofs and facades. Dow needs no introduction. So this is their high-performance building division, which was earlier Dow Corning. So this is now back to the mother company of Dow, and they are into high-performance sealing and bonding solutions. Eminent International is now a startup. It's a facade testing laboratory. So you've got a lot of glass buildings and a lot of buildings with high-performance facades coming in India. I think the existing capacity of testing labs is almost full in India. So you've got a new testing lab here, which is just on the outskirts of Hyderabad. Euramax, another coil coating company from Belgium, represented with their local partner, Diamond Engineering Corporation. Fundamax, the leaders in high-performance laminates for exterior grade, one of the long-standing partners of this event. Hilti, again, very innovative company from Liechtenstein near Switzerland. They're into multiple things: pacifier protection, ventilated cladding, fixing, fastening, you name it, they've got everything. I'm sure all of you know of Hilti. Kinlong, again, very popular brand here in India. Chinese company, glass hardware, fittings, tools, cables, door, window, facade, curtain wall hardware. and lot many more products. Railings, lots to name, they're just adding every year. Ozone, again, Indian manufacturer of the similar kind of products, hardware, tools, fittings, accessories, door closures, etc. AC Controls, British manufacturer, so they have an actuator. Actuators are used to automate the facade to open for natural ventilation and for smoke control. So AC Controls provides the actuator for the same to automate your operables. Siderise, another British company represented by their partner Olac. They have cavity barriers for rain screen facades, pacifier protection, perimeter joint protections for floor to slab protection between the curtain wall and the structure. Space-Base participating with us for the first time. They're distributing some unique ceramic and terracotta cladding products from Europe and other parts of the world. So alternate cladding materials due to sustainability are picking up. So these kind of materials like ceramic, terracotta are going to be in fashion very, very soon in India. Technoform, German manufacturer of thermal performance solutions. They've got two solutions. One is a thermal break to improve the U-value, so thermal break, and they've got warm edge spacers to improve the U-value of the profiles and the window frames. Technorail, Indian manufacturer of modular railing systems. So railings are also become modular now. You've got freestanding railings, you've got people who want clear view, seamless view, so they've got some nice railing solutions. Viva composite panel, again non-combustible aluminum composite panel and a lot of other value-added composite materials, one of the fastest growing and largest composite panel manufacturing companies in India. So these are all our associate partners, all of them have booths outside, so I encourage you to please visit them during the networking breaks and the lunch break and interact with them and discuss if their solutions could suit your project. Our next event in the series, I'll quickly go through. So we've got Hong Kong in 2 weeks from now. We've got Shanghai. We've got Jakarta. We've got Seoul. We've got Sydney. We've got, of course, the last one in the series in India. It's in Mumbai on the 5th of October. So these are our series. Of course, we've got other events in other parts of the world. I can keep going on and on, but I just thought to select events which are strategic to India and this region. And this is what we've been doing with these events. Every event is different. It's themed differently. Different people present on different topics. What is a trend in one country is definitely not a trend in another country. That's absolutely clear. As an industry, India is fast growing, but I think still the true value of, at least for me, from a layman. Hello. Yeah. So at least from a layman's perspective, from what we are designing and building here, we are way behind a lot many more countries. We can do it overnight, but I don't know what's stopping. We've got the brains. In fact, in most of the countries, most of the facade engineers, most of the production managers are Indians. You know, so when an Indian can build high-rise towers in other parts of the world, engineer and take care of facades perfectly, why can't the same be done here? So there's lots more to go, and I think this event today will show you a broad spectrum. We're touching everything, every single topic. We are touching sustainability, as I mentioned. We are touching fire safety. We are touching cladding materials. We are touching on future trends. We are touching on structural glass. You name it. We are literally talking about everything. So there's everything there for everyone here in today's event, and I hope you'll enjoy today's event. So I think the hall is now filling up. So we'll get into the agenda. But before I close, I just want to let you know we've recorded today's event. So if you miss any session, you'll be getting a YouTube link a week from now on which you can watch the presentations, which we've got permission to share and broadcast with. So that's one. Those who have the red badge, you will see a USB stick hanging on your lanyard. The USB stick has the brochure of all our event partners in that. So you have two folders. One folder you can use for yourself, and the other folder we've locked it with all the brochures of our event partners. We don't have the delegate kit anymore. And that's it from me. I think we can get straight into the first presentation. But before we do that, I'd like to call upon today's event host and convener who would be steering you through the day. Rohan Keswani is a director at Aluplex India, who are one of our networking partners for today. So he's going to be enlightening you and taking you through the day. So thank you all. Thank you all for taking your time and coming out. We look forward to coming back to Hyderabad, probably not next year, the year after. This is our second back-to-back event in Hyderabad. So it gives us 2 years to work on new topics and come back with a much better and different and a fresh program in 2025. Thank you.
Thank you, Ahmed, for setting the tone for the day. Thank you very much, Ahmed, for setting the tone for the day. So good morning, everyone, and welcome to this 126th Zak World of Façades, which is its 4th edition in Hyderabad. So first of all, I'd like to introduce myself. I'm Rohan from Aluplex, and it gives me great pleasure to host this event. Hyderabad is the fastest growing facade market in India over the past decade, and it gives me great pleasure for that reason because it's very, very close to my heart. I still remember about a decade and a half ago or so when the ICICI Bank building in Gachibowli was built. That time Gachibowli, the most of Hyderabad was barren. There weren't as many commercial buildings around. And that was the first building where we had cast-in channels used. It was a prefabricated steel building. It was the first building where there was CNC machinery used for manufacturing unitized panels. It was the first building where the panels were installed along with the construction of the structure itself. And now that's the norm today everywhere in Hyderabad. You see every building using these technologies, and you can see that, and it's great the way the whole city has transformed. Today, as we rapidly grow and urbanize, we can see that buildings are getting taller, geometries are getting more complex, and as we do that, we can see that we are using newer technologies, and that's why we have the title for this presentation, which is transforming, for this day today, which is transforming facades for an evolving metropolis. What's important at the same time is that our facades are durable and safe, not just in terms of air, water, and structural performance, but also in terms of fire. So we have a few presentations today that touch upon the fire safety aspect of it. We also talk about what's very important is that it's sustainable. We have a lower carbon footprint, not only in terms of the operational carbon. It's not about just having lower U values and having a lower solar heat gain, for which we have a presentation on, but also in terms of having the lower embodied carbon in the facade, so which is the lower amount of carbon that goes into building the facade altogether. Can we procure materials locally? Can we procure materials which have lower energy costs in terms of transportation, lower energy costs in terms of procuring those materials? And lastly, and most importantly, is in terms of the technologies we are using from a digital perspective. What are the digital technologies that we are using today? Are we really digitally transforming as organizations in the way we construct buildings? Are we using artificial intelligence in today's day and age? Are we using parametric modeling? What are we doing differently today? And we have presentations about that as well. So before I take any more of your time, let me get on with the day. Let me first inform you all that we will not be taking any questions at the end of each presentation. You can find each speaker in the networking break and ask them personal questions yourselves. That's because just to keep the agenda in the time limit that we need. And lastly, can you all please keep your phones on silent? So there is a slight change in the agenda. Instead of Mr. Sridhar Gopisetti from Team 1, we have Mr. Sriram Ramakrishnan from FHD Architects, who's talking about architecture, facade, and sustainability. So welcome, Mr. Sriram.
Thank you. Hello all. I'm really excited to share some of our projects to you. The topic that I'll be discussing is on architecture, facade, and sustainability. In the next 20 minutes, I'll be taking you through a case study of one of our projects in detail, and I'll also be showing some of our innovation. The biggest point that I'm trying to put forward is this architecture, facade, and sustainability are not three different ideas, but they are so intertwined that they are one big idea. Generally, when we say architecture, what comes to our mind in terms of the goal is, form, aesthetics, typology, programs, what function the building is going to perform. When you think in terms of facade, what comes to your mind? Enclosure, embodied energy, heat, wind, ventilation, views, aesthetic character for the building. When you think about sustainability, we think about minimizing the energy requirement of the building. We think about sustainability goals. We think about water, recycling, local materials. I'm going to show you through our projects why these three things are all intertwined into one big idea. I'll start with a small video of our project. Project you just saw is a Polycab Experience Center, which is located in Halol. You would have heard about the brand Polycab. This is their corporate experience center we had designed. Halol is a place close to Vadodara. It's more like an industrial hub of Gujarat. So most of your construction companies are in and around Halol. We started designing with, Halol is an industrial hub, so we typically see factory buildings, and we wanted to create a building that creates a landmark. The building, when it should differentiate itself from the rest of the city. We started with a site that is just adjoining an existing copper cable factory, and on one side you have a primary highway. We wanted to protect the existing trees. So there are 4 major existing trees that we wanted to protect. There is also a small existing well that we wanted to protect, and that defines the form of the building. And we are also creating a small connection to the existing factory through our building that creates a kind of a bridge above and a walkway type of an atrium under them. And we are also opening up space so that we bring in daylight throughout the building, and we don't extend the building size beyond a point. That also opens up a mini courtyard between the building. And finally, we are trying to bring in our facade. Our important understanding is, what are we looking towards? Towards the north, we are having the plains, which is mostly not so much of an interesting view. So we are having mostly an opaque facade. Towards the west, we have the existing factory. Again, it's not something that we want to see into. Towards the east and south is where we have our maximum views. We have an interesting hill on the east, and towards the south, we have a scenic view. So we are designing our glazing towards the views and where we want light from. And in order to protect from direct sun, as I mentioned, towards the north and west, we are having an opaque facade with minimal windows. Towards the south, where we generally have a horizontal sun, we are creating horizontal projections through balconies. Towards the east, where you have angular sun, we are creating this vertical fins, which I'll be explaining in detail as we go into this project. So each of this side, we are trying to maximize what is being offered from the project. As you see, the existing factory towards the west of the building is almost half a kilometer long building where they roll copper cables. And this is currently one of the most iconic buildings of Halol. And what you see is the eastern and southern facade of the building. The eastern facade looks into these beautiful hills that are both creating a view, and east also gives mild sun without much of direct heat. And towards the south, as I just briefed, we are cantilevering some of the balconies so that we can shade the levels above and below them. And finally, we are introducing solar panels to maximize the natural heat that is available in the place. As many of you know, Gujarat is mostly like a hot and dry type of a weather for most times of a year. We have a minimal privacy requirement. We need to remove glare because it's an office on one side and a customer experience center on the other. We want a 500 lux daylight throughout the year. And wind is not much of a criteria because it's generally kind of dusty environment where we want a conditioned space. We do have good views on two sides, and of course, we have to protect ourselves from rain. So when you first enter the project, this is the view that you actually see when you enter from the highway, where you are greeted by the two wings of the building. And the facade that I explained, I'll just run through some of the views, and I'll explain some of these materials in depth. So the idea is to keep this glazing, but not at the cost of losing energy. And both during the day and at night, the design provides a very interesting experience that transitions from day to night. Also, an interesting factor is most of the energy of this building is almost a net zero building, which I'll explain as well. In future, this building is going to run on the complete energy. Even now, around 60% of the energy of the building is produced within the building. So the remaining 40%, we are on track to produce a complete net zero building within the next 5 years. So the central green space, these also create interesting interacting spaces. So the building works as an office during the day, and it might bring guests and international customers throughout the day. So that is why the building has a transitionary experience throughout the day. We just saw the first view when you enter the project from where you enter through this drop-off area that you have been mentioned. So this is a double height atrium that I just showed during the massing stage. What you see floating above the building is actually a 200-seater auditorium that is designed for acoustic performance. The atrium during the day performs as a shading space. During the evening, it also performs as a well-lit space that people would want to spend time and hang out. The water you see is the existing well that we have repurposed to collect rainwater. Getting into the details of the facade, as I just mentioned, Gujarat has a warm and dry climate, so we have to shade the glazing for most times of the year. So we did a kind of a shading analysis model for throughout the project. Tata EcoFirst, a consultant from Mumbai, worked with us in this regard. We created different cases of the facade. What is the facade material that we are going to work with? Due to time, I am not going to go in detail. I can discuss this with anyone who is interested. We essentially wanted to pick a double glazed facade with like a low E value. We use the Saint-Gobain product for this. And we created a double glazed facade with an air gap that was proven to have a heat reduction impact. We have also quantified some of this. And when we went into this, we are having about 60% of our facade as glazing. So we had to work through the shading angles for our fins, which we worked with aluminum fins, which are locally procured with a wooden finish. We worked through the sun angles for having a shading effect throughout the year. We also used local materials that are available in a cable company, which we used it for our landscape and other interesting features. And the aluminum fins which we are bringing in due to the sun angle design, this is actually the sample of the material. The aluminum fin we procured with a local vendor. And these materials are actually, you can see the transitionary character of the fins. This is because of the solar angle changing in direction, that at different points of the building you have different density of fins. We also worked out a daylighting analysis for inside the building. As I mentioned, we need our lux levels to perform as an office. This is a typical office space. For almost 10 to 11 months in a year, you would get sufficient daylight to work the project without without the need of additional artificial lightings. For a photograph, this is actually a basement floor. This is the darkest floor in the floor. Even here, we almost get 200 to 250 lux of daylight. So this is the calculation we did after the building is completed. We are able to get, we measured during summer and winter without lights and with lights. So for about 9 months in a year, we are able to get the sunlight required for our functioning. So the facade as a whole kind of reduces 20% of the heat gain of the building. That is what we achieved by picking the facade design as well as the glazing and the panel cladding that we used, the fins that we used. Now coming to the renewable energy part, we almost installed 190 kilowatt of energy above the building, which is among the largest for the projects in Halol and Vadodara. And even during the construction of the building, the solar panels were installed as soon as the concrete structures were set up. So we did not have a generator on site. The entire construction of the building was also done using the solar panels once the concreting stage was done. So to sum it up, we almost save 20% of our energy requirement from the facade design. We are able to generate 40% of the energy required for the building from the solar panels. And as you see behind, we have this existing factory structure where we are also started installing solar panels as a part of this project. So we have almost installed another 20% capacity for solar panels. In the next 5 years, we'll be making the 100% energy of the building will be produced from within the building. So it's currently recognized as a net zero building in several national and international forums. And we'll just take you through some of the quick interior spaces that we have done. So since it's a copper factory, we wanted to use copper as a lot of the interior details. Copper has a high embodied energy, but in this case, we use the copper that has been left out from cable manufacturing. So all the local recycled copper, which is just in the factory beside the building, we have used to create the interior language. So this is the MD's room, where we wanted to exhibit copper and energy, which is light. This is the employees' cafeteria, which we showed in the walkthrough also. This is also a well daylit space, which has an open balcony with nice views. So currently, most of the employees in the factory city are not used to this type of a space. Most spaces in this building are designed in a way that they maximize daylight. They use local materials for their design. This is a quick section of the building. We have a triple height entry lobby from the atrium. And we also mentioned about the local materials. We procured 70% of all materials, including steel, concrete, cement, till the finishes of the aluminum fins. We procured 70% of the construction material within a 100-kilometer radius of the project. Fortunately, it was possible because it was in Gujarat, which might not be possible in other places. The project was recently published in Arc Daily as like one of the most energy efficient buildings in India. So if you want to know more about the buildings with more pictures, please take a look at the Arc Daily. The project name is Polycab Experience Center. So the last few minutes, I want to take you through some of our current projects where we are doing new experiments with facades. So one is in terms of a local material. This project I also explained last year in Zak. So we had a site in Telangana where we had local laterite that is available on site. So during excavation, we anyway had to remove some of the stone. We just made blocks of those stones and we made a facade out of it. So all the villas in this community is a very earthy community where we made laterite stone-based facade. The only problem of laterite is it cannot handle rain. So we created a well-shaded space where we exposed the laterite. In all other places, we also used laterite where you see white, but it has been plastered to protect it from rain. we expose the laterite in spaces that are naturally shaded. Another project that we are working on currently in Hyderabad, it's a project in Mechal that we are working on, which is facing a lake. So we wanted to create this large double height glazing. This is not one villa, but we are doing close to 100 to 120 villas. So generally, a double height glazing is not something that group development housing thinks about. So we had a double height glazing throughout the project. And to shade them, we actually used a parametric facade detailing. Like previously in our polycab project that I mentioned, we had vertical fins, which is a much more simpler detail. Here we created a more complex detail. These are generally details people think about in individual houses, but in this case, we wanted to break the bar. So this parametric material that I just showed, it's not yet been done in this form at this scale anywhere else. So in order to start the construction, we actually made a 3D printed model of the actual module. Each module is about 250 mm by 250 mm, which is like just short of a feet. So we decided to detail the material in aluminum, but support them with like mild steel. And how is this parametric form going to work with each other, and how does it going to perform in terms of shading? So we actually made 6 to 8 3D printed samples of this in our office. We tried various patterns of how they can integrate interlocking systems, and we also tested them under sun during different times of the day as to what type of shading efficiency they provide and how could we actually optimize the cleaning mechanism. So after our modeling, we further revised, and what you're seeing as a render is the final revised version. This project would almost be completed probably in the next year and a half. It's already under construction. So this is a project that you'll be seeing in Hyderabad shortly. Another interesting project that we are doing is our international school in Raipur. Raipur, as you know, again is a very hot and a dry climate. And it's also a primary school where we have a lot of young children coming in. So we have a unique challenge where we have to shade. We won't be able to use equal amount of glass as we typically like to use. But we wanted to get some views. We also wanted to open up daylighting. And at the same time, we wanted to create an experience for the children, both from safety and experiential standpoint. So we created this unique facade. The project is currently under construction, where we created a 600 mm projection on the wall, which opens up as fins into interesting window positions. And we are also having a daylight strip glass above the human height. So during all times of the day, even when your windows are closed, you are going to get daylight across your classrooms. So the understanding of this is this. We have this children of different age groups in this school. So we designed windows in a way each child gets a different window. So overall, it looks like a fancy system from the outside, but it's actually a well-thought, well-placed window system that we had designed. And along with it, we also provided that daylight window that I just briefed about. So it serves multiple purpose. So one, during the daytime, even at a lower floor, generally where we don't get direct light at a lower height, when you are having this daylight window at a higher level, it actually penetrates deeper into the room. Typically, we have a height of 2.4 for the window. At a 2.4 to 3, we'll get a penetration of 4.5 meters, which is the grid of the classroom. So the entire classroom gets uniformly lit, diffused light during the day. And the windows are also operable. It seems like a pretty simple system, but this is actually one of our GFC drawings we released yesterday for this project. Just to quickly tell you how much of detail went into this project. This is actually the typical elevation that you would see in any project. And then we had to give plan cut at 3 different sections. We almost had to take plan at 3 different heights to show the different windows. And we also had to take wall section at each uniform interval to show how the windows are being positioned. And then we had to give blow-up details. But all this effort pays up in time, that during the time, what I am trying to conclude with this presentation is, each of the project, we will be able to solve architecture and sustainability by doing a great facade. Often we think making a glass facade is kind of detrimental to sustainability, or doing good architecture is detrimental to sustainability. These almost work with each other together, as long as we understand what climate we are designing for and what material we are working on through. Thank you all for the opportunity. Thank you again.
Thank you very much, Sriram, for your wonderful presentation. Next up, we have Mr. Niraj Borikar, who's Country Manager of Danpal, India. Welcome, Niraj.
Thank you. That was wonderful presentation by Architect Sriram. Uh, well, I'm going to talk about, little extension of what Architect Sriram has spoken about, translucent facade solutions for optimized daylight and solar control that obviously helps in sustainability in terms of energy savings and using more of a natural daylighting solutions with solar control. Let me start with a brief introduction to our company. Danpal offers light architectural solutions for building envelopes. Danpal is the first company to develop standing seam polycarbonate panel systems for various applications for the building envelope. Danpal, of course, 50 years of innovative light architectural solutions offering. And Danpal is present in more than 60 plus countries over the globe with 10 million plus square meters of renowned projects. There are 6 architectural applications solutions from Danpal for facade, cladding, skylight, outdoor, shading, and interior. We call it light architecture. In architecture, the facade of a building is often the most important aspect from a building standpoint. And also, it sets the tone for the rest of the building for interior design as well. From engineering perspective as also, the building of a facade of a building is of great importance due to its impact on energy efficiency. So the design of the building facade has become much more complex today with the new methods of construction, the requirement of highly controlled interior environments, the stress on energy efficiency, and of course the advent of new materials and new production methods. In today's time, we can probably approach the design in these 3 principles: the innovation, novelty, and newness, the soul of contemporary architecture. Novel in this case means a willingness to experiment with the new, the things that haven't been tried before, in terms of material, light, space, or shape. Contemporary architecture typically features the use of unconventional materials or industrial material in domestic spaces. With these 3 principles, when applied to the building facades, asks us to be innovative with our choice of materials and solutions. The daylit spaces hold the potential to yield substantial benefits, including increased energy savings, increased revenue for retail applications, and improvement in human health and productivity. So it is up to us to design buildings using these modern materials and innovative systems to seek new ways to introduce natural daylight in our buildings. Facades need to bring both natural light indoors and allow for solar control. A well-designed facade can dramatically reduce the building peak heat gain and cooling requirements and improve the natural lighting quality of the building interiors. Let's look at how this precious commodity can be used in designing the building facades. The main source of light on Earth is sun. Light or visible light is an electromagnetic radiation spectrum defined between the wavelengths of 400 to 700 nanometers between ultraviolet and infrared rays. The color has, light has 3 properties: speed, reflection, and color. And the color itself has 3 main qualities: hue, chroma, and value. These are some of the benefits for bringing in the daylight in the buildings. This is actually drawn from researches done across the world. The office workers with windows had more sleep per night than those who didn't. Workplaces with good daylit spaces had 3 to 40% gain in productivity and sales. Light is number 1 wanted natural element in workplace design. Well-designed classrooms with natural light explained a 16% variation in learning. Workers in offices with natural elements such as greenery and sunlight were found to be 15% more effective. And there are many more benefits it can go on. Illuminance is especially important when selecting lighting. This is a measure of so-called location-dependent brightness. That is how bright it is at one place. This is indicated by lux numbers, and depending on the task, differing levels of illumination are required. Here are some common, recommended light levels. It can differ from, say, tasks with large items to tasks with small items. As you can see in the warehouses with large items, the lux level required could be only 108, whereas in a small, detailed assembly, it can go up to 10 times, maybe 1,000 lux required for such tasks. The outdoor light level is approximately 10,000 lux on a clear day. In a building with a glazing facade, in the area near the glazing, the light level may be reduced to 1,000 lux. And if you go inside in the middle area of the building, it may be reduced to 25 to 50 lux. So additional lighting equipment is required in this case in the middle area of the building. The most obvious effect of light on the humans is the vision. It enables us to perceive the shape, colors, images, and other information and contrast. But the light also impacts the biology. It affects our alertness and attention, fatigue, and also the hormones. It also determines our body clock and circadian rhythm. So human-centric lighting takes all of this into consideration. Research shows that the productivity under daylight is much higher than when the desk lamps are provided for your necessary workstation lighting. In addition, deprived of the natural light, more of a stress hormone cortisol is released by our immune system. And in the long term, you tend to feel sick for long exposure to such workplaces. In highly concentrated offices, the light temperature should be between 5,500 to 5,800 Kelvin, which is the color temperature of the midday sun. The color temperature of, in office is a very important factor. Here are some, color temperature examples for the sources of lighting. If you see the top half of the table shows the artificial lights with the color temperature, whereas bottom half shows you the natural light with the color temperature. And midday sun temperature, as you can see here, is 5,000 Kelvin. For any facade design, it's important that it takes care of the glare and reflection. Glare and reflection has, negative impacts on the human productivity, and ergonomics plays an important role in selecting the correct lighting. There are two different types of glare that one can, encounter. The direct glare that may be coming in from the sun or a badly placed lighting element, and the indirect glare, or also called as reflected glare, that may be coming in to the eyes from the smooth surfaces like workstation table or PC. Also, with the use of the advanced simulation tools, detailed light maps can be produced, each reflecting the choices of the materials made for glazing, sunroof, or artificial light choice. This helps in making an informed decision. Here is a detailed light map that is done for a building at 3 different times of the day. And on the left-hand side, you can see how the lux levels are, shown in this detailed light map. So you can see a lot of light during 12 noon coming in from the windows and the glazing. Whereas during the night time, say after 5 o'clock or 7 o'clock, you can see that the light is fading. So at this time, the natural light is not available, so we may have to go for the artificial lighting. Here are some examples of harnessing the natural daylight from Danpalon. So Danpalon multi-cell panels with soft light effect can help you, create a balanced interior wherein you can get the natural daylight during the daytime. At the same time, you avoid any glare that is coming in or direct sunlight that is coming in from the roof. The Danpalon panel here are used in the roof with the proprietary roofing system from Danpalon. And here is an example for facade. You can create a very balanced interior with the natural light coming in, taking care of any glare. Another example. So how can UV facades allow the light transmission, but control the solar heat gain? Because as soon as you allow light inside, it is associated with the heat gain. Solar heat gain is basically influenced by the glazing type, the number of panes, and any glass coatings. Solar heat gain of glazing ranges to over 80% for uncoated water white glass. SHGC indicates how much of sun's energy is striking the window is transmitted through the window as heat. So from Danpalon, we have solutions for that, and the Danpalon multi-cell panels with low light are the examples where you can actually control the solar heat gain, which can be as low as 0.17. And at the same time, it can allow the natural daylight to come in. For the context, when considering the laminated solar performance glass, these figures could range from 0.61 to 0.25 SHGC, which are considered as of high performance. Here is an example of a circular building completely clad in Danpalon panels used with a proprietary Danpalon facade systems. The panels were additionally finished with a mattifying effect called soft light. The soft light coating applied to the Danpalon panels limited any glare during the day, and at the also ensured that diffused light is coming in. In this brief example, we can see that modern contemporary building designed in such a way that the facade provides both maximum natural light and diffuse solar control. Here is, of course, another example with the facade with Danpalon multi-cell panels with soft light effects. From the outside, you can see the building is just a light box. But as you enter inside, you can see the box is concealing the heavy concrete structure. How do we achieve this combination of light transmission and solar control? So by utilizing the computer-aided simulation software, it is possible to model the effectiveness of chosen glazing materials used for facade. In essence, this software can provide accurate feedback based on the real-world data with geographical location and localized weather conditions. The result will help inform us with our choice of the glazing material based on the light and heat maps that can be generated from this advanced simulation software. The software also indicates the potential energy savings and usage. Here is another solution from Danpal, an integrated facade system with fixed internal louvers. So Danpalon 3D light allows the sun rays to penetrate through higher levels during morning and evening, whereas blocking most of the sun rays at the midday sun. So it allows for less amount of heat to get transmitted to inside the building during the harsh time, that is the noon, and in evening and morning it allows for natural light to come in. Here's another way to achieve a balanced combination of light transmission and solar control. An integrated facade system from Danpalon with low E panels. Low E panels are the co-extruded polycarbonate panels with low E, that is infrared treatment, which allows for blocking of infrared rays and reduce the heat gain transmission to the building without affecting the natural daylight. Some examples from international portfolio. It's a combination of polycarbonate facade system with the glass. You can see the blue and yellow panels are Danpalon, and what you see below in windows is the glass. Another combination of glass and PC with translucent white panels of Danpalon. A swimming pool facade. This is an example of a Danpalon facade system in Hyderabad, the T-Verse project, which is present in High-Tech City, wherein the Danpalon panels have been used as a main facade element, allowing for the natural daylight. An example of a cladding system from Danpalon, which is used in the Mumbai. Another small project in Hyderabad, it's very interesting view from inside. It looks very good from outside, but if you see from the inside, the effect of Danpalon panels that it creates, kind of sun setting during the evening times. So basically, Danpal can help creating a balanced environment with light transmission, optimized land transmission, and solar control. So welcome to the light architecture by Danpal. That's it from me. Thank you.
Thank you, Niraj, for a wonderful presentation on the Danpal products and solutions. Next up, we have a very interesting topic by an even more interesting speaker, Mr. Upendra Walinjkar, who has more than 20 years of experience in facades and has done more than 30 projects as a consultant, as a facade consultant in Hyderabad itself. So he's a well-known face, and he's going to speak about fire safety facades. And it's very interesting to see, because I'm sure, as he knows, over the last 20 years, there's something which a conventional fire stock that we have used, which is using insulation for the termination between the slab and the back of the spandrel panel, and how that's changed over the last 5 years. And there are tested solutions that have been brought into the market by some of our sponsors like Hilti and Siderise. And he'll talk to you more about that, which one is better, which one works better, or we're fine with the conventional fire stop. Mr. Upendra Walinjkar, everyone.
Hello. Good morning. Thanks, Rohan, for good introduction. Today's topic, what is mentioned is build a facade or a fire safety facade. This is the most discussed topic from many years now, and believe me, I am not going to waste your time on discussing same again, but just throwing a few points to you on improvisation and updating the, bringing the next level of the fire insulation in the facade industry. So these are the few fire spread mechanism: conduction fires, radiation fires, convection fires, direct contact fires, and backdoor fires. This is basic fire behavior whenever there is a fire breakout in a building. Glass panel breaks due to heat, and the leapfrog effect takes place, and fire continues to move on above floors. And fire barriers are provided to take care of spreading of fire. So this is typical leapfrog effect, where one floor gets fire, and because of breakage and hot gases, when comes in contact with air, it's go to next floor, and it's again break the next floor, and this is how fire gets spreaded. So second effect is chimney effect. This is specifically applicable on the ventilated facade majorly, where we use ACP cladding as the most optimized way and most economical material to clad the building and get the aesthetic look. So the important point is how we can avoid the fire spread due to leapfrog effect. Before moving, would like to highlight few impacts of horizontal and vertical projections on window plumes. So there is lot of research done in the Canada by National Research Council on horizontal projections and behavior of fire plumes. So if you see the first image, you will see the addition of horizontal projection is diverting the fire plumes away from the glass. And this convection and radiation, these are the two factors of the fire which are creating a fire to the next floor and breakage of the glass and through which it enters. So the horizontal projection is adding good value, whereas the vertical projection in buildings are channelizing the fire and making it more flammable, and the height of the flames are increasing. So this research has been done with many tests, and that test has given the presented in a graphical form. If you see the top image, the flame deflector has shown the considerable reduction in the heat flux level. And similar way, the vertical projections had added the heat flux level to a value of around 100 plus. So the second image is showing the importance of the horizontal projections with consideration of the height and the reduction in the exposure of the relative exposure of the fire. So if we study this, the graph, the first topmost graph is showing no projection. The second is 0.3 meter projection. Then we have the graph which is indicating 0.6 meter projection results. And fourth graph is showing results of the 1 meter projection. So if we study this graph at 1 meter height, which is generally the height at which the fire breaks out to the next floor also. So with use of these different projections, there are reduction of 50, 65, and 85% in the relative exposure to the fire. So it's very much important to use this technique in optimizing the fire spread and to mitigate the fire spread to the next levels. However, in all buildings, we cannot have all horizontal projection, as well as the, in all buildings, we cannot avoid the vertical projections, considering the aesthetics and the energy saving advantages due to the vertical fins. Moving ahead, just would like to highlight the typical details followed for the projects in India. So this is generally, we have all commercial buildings in the range of 4050 as the floor height, where 3 meter generally is the vision panel and 1 meter is the spandrel height. In this, the spandrel configuration is having a GI tray, shadow box in the front, and insulation material, and fire-saving, fire perimeter barriers as indicated, with GI sheet at the top to protect the fire barriers. To understand the fire saving and perimeter fire barriers in detail, there are different codes locally as well as internationally. NBC, everybody knows over here. NFPA, everybody knows over here. International Building Code and International Fire Codes. Everybody knows all this. So in this, if we read the underlying statement, the fire barrier should be tested in regards to ASTM E2307. To understand the fire safety, we need to understand fire resistance, where the important factor is the facade should also remain structurally intact for the reasonable amount of time when exposed to fire. So, do this only the perimeter barrier needs to be 2 hours fire rated, or whole system? It's a holistic approach should be there to get the desired result and avoid accidents due to the leapfrog effects. So this is just the indication how this fire testing has been done. It has 2 burners, one in the front and one in the inside. And these are the few reference images just to have an idea about the fire testing. In deep diving into the fire test conducted by different manufacturers, these are the results, test reports by all manufacturers, done the testing as per the ASTM and EN standards. So all these results, if you study, it shows the spandrel panel has been protected well, and there are mullion covers provided in all these systems when they are testing. Also, the stiffening angles are there to protect the integrity of the and stability of the spandrel panel. So these are the same images where the things has been highlighted. These are different companies who are manufacturing the products and tested their products. So details what we followed, I'm coming back to the fact that what is different in the detail what we followed on our projects and what has been tested in the laboratory. So this is the first factor, which is stiffening angle has been used by nearly all tests has been conducted, which is giving the the required compression in case of fire when it starts expanding. This is the protection to the brackets when we are having the required depth of insulation should be provided at the bottom of the bracket. So locally we need to provide this. Then this is the mullion cover to protect, because at 200° plus mullion starts losing its properties, and at 600° it melts. So we need to cover the mullion. These are the few views. I think aesthetically that mullion covers will be a issue to architects, but certainly this is the life safety. So we need to accept with it, and we need to find out the right solutions to cover this. To understand the spandrel panel and learning from test, if you see this video, it shows when the spandrel panel gets fail, it's have immediate impact on next floor, and leapfrog effect takes place, and it's continue the fire spread. So this is the image video which is showing that when we are using the right combination of the spandrel panel, the fire can not break the next panel, and this is how we can achieve better fire spread results. So these are the few learning from the test reports, that in major test, the insulation, the spandrel insulation used is having a density of 128 kg per meter cube. Stiffening tees are there, framing covers are there, correct connections are there. If we read the statements and the nomenclature, it shows that around 200 to 250 is the spacing of screw we need to put. Demand for the engineering judgment should be there. And further studying this, is there any relation of spandrel height and leapfrogging effect? While working on this, I got this interesting image which indicates if we have 0 spandrel, it will take just 5 to 13 minutes to break the next panel. Similarly, nearly 21 minutes for 1 meter height spandrel panel, and so on. Just this is similar way chimney effects. This is more critical for ventilated facade as the gap is very less and fire can spread to the next floor very quickly. These are few of the fire accidents happen worldwide, and out of which fire accidents like address in Dubai in 2016 and Grenfell, everybody knows, are really eye-opener in this industry, facade industry, and people have started using FR material. There are countries who has regulation which doesn't allow using LDP core material. And all these panels, if we study, are passing the fire rating system. So similar way, there are some requirements for passing the fire performance of the ACP cladding material. So these are the images based on the NHBC, National Housing Building Council guidelines UK, which indicates the need of cavity barriers and vertical compartmentalization on the facade when we are going for especially the ventilated facade. So only using a fire rated ACP is not going to help us. We need to follow the full-fledged system to achieve the desired results. So these are the few of the learning from this process. So addition of horizontal projection as per the study plays major role. Increase in height of spandrel panel is also helpful to reduce the spread of fire to next levels. Adopting holistic approach to design and facade systems with fire-rated horizontal projections, height of spandrel panels, or combination of above, use of sprinkler system with periodic maintenance. This is very much important point, which is always, not taken care by developers or the maintenance people, and because of which we came across the situations where the fire spread is increasing. Also, use of cavity barriers. Use of cavity barriers for compartmentalization, and revision in regulation is required considering the maintenance of the sprinkler and fire spread with FR grade ACP without cavity barriers. Just to understand more, we have different neighboring countries which are following the similar codes, and their codes are bit stringent. If we see a Singapore requirement, it's stating that 1 hour fire rated spandrel that when installed measure at least 1.5 meter. This is the point which I was highlighting in my previous slide, which is indicating the height of spandrel panel and leapfrog effect to control the fire spread. So this is the first point. Or they are having a choice that 1 hour fire rated horizontal projection. Please remember, it should be a fire rated horizontal projection, which is at least 600 mm from the building. So either you go with 1.5 meter high spandrel panel, or you use a 600 mm high projection of 600 mm as a horizontal fire rated projection. If we study further and see UAE standards, it's again a demand for similar that 1 hour fire rated spandrel panel should be there, and 762 mm as a projection. The same way China is having a similar requirement of 600 mm horizontal projection on 1 meter of the fire rating for spandrel panel. Hong Kong is having again the similar requirement of 900 as a spandrel and 500 as a horizontal projection, which are fire rated. So these countries had written a code very clearly, and whenever we talk about the 900 as a vertical spandrel, which is minimum, in all test results, if you see there is a 914 as a spandrel height minimum requirement for testing. So we need to wake up and understand what we are providing as only fire barrier is not going to help, and we need to look into spandrel panel also with some performance rating, not 2 hours, but at least 1 hour, which will avoid the fire spread, and that's how we can avoid the accidents, fire and losses. The good news is there are latest development happening in the country, Bureau of Indian Standard, and the CED is working on revising the fire codes, and they will be coming up with a new amendment to the existing NBC. And based on this, they will maybe follow the full adoption of ASTM E2307, which is most relevant code based on the different test methods and simulating the fire condition happening in the fire accidents. So the holistic approach in our design is very much important, and we should follow the holistic approach whenever we are designing any facade or whenever we are working on any project which is where we are doing the compartmentalization of the facade. So thanks, and hope I'm on time. I'd say 1 minute. Yeah, thanks all.
I mean, since we have a little bit of time, I thought I'll ask you maybe just one question.
Yeah.
You know, excellent presentation. You spoke about the tested assemblies, which are important in terms of not just your fire stop, but also your spandrel insulation. You spoke about the height of your spandrel. You talked about the projection, which is required. Now, that projection would be, as a fire-safe material, what would you call that? What would you recommend as a fire-safe projection of 9?
Generally, fire-saving material, it will be a responsibility of architect to design. I would recommend if we are having some the slab projections, which will be more safe. And when we are talking about the fire-safe material, then we need to follow the standards and have a material which will be having minimum 1 hour fire rating and selecting a material which
maybe an aluminium fin.
With some insulation stuff inside, and selecting the right density of insulation material to withstand the fire loads, and stiffening of the material with some GI so that it will not, it will remain there stable for duration required.
Thank you very much. There's a last question. You don't have to answer if you don't want to. What's better, Hilti or side rise?
Oh, it's open to everyone. It's a choice of fabricator.
Thank you very much, Upendra.
Thank you.
Next up, we have TS Aditya from Fundamax, one of our sponsors, who's going to also continue this excellent topic of fire.
Check. Good morning, one and all. So, Mr. Upendra has covered a lot of important topic that is especially regarding fire. I would like to extend that, and the key message from this presentation is what is the criteria for selection of the right material in order to withstand fire? What are the installation systems available by which you can ensure fire safety? Along with that, I would also like to showcase you some unique and interesting projects that we have created. Before starting the presentation, I would like to start with a small video.
Change. Change is our constant. A journey over the last 130 years. We are rooted in change. change is our way. And we are doing it again. We are changing. We think freely. We think ahead. We are Fundamax. We live perfection. We love design. We respect individuality. We complete what nature gives us. And we know where our journey is taking us. We are open for new ideas, for inspiration, for tomorrow. Open for you. And open for you to create. Fundamax.
So, I'm sure you all know about fire, but just to brief you a little, fire is a rapid exothermic process which emits heat, light, and other various byproducts. So when you look at slower processes like oxidation, when it comes to rusting, these do not qualify under this category of fire. Generally, we talk about a lot of products which are fire rated. We talk about A-class materials, we talk about B-class materials. But yes, even fire can be categorized based on the material it comes in contact with. For example, if you look at normal combustible materials like wood, paper, and rubber, when fire comes in contact with these materials, it is classified as Class A fire. Similarly, when fire is in contact with materials like flammable liquids and gasoline, oils, it is classified as Class B fire. In the right-hand side, you can see the mechanism or the methodology by which you can extinguish this fire. Fire, when it is in contact with electrical live equipment, it's called Class C. When it's in touch with metal and metal alloys, it is Class D. You have a lot of combustible materials in our kitchens. We have animal fats, we have vegetable oils. So all these materials, when come in contact with fire, it is classified as Class K fire. Now, if you want to understand what is the entire process by which a material can actually, right from the ignition process, how it starts, you need to understand this graph between temperature and time. So any material generally undergoes this process where there's initially ignition, and then there's growing fire stage. From growing fire to fully developed fire stage, it crosses something called a flashover potential, and then you have the cooling phase, and then it's gone. So now we are trying to look at materials, how they are categorized based on the contact with fire. Now, if you look at materials which are concrete, brick, stone, these are completely non-combustible, which means it's A1 class. A1 class means that no component of the material can catch fire. So the process in which it starts the ignition, but it does not go into the growing fire stage. When you look at Class B kind of materials, which means that they're flame retardant materials. So for example, if you look at glass wool is made up of various glass fibers, which are integrated with an adhesive. So what happens is, when glass wool is under fire, the adhesives and the glass fibers can thermally degrade, but still it remains intact. So it means that some components of the material can catch fire, but not completely. So for example, we have a product called M-Look, which is made up of glass fiber flea. Now, only the decor paper on the top and bottom can get burnt, but the core remains intact as it is. So this qualifies under Class A2. Similarly, you have Class B. Class B means it's a flame retardant product, which means if you start igniting the product with fire, at the point of contact, the material burns, but the material has a property in which it will retard the flame by itself. So it's a Class B material. Similarly, if you move from Class C to F in the ascending order, the time taken for the material to cross the flashover potential and to completely burn is very rapid. So typically, architects and facade consultants do not prefer materials which are C to F. So we talk about European standards, we talk about ASTM standards, we talk about British standards. How do we correlate each of these codes is something which I'm going to show you in this presentation. Now, if you look at European standards, we have A1, A2, B, C, D, and E. And if you look at a B-class material, it is generally as per EN ISO 11925 Part 2. And our fire rating is in line with BS 476 Part 7. So now if you look at it, Class A1 in European standard falls under non-combustible category of BS 476 Part 4. Class A2 falls under limited combustibility. Class B falls under Class 0 as per UK standards. Class C is 1 and 2, D is 3, and E is 4. So you can correlate Class A1 with British standards in this first table. Now when you look at ASTM standards, it's slightly different because they talk about something called flame spread index. Flame spread index is nothing but the length of fire by amount of fire. When you talk about the length of fire, fire can spread both horizontally and vertically. The material, due to the material property, it spreads horizontally. Due to the natural phenomenon, because of chimney effect and other effects, it spreads vertically. So any product within the flame spread index of 0 to 25, as per ASTM standards, falls under class 1. And ASTM standard class 1 means it can be either A1, A2, or B as per European norms. So anything in A1, A2, or B still falls under class A as per ASTM standard. So the important thing here is we should understand whether it is ASTM or British standard or European standards, and based on that, you can categorize the material under which segment it falls under. So far we have looked at types of fire, how we correlate the codes with different materials, and what is the difference between European standards, ASTM standards, and British standards. Now we are going to look at some facade materials that are typically used. So when you look at aluminum, you have solid aluminum sheets which are used for facades starting from 2 mm. You have perforated panels. You have a lot of parametric facades which are made by bending aluminum. So aluminum melts at around 600 to 660 degrees centigrade, and it is a very good conductor of heat, and it has extreme high reflectivity compared to MS or iron. But however, if you use a solid aluminum panel, the product itself falls under the category of A1. ACP is a different material. You have an insulating material with 2 thin sheets of aluminum. If the insulating material is made up of completely polyethylene core, then it is easily combustible and it falls under the category of class D. But if you have a mix of fiber mineral core and polyethylene, it may fall under the category of class B, which is a flame retardant product. And if it has completely a fiber mineral core, then it becomes class A2, generally which you call it as fire rated ACP. You have stone. Typically Indian architects and clients love stone, so it has its own beauty and its own charm. However, depending on the type of stone, for example, if you look at something like granite can disintegrate and in case of fire, and it can explode. It is possible under extreme conditions. You have seen a lot of projects where the stone keeps falling even though you use a dry cladding system, because the substructure is not in line with the stone, which has so much of dead weight. And when you have so much of thermal expansion and contractions, there's a possibility for it to disintegrate from its subframe. So it is very important to understand the fixing mechanism and not just the product. In spite of using a class A1 material or A2 material or even D material, if you do not follow the right installation methodology, then no material is good. So if you look at something like limestone, it can easily crumble under very low temperatures. Sandstone is a little different. It's very compact. And generally for facades, if you look at stones, sandstone definitely is preferable compared to granite and limestone. Zinc, you have solid zinc panel. Again, zinc is a good conductor of heat. It can withstand somewhere up to 400 to 420 degrees centigrade. Solid zinc panel falls under the category of A1, and zinc composite panels with polyethylene core qualify under class C. Now, since you have seen the video, we talked about change. The reason why we have shown that video is, times are changing, the demands are changing. We talk a lot about fire safety. Until and unless we find and evolve ourselves and acclimatize to the requirements of the architect, it's very difficult to fit into the requirement. So far we had a product which is high pressure laminate, which is made up of paper and resin, and it's a class B product. But because of certain requests and demand from the market, we have developed this product called M-Look, which has glass fiber flea. It has 14 different layers of glass fiber flea. gray dyed glass fiber flea with white dyed glass fiber flea. The reason why you have that white dyed flea is that you don't get the impression of the gray on the top decor paper, and it does not kill the character of the decor. So this is completely categorized as A2 material. Now, we talk about rear ventilated facade systems. So there are two criteria in which you can qualify a material to be rear ventilated, or system to be rear ventilated rather. The gap, the cavity between your finished surface and the wall should at least be 2 centimeters. You should leave a vent on top and bottom so that there is circulation of air. You know, the hot air enters in, because it being less dense, it has a tendency to rise up and come out from the top vent. This increases the thermal and energy efficiency of the building. Then if you use an insulating core with a rock wool, then you can further have better efficiency. The next thing is that you have to also make sure that you give proper expansion gaps. This is for the material. It has nothing to do with rear ventilation. Every material has a coefficient of expansion. It may expand because of heat. It may expand because of moisture. But if you do not give those expansion gaps, and if you close them with so-called sealants, if they are not working over a period of time with the tropical changes, then it may fail. So this acts as a thermal bridge. You can have substantial amount of noise reduction. You can also increase your thermal comfort inside. If you have probably a decent window to wall ratio, and it of course depends on the movement of the sun, on the sun path and other things, but you can have a thermal efficiency up to 33%, depending on the usage and you know, which phase of the building you're using and which region you're placed out of. So these are some advantages of a rear ventilated facade system, and it also acts as a bracing. The subframe acts as a bracing, and it will definitely help you to reduce cracks and also conceal them in case if you find some micro cracks here and there. So coming to our standards, we have already seen our code NBC 2017 is in line with BS 476 Part 7. And if you look at the smoke index or flame spread index of our panel, it's between 10 to 15. So it is class A as per ASTM standards and class 0 as per British standards. I'm talking about a class B material in European standards. So this is how it is. And as per European norms, it is EN 13501. So this is the corresponding norm with respect to a B-class material. And the standard is BS1D0, which means it is class B material with smoke index 1 and droplet 0. When you look at an A-class material of Fundamax, it is A2S1D0. Now, we spoke about the installation systems. Until and unless you use fire stops at the right places, whenever you have an opening in a dead wall, if you do not conceal the periphery of that opening, and then you use a rain screen facade system where you compartmentalize various parts of the substructure, then fire can easily spread from one place to another. If you use a rear ventilated facade system, the fire will easily spread because of the chimney effect. So you have to use a rain screen facade system, and you need to compartmentalize it and make sure that in case of fire breakage through an opening in the dead wall, it should not spread fast. So these are some projects what we have done. This is a 700 mm by 700 mm panel, which is suspended on stainless steel ropes. It's a kind of a kinetic facade which keeps moving with the wind. They are singular, double and triplet panels connected with GI brackets, and they are fixed onto the stainless steel rope with studs. This is a school building which we have done in Bangalore. Even the profiling on the edge is done by us. So this is done with a combination of, with glass. It's a semi-unitized system. Everything was done in the factory. So it can be very efficient and fast. Then this is a project in Czech Republic. We have done it on MS substructure with stainless steel rivets. In Europe, there's a rule that about 22 meters, you cannot use a B-class material. So you are mandatorily supposed to use an A1 or A2 class material. And if you have twin towers connected by a bridge, then the bottom of the bridge is generally cladded with Fundamax, because with M-look panel, so that in case of fire breakage in one tower, it does not spread to the other tower. Up to 22 meters, you can easily go with a normal B-class material. So coming to Fundamax, we have huge range of decors. We have close to 132 decors. In fact, we have launched around 40 new decors recently. We have launched new surfaces, which is Paragon, which is completely, it is like a ultra matte finish with a velvet kind of finish. We have Sky finish, which is completely has an undulated surface. And we have other materials like glossy as well. Our product is almost 130 years old, and our head office is located in Bangalore. We are there in India from the last 15 years. We have executed close to 15,000 projects. We give importance to installation. That's the reason we give a complete, full-fledged, end-to-end solution. We ensure that it's installed following the technical norms and technical compliances, and we operate through our channel partners. So these are some of the pictures. You can see they are perforated. You have louvers. You have segmented. You can make curved facades, and you can have manually and motorized operating louver system, and you can have parametric facades as well. So thank you for your time.
Thank you very much. Thank you, Aditya, for your presentation on fire. So we've had a nice morning session. I think we've had informative presentations on fire, sustainability, and it's time for us to get our cups of coffee. But before we head out, we're heading out for 20 minutes. We want to see you all back here in 20 minutes. And before that, we have Mr. Shyam from Shuko to give the mementos to all the speakers. So if you guys can stay back, and everybody else can go out for coffee. Welcome back, ladies and gentlemen. I hope you're all recharged with that caffeine in your system. If we can all please take our seats, put our phones back on silent, because we have a very, very interesting session coming up. In this session, we have 4 speakers, actually, 5 speakers, and an excellent panel discussion. 5 speakers because we have 3 presentations. First of all, the one that we have coming up next is by Sushant Goel of Eckersley O'Callaghan, known as EOC engineers. EOC engineers, for those who don't know, are responsible for all the Apple stores in the world, most of the Apple stores in the world at least, for which I had personal experience very recently working on India's first Apple store at BKC in Mumbai, where we worked very closely with EOC and Seeley. And we have Sushant over here, who has finished his master's in structural engineering in computational analysis in Germany. Spent 7 years working in Germany as a structural engineer, and then has been working with EOC and heading their India office for the past 3 years. Sushant.
Thank you for the kind introduction. Good afternoon, everyone. The presentation is split into 2 parts. First, I'll be talking about the process, and the next part, I'll rush through the projects in whatever time is available. So EOC, or Eckersley O'Callaghan, is a design consultancy firm. Our business is split into 3 verticals: structures, facades, and glass. The picture on the right is India's first Apple Store BKC in Mumbai, engineered by EOC. EOC's footprint on the world, we have 11 offices with our headquarters in London, 147 experts, 32 countries with live projects, and the most important, 67% of our work comes from repeat clients. Now, today's theme, as we all agree, facades are one of the most fundamental systems in a building. Their design is a complex interdisciplinary process, and typically sequential approach is what we use, but that is something which doesn't allow comprehensive exploration or informed decision making during the early concept stage or the critical stages of the project. So what is the alternative? Holistic approach with the help of digital design tools. Now, before we talk about the holistic approach, what are the elements of facade design and engineering? Architecture, structure, environment or environmental aspects, construction, ventilation, acoustics, energy or HVAC modeling, maintenance of the facades, fire requirements, as has already been highlighted in the previous session, cost, a very important aspect, design life, the structural redundancy in the facade or the glass panels, the facade movements, embodied carbon, And this is not an exhaustive list. There are many more, but these are the ones which we'll be talking about. So, sequential approach. Typically, when you have a concept sketch, we try to rush through various stages that are mentioned here, something that we call a preliminary design, and we make a judgment whether that concept sketch can become reality and whether that is a good solution or not. This approach works with, if you have 1 or 2 concepts, maybe it works even with 5 concepts. It will be time consuming but manageable. But if you're passionate about concept design, how do you deal if you have to check 20 concepts in the beginning? So the proposal is holistic approach, wherein all the parameters are not sequential, but they are arranged around a fully parametric model in which the geometry of the model or other aspects can be parameterized. So these are the tools that can be used to implement holistic approach. On the next slide, I'll show how these tools are placed in the entire process. So first, we start with this environment, Rhino and Grasshopper, where we define our model with the parameters. Then we dive into these various plugins. For example, Ladybug is a plugin that allows to do environmental analysis. Butterfly is a plugin that allows to do computational fluid dynamics. Honeybee is a plugin that allows HVAC sizing, energy modeling, or glare, annual daylight, illuminance analysis. Then there's something called Karamba on the right side, which provides serviceability, strength, stability, movements, material takeoff. Then we have embodied carbon, that is a in-house EOC tool, which is called EOC Echo 2. And then, again, the most important aspect, cost. So all these variables is something which are revolving around a parametric model. And then over here, these are optimization solvers, single objective, multi-objective, and this process can be fully automated. As an example, we'll see, so this is an example building which I've taken in red. Now this is a parametric geometry model where the parameter is ratio between the plan of ground floor and top floor. And now, so this is parametric geometry. This is parametric annual radiation, where in real time, as the geometry is changing, I can see the change in annual radiation. So that was parameter 1. Now parameter 2 could be the twist of the building around the principal axis, like a twisted form. And this is in real time, the annual radiation change as the form is twisting. So now how can I use it in a project? What's happening here is there are 2 parameters which are changing iteratively, and I've connected it to a single objective optimization solver, and the objective is minimize annual radiation. So it is playing with those 2 parameters and generating different forms and trying to reduce the annual radiation of the building. Now you can also club it with many other parameters like increase the floor area and so on. Now we have a fully parametric model. We have various plugins to calculate and do the analysis. But how do we make a judgment from the generated options that which is the one which we should proceed with? So this is where the consultants, the codes come in, that the performance criteria are listed radially, and they are graded. Code compliance, consultants input, experience has to be put in, and then you compare the generated solutions with this benchmark. So again, I can generate multiple options with this process and make an informed decision about a project during the early design stages. So this part of the presentation ends with this slide, which is very important. On the x-axis is the time invested. On the y-axis is the value drawn from a model. Red is setting up the model. Yellow is self-validating the model. So this process, red and yellow, is very important. most of the times what happens is people try to shorten the red and the yellow parts and directly jump onto the blue parts, and then you never know how close are you to the real building behavior. So, and hence the quote, with great computational power comes great design and engineering responsibility. You have to be very responsible when you're using these tools, and you need to understand them properly. Now I'll show you 3 projects. First one is 2 Taiko Place, Hong Kong. EOC is the facade consultant on the project. This is how the building is located with respect to north, and it's in Hong Kong at the Quarry Bay Business District. Fact file, tower height is 200 meters, planned dimensions are approximately 37 by 72 meters with rounded corners, 99,000 square meters of lettable floor space in 42 stories, including 2 sky gardens, and 32,000 square meters of curtain wall, having 3-meter wide modules. A render during nighttime and daytime. Some concepts that were generated for the facade, and the ones marked with the blue boxes are the ones which are picked up for further studies. Curtain wall typology, light blue is flat, unitized curtain wall. Dark blue is curved, unitized curtain wall, quite complicated. The red ones are the panels with the louvers. That's on the south facade because that's where all the HVAC systems are. And at the bottom, you see the gray area. That's the most remarkable feature of this project that I'll talk about in one slide. View analysis, pink means the view is blocked, cyan means the view is great. So based on the view analysis, you can make changes in the geometry or some other aspects. Annual radiation, if you move from left to right, these are the solar radiation plots on an annual basis. They're converted to grayscale. Black means that solar exposure is very high. You need high intensity strategies. Gray means low intensity strategies will work in those areas. Those plots are basically from Jan 1 to December 31, the annual daylight image with, so on the x-axis is time, on the y-axis is the hour of the day, so that's for entire year in that particular black region. And on the extreme right is the sun path analysis for various seasons for this particular building. So all these outputs from the tools is what helps us to make an informed decision. This is a render of the facade without any shading elements. This is a render of the facade with the shading elements. Now, why do you want to add fins to it? So this is what justifies the use of fins. X-axis is shading strategy, which is pictorially represented in the images below. And y-axis is the maximum allowable shading coefficient. So to achieve the LEED Platinum or the OTTV requirement of 20 watts per meter square, it's the middle green line on the graph that works. So without shading elements, it is 0.21. With shading elements, it goes up to 0.26, and that is the chosen solution. And we can see from the graph that horizontal fins don't add much value, hence the prime focus is on the vertical fins. This is a render of the mullion with the fins. Now, coming to the corners. So these corners are tapered as they go up because the architect wanted to give the building a taller impression. But the problem that arises is that if you look at this panel, the top and bottom, the color coding is consistent, but on the sides, there is an arc rise. And left to right, it is different. So this involved a lot of scripting to find out what is the manufacturing tolerance available, what can the manufacturers achieve, and then backfeed into the computational design model and come up with a solution. So the last thing in Taiko Place, Hong Kong is this remarkable podium facade. It is a 15-meter tall glass panel, and it doesn't have any framing. There are tension rods between the glass joints, which are highly tensioned, and that forms the out-of-plane resistance of this facade. So this is, I think, the first in Asia and probably the first in the world at this scale. Next is 63 Madison Avenue in New York. EOC was the facade consultant on this project. This is how the building is located with respect to north, and it is right next to the Madison Square Park. Fact file, it's a 15-story New York City office high-rise constructed in 1962. The aim is to cut emissions by half by year to 2030. It was a design competition to sort ideas to give a representative building a deep energy retrofit with a focus on the facade. And EUC was the part of the winning team. This is the building that needs to be retrofitted, the facade. This is the idea sketch that you add a secondary skin with some shading elements, which also gives it a unique element in terms of its aesthetics. Now, idea overview again. You take off the existing facade, put a new facade, and then add a secondary skin. Now, the secondary skin, if you look at the vertical image on the right, you add some brackets and cables. You add shelves and balconies, and some shading elements and greenery. So let's look at some renders now. So this is how the refurbished facade looks like. This is a competition, so hasn't been executed, but this is what it was supposed to look like. Another view. And this is a close-up view. Secondary skin with some plates, some natural and artificial shading elements, and a holistic retrofit solution. Now, environmental analysis, solar radiation, summer, winter, sunlight hours, summer, winter, windrows diagrams to find out which is a prominent wind direction where natural ventilation will be efficient, air quality, noise, wellness. All these studies were done. Useful daylight, the existing facade with blinds up had a 48.5% UDI, with blinds down 16.2%, and the new proposal, the UDI is 69.5%. So it improves the penetration of light, and hence reduces the load of lighting on the building. I mean, artificial lighting inside the building. Again, solar exposure studies, the area within the red triangle, like similar to a triangle, is most exposed area on the lower block, and most exposed on the top is that area within the black box. So again, informed secondary skin layout. Based on the analysis results, you can see on the picture on the right side that the density of shading elements, balconies, greenery is correlated to the results to that triangle-looking area. The density of the elements is mostly in that region. So I'll switch to the last project, which is Atlassian Central in Sydney. EOC is the structural and the facade consultant on this project. This is how the building is located, oriented with respect to north, and it is right next to the Sydney Central Station in the business district. Fact file, building height is 182 meters or 40 stories. Planned dimensions are 35 by 65 meters. It is the world's tallest commercial hybrid timber tower, and with a reduction in embodied carbon of up to 50%. This building will operate on 100% renewable energy from day one and include solar panels built into the facade. Now, this picture is the most remarkable thing about this project, according to me. So these are the volumes of various structural materials: 9% steel, 19% RCC, and 72%, more than 2/3 of a 182-meter tower is timber, mass timber. Some renders generated by project architects, that is shop architects in US for this project. System overview, gray is concrete, red is steel. So there's a concrete core, there are mega columns, and then there are mega floors. Now, why are these called mega floors? Because on each of these floors, there are 4-story wooden buildings, mass timber buildings. Next, there is an exoskeleton that wraps around the building, and then there are transoms that are supported on the exoskeleton for the facade. Facade layout on top left. So blue is your thermal envelope, and gray is your wind and rain screen envelope. The habitat or the wooden buildings inside, 2 sides of it are connected to the blue area, and 2 of them are not connected to the exterior. There's a space between the exterior envelope and the wooden building envelope, as you can see over here. So what is this space for? This space is for a beautiful garden, or as the architect calls it, the park, and this is a render of it. So now you can imagine a 182-story tall building with such features is something which I haven't seen before. Ventilation analysis, finding the predominant ventilation direction based on weather data and providing louvers in the building to activate that natural ventilation. So the exterior facade has a lot of openable louvers, fixed louvers, and normal windows. Energy generation. So this is a shelf, something that we call a shelf in this building. You can see on the facade, there is a top glass panel, there is a bottom glass panel, and there is a shelf in between on which the photovoltaics are installed. Now, if you look at the render, this is where you see those photovoltaics. Again, a lot of analysis was done to find out the PV yield results per floor and optimize the placement of solar panels. Inclination studies were done to find out what is the optimal inclination for the solar panels and accordingly install them. A graph which shows the effect of shells on solar radiation. As you can see, original is orange, and the shells, they provide a platform for the solar panels to be installed, and they also provide shading, so there's a reduction in the solar radiation. And the last slide is a video of Atlassian. Thank you.
Thank you very much, Sushant, for an excellent presentation.
Thank you.
It's very interesting to see those case studies and those advanced computational methods that you showed us. Next up, we have a presentation by Shuko, where we have 3 speakers, not 1 but 2, but 3 speakers who are presenting together, which is Innovating for the Future. Please welcome on stage Dr. Omkar Powar, Kushagra Awasti, and Mr. Pratik Doshi.
So, good afternoon, all of you. I am Omkar Powar. I take care of innovation activities for Shuko India. Today, I want to discuss with you all what are the megatrends, especially the megatrends which are driving in the building and construction industry to innovate more, so we can boost up the profit and the growth of the building and construction industry. So what are basically this? So we define megatrends as the trends which are interacting or having interface with each one of us here sitting here. For example, behind like say 20 years ago, we were dealing with the buildings which were in the range of say 15 stories. But today, being part or design a building with 30 plus stories is the thing which every one of us is accustomed to. It's not something new. So the first trend, high rise and urbanization. Then comes sustainability. This growth which we have achieved, it has come at certain cost. Today, we as a building and construction industry are consuming 40% of the total energy demand of the country. So we can't continue in this fashion. The growth in this fashion is not sustainable. So each one of us here have to design our products or have to select the materials, else giving the due considerations to this megatrend of sustainability. Then climate crisis. Climate crisis is not only limited to the global warming or rising of temperatures. It is more about the uncertainties in the rainfall or the intensification of the cyclones which are happening. What we saw in Himachal Pradesh, the cloud bursting. So it's all related to that. And today all of our products has to be designed to cope up with the demand put forth by this climate crisis megatrend. So that is the third megatrend, followed by the megatrend of freeform and bionic design. No one of us wants to be limited by the traditional linear shapes. We want to go into the parametric design, as Sushant said. So that brings us to the freeform and bionic megatrend and of the currently. And last but not least, the real-time data and AI. Today, we all are convinced that at the wristband in our hand, when it pops up the message that, yeah, it's time to take 100 more steps to compensate for the calories you ate for the gulab jam, that we all are convinced now. So that is true with the human health, increasing the life or design life of the human body. Same is true with the buildings. And this is what is the fifth and the most mega trends which are there. And I want to point out that Shuko is driving to work and is working in all these mega trends or all these aspects of driving the innovations. So today I want to focus on the aspect of sustainability. So again, the sustainability is a difficult nail to drive on. It is very dependent upon the perception based, because one may say sustainability is regarding to the recycling of the element, whereas someone else comes and says that, no, it is about the energy embodied, carbon embodied. So it's perception based. So what we think at Shuko, that the best tool available currently with a designer is the whole life cycle assessment, where we give the due respect to each stage of the life. What is the performance of our product in each different stages, starting from the fabrication till to the credits. So based on the literature available, these stages of life are classified into 4 main stages, stage A to stage D, where stage A deals from the ore or mining process till the product is being installed. So this phase is defined as stage A, whereas stage B is more to do with the building operational efficiency of the particular product. Stage C deals with at the time of the demolition or deconstruction, more perfect word is deconstruction. So the energy consumed during that phase of the life is stage C, whereas the stage D deals with the energy consumed or the carbon emitted during the stage of the life when it is being recycled or obtained from the after demolition, obtaining it and reusing and recycling it comes under the stage D. So this holistic way of understanding the particular product is what we care about. And there are many terminologies existing in market, like cradle to gate or cradle to you can say upfront market. All these terminologies are trying to address only one particular or 2 particular phases of the life. But what is most important is cradle to cradle. The whole circle, completing the whole circle is more important. And we at Shuko believe in taking that extra mile and going to design for cradle to cradle process. So about what I have told till now. So how do we do it? So at Shuko, we have a carbon control a holistic approach where we have defined our strategies in 4 different modules. Module 1, where we work for design to decarb, where we empower our partners with the information which is very critical in the stage 1 itself, at the sketchboard stage itself, what is required. For example, powder coating is more or energy consuming, how much times more, and all that information is available at the tip of your hands, and with the in-house tool which we provide. So that is designed to decarb, module 1. Then we have module 2, build to decarb. On this aspect, we are covering stage A and stage D, which I explained in last slide, where we try to bring up the solutions like ultra low carbon or low carbon aluminiums. These are nothing but the modified forms of the recycled aluminiums. We are trying to bring that kind of a solutions, along with the solutions like hybrid systems, which Sushant again pointed out. And I will be focusing more on to that particular points, like what is this hybrid, why hybrid, and how it helps into the sustainability aspect. So that is build to decarb. Then we have operate to decarb, where I feel that Shuko is already strong. We are performing, or we have the products to give the building efficiency or bring down the building efficiency by having the smart products like smart building controls or integrated lowers. So that is the module 3. And the final module, which is recycle to decarb. Here I think our IOF tag, that is Internet of Facade tag, plays a crucial role. It allows us to see today's buildings as future store for mining. So that is nothing but we consider as urban mining. So that is how we complete our 4 stages, which try to bring us or give us the whole holistic approach or cradle-to-cradle approach, and this is how Shuko is strategizing itself. So, as I said, I will be giving brief about hybrid structures today in my short presentation. So here, when we say hybrid, the first thing comes into mind, timber. The reason for that is also very clear. It is the only building material which has negative embodied carbon. As you can see, it's minus 1.27. And the reason for this is the sequestration process of the carbon. During the photosynthesis process, the carbon is actually entrapped into the timber when it is formed, and it is kept out of the life cycle when it is being used. So that is the unique advantage which timber provides over all other building materials. The another question can come is, can it be engineered? Yes, it can be, it has the possibility of reducing the carbon, but can it be engineered? Any material, when it is being used, it starts its phase from being used as an aesthetic material, then starts taking the load, and finally becomes a member which can take primary load. So starts walking, jogging, and then running. So today, the timber is already running, I would say, because the advanced versions like cross-laminated timber and cross-laminated timbers are capable of taking the multidimensional loads. Initially, what happens, the wood, because of its cellular structure, has the possibility of taking linear structure. It is more strong in one direction. But because of this cross-laminating, it is capable of taking the multidirectional and multi-axial loads as well. So along with the advantages of reducing CO2, reducing the weight as it can bring the weight drastically, somewhere in the range of around 60% the weight can be reduced of the structural components. So yes, it can be engineered. You can see here, it's not only a single residential story, but bespoke engineering design can happen. This is another timber hybrid structure where the principal or primary structures is made up of timber and facade is made up of aluminum. This is an Shuko project where it was, the material consumption was brought down by 40% and CO2 was brought down by almost 80%. And so that is the impact which can happen. This is another 80 meter high timber structure. This is the inside, which is primary components along with the secondary elements, you can see like handrails are also being made up of a timber. So basically where I am taking you all, why I am telling primary structure, secondary structure it is made. I am trying to make a point that soon there will be a need coming from the architects that we want timber to be used in facades. And that need, we have sensed it, and at Shuko we have a product which can systematically accommodate wood or timber into facade systems. We have AOC system which can accommodate the variety, face widths from 50, 60, and 75 mm. We can have the glass varying thicknesses from 6 mm to 70 mm, and the glass weights can be of 1,000 kgs. So we have the system for you now. So that's what I was trying to come to. And for more details about AOC, we have a booth outside. We can come and discuss more about it. So to recrystallize and confirm, emphasize that, we discussed about the mega trends, which are the mega trends, and each of these mega trends Shuko is working. I tried to highlight one of it, but each of them we are working at it. My colleague Kushagra will brief on to the mega trend of freeform and Bionics design. Thank you.
Thank you, Omkar, for giving insight on sustainability and talking about the mega trends in construction industry. This is a marathon presentation from Shuko, so it's a back-to-back, and my colleague will come next. But I would like to tell you, I'm having a wonderful day here in Hyderabad. I mean, some really good presentations I've been seeing since morning from the architects and the consultant, and for me, the story is already built up. So I don't need to speak about anything to create the story. So I will be focusing on the freeform and bionic design. This is one of the megatrends that Omkar has left with. This has connection to what Sushant was talking about earlier, and plus the presentation that we saw in the morning. So just to give a little insight, how and from where we started. So around 40 years ago, even the architects and engineers used to use the drawing board, you know, the grid lines, change the grid lines, do the changes only in the paper. There was no tool available, you know, to visualize other than the board itself, right? So it was a very tedious process, I would say. So there was no kind of experiment being done, so the designs were kept very simple. The only experiment that people were doing, or the architects or the engineers, was exactly on the site with the materials or with the design itself. So there was no chance of making complex structures, right? So all the designs from the architects and engineers were put up in books and papers and then stored, right? But things has changed, you know, in all these 40 years, and especially in the past 10 years, the world has evolved, especially in the architecture and engineering field, and we have seen a lot of trends in the geometric forms. So I would like to discuss the recent trends in the geometric forms, a couple of which you saw earlier in Sushant's presentation also. So this is a kind of extruder building where the floor plan is the same. It is just extruded vertically, okay? Then comes the rotor, where the floor plan remains the same, just the size varies. So you can, you know, taper it up, or, you know, taper it down, or maybe keep cylindrical and then taper it. So that's the one of the geometrical form. The third one, the twister or tordos, is something where the floor plan is the same, you extrude it, and you rotate it in whatever angle, dimension, as the analysis was shown by Sushant. So based on that, it's you know, the geometric form is given. Then comes the last one, which is a free form. I wouldn't say that there is no design principle behind it, because there is a really good design principle behind it, but the thing is, there is no a set principle, or there is no line that has to be followed. So it is completely free, okay? So these are the general design trends in geometrical extrusion. Now I'll come to the third point, fifth point, I would say, but it's a subset of the free form. So this is basically a simple floor plan, which is just extruded, given some dimensions, tapered, tordos, twisted, extruded, everything is there. Then comes the modularity part. So all these things can be, you know, done in a small modular part, and then it can be populated. So there is a lot of space
that has to be utilized, right? So in order to utilize the space better, a small module is optimized, and the same thing is populated. So this is one of the parametric tower exploration by Non-Nicholas. There is one living example of Market City in Toronto, which is done on the same principle, okay? So this is where the architectural, the architects basically are going. So what has happened and what has led to this, this kind of exploration by the architects? So they are basically using different scripts, so they have become like coders. The architects has become like coders, so this is basically a Python script. Then we already saw a Grasshopper script in the previous presentation by Sushant. This is just to give you an example. Now, the third part, what is the future? And this is really happening. This is the AI in architecture, which is really happening. And it's really amazing. You know, you can design, optimize, and visualize at the same time. You can do any changes, whatever you like, whatever you feel, you can play with it. It's like the computer is thinking, a computer is generating, and you are thinking, right? So it gives you a big scope of developing or thinking or designing anything, right? So this one is AI prompt crafting process where this building is designed. This is by an architect called as Sahil Patel, and this is where the future is, okay? So coming to the next point, I mean, what are we as engineers doing? So we have a solution for such kind of free-form and binary design. This is Shuko G2S, or grid to shell. This is, you can call it as a facade, you can call it as a skylight, you can name it whatever you want. So this is a completely self-sustained kind of a building structure where the first skin of the facade doesn't need any secondary structural element. So it is just self-standing structure. So this was from the outside, and now this is from the inside. This is already an executed building. If you want to speak about this more, please feel free to speak to us on the booth outside. So, I mean, this complexity is already reaching Indian shores. We have already seen it. And this is one of the example of IPL building in Ahmedabad, Indian Potash Limited. The other one is one in Hilton Hotel in Kathmandu. This is, doubly curved facade, so you have a convex and concave system inside one building, and this has been addressed with the same facade system. So we don't have a separate facade system for concave system, we don't have a separate facade system for convex, both are integrated, so same linear facade system is there to incorporate both the curvatures, inside and outside. Then we are also in designing basically another project, which is basically a geodesic dome. These are two domes, which are converging on two eccentric points. So this is under the development. So what I'm trying to say is this complexity is already there. We are being challenged as engineers. We are being challenged to address to the facade system for this. The architects, they have the computational horsepower to. You have already seen, right? So they have the computational horsepower to innovate for these megatrends. So what are we as engineers doing in to realize these designs, right? So what we at Shuko do is we see the complexity from another perspective, okay? So when I say that the complexity is a challenge, and how do we do it? We break the entire complex system into subparts. So there are various elements going into the facade. So we attend to these complexity and try to visualize them and try to analyze them on a smaller scale. Right? So we get a lot of input, a lot of insight when we go into each and every part. Just to give you an example, just let us start with optimizing structural design. So what you see here is the first step of optimization, facade optimization, which is basically a floor height, which spans from 2.5 to 4.5 meters, and this is the mass of aluminum that will go in the consumption. So we have, just to get an idea what should be the target cost of this project. Then we go into the optimization of the stack height. What should be the optimum stack height? So is 600 optimum stack height for the facade system? And then what will be the consumption of aluminum if you are going for the particular stack height, right? So the least consumption will be there. So this is based on a study done by engineering students in the university. And then after that, what we do is we have a couple of tools available where we optimize the profile sections, right? So every element, every node of the profile system is analyzed to a certain condition. And then we have developed a wide range of cost-optimized project solution, I would say, to offer in the project, okay? So it is compliant, technically compliant with all the technical specifications because it has been designed for that. And then it is cost effective because we have done value engineering and cost optimization for the same. So this is how we deal with this. Just to give you an example further, this is one of the projects which is under execution. So the designing has been done. This is really complex. As you can see that the building is little tapered, and then you have this V section, which is really complicated. Really complicated. So this is basically a Shuko render done by our team to inform the architect how the grid lines will be and how we are doing it. So there's a lot of engineering that has gone into it. And just to give you an example of it, so the entire 17 to 18 floors of the model was done in a software for a structural 3D analysis. So just to give you an example of what Shuko is doing. Then second example I would give, I won't take much of time. Second example I would give is the drainage system. How do we do it? So this is one of the, again, a complex building where the facade was inclined. Then how do we address to the drainage into it? Because the facade is already inclined. Then we came up with a solution where the gasket system itself will have an additional 2-degree taper where all the water ingress that is coming into the facade is, channelized outside in a controlled way. So the drainage has to be controlled. So all these studies, all these experiments we are also doing in computational world and realizing it. So this is already an executed project. Then in the end what we do, so you saw 2 examples, one structural and one drainage concept. Then in the end what we do, we integrate everything, right? So we kill the complexity by chopping it off in smaller parts, and then we integrate it back again. We also offer a couple of solutions to architects and consultants to help them visualize what solution we are providing. So this is one of the example of the skylight. So the skylight, we have opening out angle and opening inward angle. And we give them the solution and we explain them all the principles, like how structurally it is working, how the drainage is working, and everything. So this is how we visualize and tell them. So this is how we are progressing in the things that we are challenged by the architects in the freeform and bionic mega trend. And my colleague Pratik will now take up hereafter. I'm sorry, again, you are left with 2 minutes, but unfortunately.
I'm prepared for it. So, thank you everyone, and thank you Kushagra for giving a great presentation. Thank you Zak World of Façades. Thank you to the audience who are very attentive today. I have found the most silent and most attentive audience this time. Thank you very much to everyone. So since my colleague Omkar discussed about what is the culture in Shuko about in understanding to design to decarb and all that decarbonization and understanding complexity, Kushagra explained about his engineering team capabilities of handling complexity in engineering, as he has a big team and it's growing to handle the complexity. I'm here to present something which we have implemented on ground. I'm sure that's the most interesting thing which we would like to see, because a lot were theory and this is the climax now. Okay, so while we have a lot of projects we have done in Façade since 2017, I'll say. Before that we used to do 1 or 2. Since 2017, the story of Façades in Shuko actually started. So I have selected a project which is near to where we are, and that project is, one second. Yeah, it's One Hyderabad Park, and it's a prestigious and a very lavish residential building where we have done our facades, what we have designed. So basically, I thank Facet and CS and KS Group for giving us this opportunity and trusting us on this. And I thank very much for Almec for handling this mammoth task of actually fabricating and installing this elephant. Because really this product is maybe a mammoth more than that. So the bigger challenges in this project, this is a residential project but having facades. The challenge in this project was integrating a unitized facade with a slider. Now integration is okay, but along with that challenge we wanted concealed drainage, The architect and the consultant wanted, glazed look from outside, and that made it a bit difficult to actually manage, and there was some intent to be followed. So we were like pushed hard in actually designing the right way. So the complexity how we handled was, we smushed two products, a unitized facade and a slider together, and we had to make it seamless transition between that. So how we did it? We achieved it with profiles concealing it, okay? We achieved it with the interlock actually matching the mullion line and concealed drainage. How it looked like? So what we had to do is, we made one profile out of three. The three profiles are the starter transom, okay, the slider outer frame, and the gutter profile. All were extruded as one profile to handle this. And this is a floor-to-floor unitized integrated facade. Now, I understand, since a lot of people, a lot of consultants do talk about and do ask for a slider integrated solution, and there is no one product, okay? Every product is based on the different requirement of the building. So I suggest please involve us at start so that we can give you numerous solutions, because there is no one catalog product, and the Shuko engineering team can handle it if we are given time and give you a proper solution with the most optimized way. This is how we managed an interlock. You can see on the there is a slider, okay, and the glass is pasted on the face. So you have a 10 mm sleek aluminum profile coming out, which you can push and slide the slider. And if you are 10 meters away, you will find everything is glazed, and you won't come to know it's a facade or a slider. Sorry. Okay. This is the meeting style which we look inside. Okay. It's also a kind of a profile which is sleek, and you can ergonomically handle it and open the slider from inside. The intent versus reality. This is, on the right side is a 3D rendering of the project. On the left side is what it is finished, and it has come out beautifully, and it is, you can get in touch with our Hyderabad team to have a look at the sliders. It's performing excellently. Okay, now I just have 3 slides to finish. So this is a project which is at Ahmedabad, where we had to we have to handle the complexity because of the kind of sun shading the architect required. The facade was difficult because of 24 corners in the smallest building, so we had to maintain a lot of profiles inward and outside corners, and also with the angular fins to achieve the sun shading possibility. We almost made 13 new profiles there, and in the earlier project which I discussed, the One Hyderabad Park, we had to make at least 20 new profiles and to serve the purpose. Then we have Bluegrass Commercial Pune. The requirement of the curved facade is increasing day by day, because everyone wants a different kind of shaped building. So it can be achieved by a female facade available at Shuko. We have almost 4 to 5 designs available, and we are ready to even make some new designs if the design permits and the volume allows us. Then there was an architect who came. This is the last slide I am giving. There was an architect who came to us and said that he wants a facade with cap, a unitized facade with cap. So we came up with a solution that why with cap, like I'm bonding the glass and then putting the cap, I'm wasting too much. Why not I remove the silicon bonding and I give you a cap with a groove which will look uniform. So we designed a system which we already had. We designed a male-female system to give exactly a facade where you don't require no silicon bonding, and the glass is actually taking care, the glazing bead is actually taking care of the glass. So the facade panels are made like windows. Okay, so it is completely silicon-free, 25-story building installed and already installed since last 1.5 years. And these are few projects which are there already installed in Hyderabad. You can have a look. These projects are since long, and we are ready to handle these. And we have a stall outside. Please do contact us if you have any such requirement, and please involve us on time so the engineering team at Shuko India can handle the complexity, and we are here to implement the complex project on the ground. Thank you so much. Thank you.
Thank you very much, Team Shuko, for a very exhaustively interesting presentation with a lot of technical details, a lot of interesting subjects that were all covered by all 3 of you. So thank you very much for that. Next up, we have Mr. Mehul Patel from C&T Architects, who's going to deliver his presentation on context, scale, typology, and facades.
Thank you, Ron. I've changed the topic though. Yeah, so my topic is slightly different than what Rohan said. It's going to be building envelope evolution. Now, it's going to be a very architectural presentation. I have not really added much detail into this one because I just wanted to explain how architects at CNT really think about design and building facade. For us, building facade is not a separate design. It is part of the concept design and how we evolve the entire building itself. So I have captured about 4 different case studies. 3 of them are from Bangalore, a completed project and 1 proposal in Hyderabad. It's largely showing the diagrams, how we evolve the project along with the facade. And then eventually we develop into a more detailed facade. So brief introduction to CNT. CNT is one of the oldest from in South India. It's probably the oldest in Bangalore. It started in 1950. Though it's an old firm, we are very young. A lot of young people are working in CNT. And across that many years, we have done multiple typologies of work from industrial to institution, corporate, residential. So we are lucky to work on all typology of project. Whenever we work on a project, we always start project with the proposition, strong idea or aspirational statement about life, and then convert that into diagram, architectural diagram, an explicit architectural articulation capturing the spirit of the proposition. So in my presentation, I'm going to show more of diagrams and how we evolve the initial stage of the building. So this is a recently completed project, MSR North Tower. So site is located on a ring road very close to Manyata Tech Park with a lot of low-rise development on 3 sides, and 1 side is Manyata Tech Park. So that's the odd shape of a site. So we got a very site which has a lot of issues in terms of boundaries and how no jagged edges are there. And client's requirement was to look at something very geometrical, such a way that they get a certain level of efficiency in a building. So that's the building setback. Because of the odd shape, amount of footprint we get is very little. And then the requirement of geometrical building. So we thought that let's not kind of look at the standard geometry where we look at rectangle or no any other shape, but let's try and juxtapose the octagon with the site boundary and see what shape we really get. And then we have done a certain level of conceptual diagrams, and finally this is a diagram we have frozen with. So it has an overall, virtually it has an octagonal shape, but then it kind of get cut based on the site conditions and how we really plan out the areas. What we achieve by doing that is at the ground level, we achieve a very large open space, and we practically didn't put any of the office spaces, any other program at the lower level, just put the bare minimum vertical circulation and services, allowing the maximum flow of the landscape at the ground level. At the typical level, we look at the building which opens out onto one side, and then other side we have the services and a vertical circulation, a place to kind of block the side. At the topmost level, we kind of played with the height such a way that we can create step terraces so that those terraces can be used as a cafeteria and other common amenities which opens onto the northeast side. Now, doing that kind of a shape, we get a complete protection on the western side and the southern side, such a way that we protect the building by putting the solid layer of vertical circulation, lift and staircase, as well as washrooms. And then the north and eastern side is completely open. That's where we look at the large, the glass facade. So glass facade on the north and eastern side is the largest one. And then on the western side or the southern side is a minimum, which is protected to the deeper opening over there. Now, this is primarily to say that before we get into the engineering of the facade, I think we need to take care of the facade at the orientation and the position level itself. So that's the whole idea. Second diagram and third diagram just showing the spatial organization, how the floor plate can work as a whole, as well as it can be divided, and how the views are captured from different sides. So that's a general layout, not getting into detail because this is designed as a multi-tenanted office. The people will design in a different way as they want. But idea is to kind of show them the idea that everything should be open onto the northern side and eastern side such a way that it's all protected from the harsh sunlight. That's the ground floor, just showing the free spaces we got because of the smaller footprint. So evolution of the facade is No, practically we take the octagon and then give a 3-dimension, which is a 60-meter height. Then we start cutting the building such a way that we capture the maximum glass on the northeast side and then the minimum on the western and southern side. Now, that's a further evolution. So we keep evolving that based on the different parameters. At this point of time, when we kind of started getting closer to the overall form, we also decided to look back to the certain natural element, and we referred to few and finally picked up this interesting image. This is a rock outcrop near Udupi. We also see something similar in the northern part of the Europe in some areas. So what we found interesting that how this natural stone is really there. So it's kind of a formation because of the volcanic activity. So we thought let's use this kind of a lines and then develop the facade. So that's a further development. We started playing with the height, and then finally we kind of come up with this final layout or final facade. And of course, this facade was done along with a lot of exploration in terms of how it works in the Sunpath diagram. We have a technical team or technical consultant who help us getting the energy simulations and the Sunpath diagram studies. So based on that, we finally worked out this thing. Of course, then to support with the appropriate material, so we did multiple exercise on the material. And that's the final aesthetic. So that's the rendered views. So that's first image is on the western side, and then the second image is on a, sorry. Can't go back. Okay, the first image is on the western side, and right side image is a northern side facade. So northern side has a larger amount of glass, which is very protected because of the shape of it. And then the west side is protected because of these solid masses. That's the entrance view. I'm just running through some views now. That's the project is still not documented, but these are just work in progress photographs, so we still have to document. Yeah, that's the western facade as a north facade. So typically, I mean, we got a lot of feedback while this is the western side is the front building, and a lot of people were surprised that why glass is used on the back side of the building. But it's completely because of the climate, and when we explain them, then they realize that no, rather than just looking at the aesthetic of the building, it's important that we look at the aesthetic in a true sense, how we respond to climate and context. So that's the project. Second is university project. Of course, this is not a high-rise project, but would like to show it as a general attitude and approach to the facade when it comes to the larger master plan. Because most of the time we have an understanding that when you have to look at a tall building, the facade is important. Shorter building, we don't have to pay that much attention. But here it's an entire campus, and we kind of worked out the facade which works as a whole. So quick introduction to site. Its site is about 56-acre land outside Bangalore city, and it was a largely barren land with the quarries on two sides, and the site is sloping onto the eastern side. So yeah, that's the general condition. We have to respond to the slope, quarry, lake, and the noise coming out from the existing quarries. So general intuition was that we should start the campus planning, which is largely the central spine base. So we defined the spine, and then we thought that rather than working on the built mass, let's start working with the voids first. So we identified the required void for the university campus. So things like a large play field, cricket field, one maidan which can be used as a multi-purpose play area or event place, an entry court which is more of the first impression to the campus. So we looked at defining the void first, and whatever space is got after that, then we started looking at those as a different department and different solid blocks. So entire master plan was broken into this kind of a multiple node. Red ones are the primary nodes placed along the spine, and then the yellow ones are the smaller nodes which probably represent the departments. And again, we looked at the void to solid kind of approach. After defining those nodes, again, whatever area we got, we started filling in the building. Now, of course, we did the scale exercise. We exactly know what is the size of blocks we require, and then we started putting the block. Now, when we looked at the block, the first intuition is that orientation and the location of the building should be such that we prevent the harsh sunlight from the south and the west, and then maximize the opening onto the north. And that's the reason we looked at all these linear blocks going from the east to west side, opening the majority of spaces onto the northern side. And even when spaces really look at onto the south side, no, it will be protected. Then we need to work on that. That's the general solid void diagram explaining the master plan. So you can see the proportion of the void and the solid. No, it's equally distributed, and no, none of them are really overpowering. And we have given the large amount of open spaces as an experience at the campus. So that's the diagram explaining the central spine, which has a lot of common amenities, and the gray areas where we have largely the study spaces. Now that's the general master plan level. We look at the certain solid and void exercise such a way that we capture the climate well and then develop the facade based on that. So we set up the parameters for facade in a very beginning. Now similarly, when we look at the part to whole, we need to start looking at the building design. So that's the minimum size of the block we require, which is broken with the large courtyard so that we can take a light and ventilation and minimize the thickness of the building to maximize the natural light. And practically all the spaces should have a natural light and ventilation. Then we further break it such a way that we allow the higher amount of cross ventilation across the building. And then we start looking at the program. Now program distribution is mostly the classrooms are at the higher level because they are more private and they require more concentrated inward. Shared spaces and the office, the staff office, like a teacher's office, are at the lower level, such a way that they become more interactive spaces and they efficiently use the courtyard spaces. Of course, this is in Bangalore, which has a much better climate than Hyderabad. So, and then we start multiplying these departments. Then we work with the building height such a way that we can also create a lot of terraces at the on top of the building. So the end conditions will become taller and internal spaces become lower, so that the taller building can open up onto the terrace. And in Bangalore, the terraces are very successful because you can actually have outdoor classroom in most of the weather condition. Again, certain study in terms of how the void proportion and the solid proportion should be such a way that we can create the mutual shading in the courtyard, such a way the courtyards are occupiable throughout the day. No, except probably a couple of hours in the afternoon when the sun is right on the head. But 3 o'clock onwards, we can really occupy the courtyard, and that's how the distance between the building is really set. And finally, coming to facade, once we set up all these parameters, then we get into the development facade, which react to this initial diagramming. So the face is largely blocked because anyway we are not looking at the longer facade over there. That's largely short facade, and we can have a very small punctures with a bare minimum as required. Northern facade is completely open. We look at maximizing the glass. Some protection is required for the rain more than a sun. So rain protection is given. On the southern side, we go for the deeper protection, such a way that we protect the sun coming at a certain angle. So that goes across the entire campus, and that's how the facade looks. So that's the western facade where we have looked at, no, sorry, this is the southern facade where we have looked at this fins, and then we kind of created play. And we created certain void such a way that, I think you can see it in this area. So certain voids are created, those act as a semi-open terraces over here onto the southern side also. So in a good weather condition, even students want to come out onto that side, they come out under the protected area with the greater view, and then we have those terraces can be occupied in a more informal way. So in terms of development of the facade, the upper level of facade where we have classroom, where we have looked at the higher protection with those fins, and the fins are played based on the part of the classroom. Where students are sitting, it's slightly different. Where the teacher is sitting in the blackboard, there probably it will be slightly different conditions. So we worked on those conditions. Second part is the intermediate space, where we have looked at a large glass facade with and in a certain condition semi-open spaces. Here we did not require protection because we looked at these as a spillover spaces and informal activities. Those students after class hours, they can just come out, sit in a semi-open space. Probably they can talk about some thing about the next class, or maybe last moment homework or something they want to finish, they can do there, or they can do preparation for exam before getting into the exam. And then finally, at the lowermost portion, which is more of a technical area in this part, because we are looking at a lot of labs, chemistry lab, no civil lab, biology lab. So in that case, we had to work with a smaller opening because there are a lot of equipment, a lot of storages are there. So we worked with the deeper openings over here. And then we have given the stone texture such a way that, no, there's a better feeling when you're walking around the space. So it gives a very natural feel to that. So that's the facade of the building. That's the central courtyard. Of course, right now it's only the phase 1 building is done, so it looks slightly incomplete. So that's the character of the courtyard, where we look at the central courtyard with a lot of hard surface. Wherever the level difference is that we have amphitheater, spaces are directly opening into this one. And then we have a large trees coming into this one, which will create the shade. This photograph is taken somewhere around 1 o'clock. So you have direct sunlight. Otherwise, it's kind of a shaded space most throughout the day. And at the upper level also, we have a lot of these semi-open spaces or corridor which look down into the courtyard. So that's the intermediate terrace we talked about, so where the building height is varying and then create the informal spaces for students to occupy. That's a central space where we looked at the clear glass or the glass-less facade. So that's the campus design. So this is the first building we made in the campus which set up the general guideline how the overall architecture of the building should be done, and then it's open for multiple architects to design how they really design. So it's a campus is designed for multiple designers. Residential project in Bangalore. This project we designed about completed 10 years back. That's for the developer in Bangalore. So here, it's a curved building, and many people think that no, it was designed as a curved building. But when we started the building, it was never thought that we'll make a curved building. It came through the certain evolution of the plan and how we looked at the response to context and the climate and the vista. So initially, when we designed the building, of course, it has a very geometrical, very orthogonal kind of a geometry where there are two layer of units are there which are looking into two different directions with the central circulation. And then it has a certain large openings which kind of act as a common amenity spaces. But then we felt that no, the kind of context we have a very low-rise context, and we have a vista, possibility of vista all around. So we thought that let's not look at the same kind of the view for everyone. So we looked at the inside to outside kind of approach, and then how that approach really affect the aesthetic. So the first diagram is showing that typically we look at units which are parallel walls, and it goes like this. And then we thought that let's kind of change the angle and capture the vista. Rather than going for 180-degree view, let's go for 270-degree view. Along with that, we also looked at idea saying that can we also capture the idea of green on every floor, where everybody gets angan, and no, they can have their own greenery on terraces, irrespective of what floor they are on. So based on all this diagram, we started evolving the rectangular buildings. So first, the linear blocks were broken into two square buildings with the core in the center. Then we changed the layout such a way that we capture the vista all around. Now doing that, what happens is in the central place, this area, what happens that units start looking into each other and cores get very disconnected. So in that case, we start removing the unit from here, and then open only units on the outer side, and central portion can become part of the core. So we kept evolving, putting multiple butter paper on it, and then finally we came up with the diagram where we rotate the unit like this direction. So we create the central space which is through and through with the core in the center, and we look at the three units which are opening onto the outer side. So that's the development of plan, which kind of start giving us a certain kind of elevation to that. So getting into the detail of the plan, even when we look at the one wing, we thought that when you're looking at outward, the outer space should be completely transparent, and we should look at the clear glass and the balconies over here. But the inner side, where we have this dark line, that's where we put all the services. So that's how the overall building envelope is worked out. So that's the diagram putting all the units together, how it works. So diagram shows the glass on one side, view on other diagram, green on the other diagram. And finally, that's the overall layout. And that's the building. So facade is completely designed to capture the 360-degree views, and everybody is looking into a different direction. These are older photographs, but in the new photograph now a lot of green has started coming because people have occupied, so they started planting things in it. So that's more views. That's a central space again with the podium landscape. And the last project is a design proposal in Hyderabad. It's a residential project. We got a slightly odd kind of shape of a site, and we have to look at a very high density residential project over here. So that's the footprint after leaving the setback. We are looking at 120-meter building, so we need to leave about 18-meter setback. So we have looked at the conditions such a way that lower level can be public amenity, intermediate can be the residence, and at top level we can look at a public amenity. And then we looked at the diagram where the central space is in a lobby and 4 units looking into 4 different directions. Now, because odd shape of the site, building was becoming very odd shape, and we couldn't really develop the facade just by the plan to elevation approach. So in that case, what we did is that we took a plan and we started using the balcony as an envelope, and we started creating the layer around that. And then we thought that let's not make that layer as a constant layer, but we start playing the layer which varies. So in that case, we started playing this thing in a 3D. Now, while doing that, we also looked at that how we create this odd shape of a balcony as a very playful balcony with the green which capture the vista. So these are the views from inside. And that's a section. So once we start playing with the balcony, it kind of give a very twisted kind of form. The internal place, which is all the residential, that remains constant because that we cannot change. Of course, there are a lot of things related to the services and vastu, so there has to be constant. But the outer facade can be changed. So that's the lower level diagram showing that the entire ground plane is open as a public areas and capturing the the landscape on the ground level. And upper level, we look at the open spaces which capture the vista. So development of the form and then the elevation. So that's the overall volume we get, 120 meter in an odd shape. We break into 4 different tower, which is like each unit. Then we look at the very simple envelope around that as a skin. Now to develop the facade, we looked at again some of those natural formation of the condition. This is the place in Scotland, and we found this thing very interesting because it has a similar kind of a proportion we see in a residential tower, but it has a certain playfulness, how the layers are seen, how the green is a part of it. So we thought let's kind of have fun with the form here. So we took the simple form and started pulling and pushing, and then we started playing with the skin. And once we break that skin into the floor plane, then it started creating the different shape of the balcony. Because it's a residential project, we were not looking at the continuous screen because we didn't want to break the view from inside to outside. That's the reason we looked at, instead of skin, we broke the entire facade into the series of planes. So that become part of the facade. So that's the rendered views. So upper level is all the common amenities. We also tried, at the lower level, perhaps we can look at a lot of terrace gardens. So that's something we still have to evolve. That's it. Thank you.
Thank you very much, Mehul, for an excellent presentation. So next up, we have a very, very interesting panel discussion. And the moderator for this panel discussion is no other than the Managing Director of Shuko India, Mr. Shyam. Where is Shyam? I don't see him. Shyam around? Yeah. Oh, there he is. So Shyam, if you can quickly, briefly introduce all the panelists.
love to. You can hear me, I presume. We have a really distinguished panel here today, and I'm really honored to be part of that discussion. I will start in sequence, and we have two participants from the investor community, Mr. Venkatesh Nuna from Aurobindo, and Ms. Sarda Vemuri from Polomi Estates. And as we all know, everything starts with the money and what investors want. So I'm very happy to welcome both of them first. Right after that, I think we have two very distinguished people who take this investor intent and convert it into a concept that people need to execute. Very happy to have Mr. Vinod Kundargi, principal consultant from Aspect. Great, deep experience. And also, I think we had a panelist already earlier, speaker earlier, architect Sriram Ramakrishnan with that excellent presentation, who then take this investor intent and create the shapes that they imagined and want to sell. Last but not least, Mr. Vinod Binu, Executive Director at Land-Based Consulting. All this somehow, of course, needs to happen at zero cost, at the highest quality, and get done yesterday. And that is something we will hear from. So the panel topic is Challenges in Designing High-Rise Buildings with Glazed Curtain Wall. We'll go through each of the panelists. They all have extensive experience, a lot of know-how. And the topics that we'll focus on today, very broadly, is urban design and sustainability, facade and architectural intent and design and elements, construction and project management, and then safety and maintenance. So we'll swing between these topics and hear from our panelists what they have to say. We are, I think, all very well sensitive that we are standing, or rather sitting, between you and your lunch. So we will be sensitive to that fact. But I think it will be well worth it. And I think the hunger for knowledge will then transfer to the hunger outside. And we'll leave you with that. So thank you very much for coming, to each of you. Really honored to be on the stage with you. Thank you to the Zak team for giving us this opportunity, and really look forward to this discussion. So I'll start, I think, with the first question. We are discussing challenges in designing high-rise buildings with glazed curtain wall. My first question, maybe I start with the investor team. What is driving this trend for high-rise curtain walls in the city, outside the country? Any thoughts? And what are some of the challenges from an investor that lead to this not happening in terms of sustainability, high-rise? Any thoughts? What's driving it and what are the challenges? If either...
So we talk about sustainability. If we are looking at sustainability in terms of taking up for projects, there are pros and cons for both of them. The cons are that we have to initially put in a lot of money for the buildings. So most importantly, it's like we get in a new consultant that's called IGBC or green buildings. We put in money for IGBC approvals. We put in money for sustainable materials, then finish the product with a lot of investor amount or initial amounts. But later on, the profits are much higher for the person who's using the office spaces. And of course, also even there are added benefits for the person who is using the space in terms of there is less amount of money that they need to put in. Like, let's say we are energy efficient, plumbing is better, facade system is better because we are getting natural lighting, so many other things. So that is how sustainability is both new sustainable buildings have both positive and negative impact for an investor point of view. You want to take up
From owner perspective, we mainly look into the client requirements. Nowadays, the clients are, most of them, throughout the globe. They're coming up with the requirements, with the building should be unique, they require the full ventilation. There is so many requirements, they require so many amenities in the building. Then first, we'll also study the requirement and the place where we are going to build the structure. These are some of the preliminary, when we go with the preliminary concept, we'll keep in that mind. These are the very important factors. What is the required for the end of the day, we have to lease it out. Once we build, we are going to invest certain things, amount and the building. So end of the day, it has to be leased out with a certain premium also we have to get. So based on that, we will look into that in terms of the facade. I can say that in terms of spacing. When you call about the office buildings, particularly when I take the example of the office building, we go with either central core or side core, depend upon the profile of the building. Central core, definitely in the office building, central core, you will get all around the lighting. If you go for the glass facade, it is going to be, will get light is going to be, will get completely lighting. People of the clients, most of the international clients, they will look for that the building should be unique and what do you call that, staff from the organization should be work, they should be healthy also. That is, they will also look into the perspective. So some of the factors, these are the factors we'll take consider. And of course, the facade cost nowadays, if you can see that in the present terms, in terms of the costing, it goes 8 to 10% of the construction of the high-rise commercial buildings. We are spending on that. So, because why we are spending that, end of the day, the building should be unique, we have to attract the client, again, the same.
Great. Thank you, sir. Would any of the other panelists like to add, what are the key trends? What are some of the challenges in high-rise urban construction?
I would just like to add a completely different perspective in terms of design. Why generally the taller the building, the more we see curtain glass? I would actually break it down into like kind of 3 small points. The first thing is when you cross the standard height barrier of most of the buildings in the city, which means you are going beyond the skyline, you are actually opening up the views beyond the problem of privacy. So by opening up, you naturally bring in more value to the property, whether it is commercial or housing. The second is, imagine in terms of a volume. The taller a building, it's really physically not so good looking to keep repeating windows beyond certain number of times. Whereas curtain glass allows you to create a very simple massing that is very elegant. The last reason is when your building goes even taller. If you look at the 10 most tallest buildings in the world, 8 of them are completely curtain glazed. Why? Because beyond certain height, constructing it as a module is much more efficient with glass. And also the glass as a material can be conditioned to take certain amount of adjustment due to wind load, etc. This is naturally the tendency that taller buildings are want to have curtain glass.
Yeah, and to add on to what my fellow panelists just said, there's also one more point that is very relevant when it comes to why high rise, especially with the land value skyrocketing here in Hyderabad, and the government policy is also enabling us to go high. It makes more sense for a developer to invest in high rise so that he gets better returns on that. That's one more point which I just wanted to add to them. Thank you.
I had to add one point now.
Adding to that, going by high rise, that gives a aspirational value to whoever, that it be a residence or a office. When they occupy that, that gives them a aspirational value. And other thing is, by the data what we see, more than almost 50% of the population are moving towards the urban areas or cities. So when we go high rises, make better use of the space provided so that all facilities or travel time is reduced. There are many other factors, But on the other side, okay, environmentally it might not be so sustainable also. There are pros and cons to it. That needs to be balanced.
Great. You were saying?
I would like to add one point. There is always pros and cons in the high-rise building. If you can see the last 10 years, the last 1 decade, in Hyderabad itself, I'll just tell the example of the Hyderabad, we have built around 60 plus numbers high-rise. High-rise means I'm talking about the 100 meters and above, which includes the commercial and residential. Last 10 years. Now the coming next 4 to 5 years, the 90 numbers of high-rise buildings is in progress. So the city is observing that high-rise, the people are, in terms of either residential or commercial, there is a huge demand in the Hyderabad, particularly is going to be a huge development. Out of that also, there is a 35 high-rise buildings of more than 150 meters height, which are going to be come in the next 5 years. So it's going to be a huge demand for the high-rise, definitely. There is a lot of pros, but still there is a growth in the high-rise, huge growth in terms of either residential or commercial.
That was really insightful. I mean, what I took away was there is an aspect of urban movement, people moving to the cities. There is an aspect of open spaces, surprisingly. When you go higher, you get open. There is a question of flexibility in design. There is that issue of wellness, giving more light. I think that came out. And then at the end of the day, I think by doing better designs, high-rise designs with curtain wall, you're able to attract people and get more return for that investment. And I think at least in Hyderabad and the other cities that we see, this trend is only increasing. Also in, I think, the so-called tier 2 and tier 3 cities. And you're right, I think this trend will just keep going. I think some of you mentioned, and I wanted to pick up on that point, there are some cons. And this is not a sales session on high-rise buildings. I think two panelists, I think, Vinod sir, you mentioned cons, you mentioned the cons. Maybe that's a topic, I actually had that question, I was not going to touch it. Both of you mentioned it. What are some of the disadvantages of high-rises and with curtain wall? Maybe not in the short term, but maybe in the long run. You have seen the development across decades. What are some perspectives on the disadvantages?
Disadvantage in terms of the maintenance. We have to maintain the building. Of course, the building BMU system will be there, but periodically it has to be maintained, cleaned. That is it should be always look like a fresh building. Of course, the costing, already I spoke to you. This cost of the total construction, the facade itself is going to be 8 to 10% of the overall construction cost. Only the facade I'm talking.
Yes, I think maintenance is definitely something that challenges us.
It's going to be a big challenge. Some of the thing, initially when we designed, we used to see that how it is going to be maintained. There are so many designs will come up, so many shapes, and at the end of the day, it has to be maintained. Those are the things that are very important during the design approvals.
You are saying so?
I will actually answer this in two folds. One is human beings, I mean, high-rise could be commercial or housing. I'm talking about the part that is housing. Humans as animals like to live close to the ground. This is human tendency. And people over time have adapted to live at certain height because of the power of proximity. They want to stay near their work or they want to stay near the business hub. But now technology is slowly changing that. You don't need to be physically present at a particular geography all the time to get your work done. You can be geographically disconnected, but technology enables you to be connected. So eventually this, along with the fact that our population is eventually stabilizing. At a point, I just read a stat that by 2050, India's population would have hit the peak. So the idea of urbanization is slowly but gradually reversing. The second aspect of looking at it is as a built form. It's not an issue when you actually build a thoughtful high-rise building, but if you look at buildings in Dubai and other Middle East places, when you build a building just for the sake of showing certain showing certain ability to build or the fact you can afford a building, it becomes extremely expensive to maintain, and also if your building doesn't try to respond to the local climate and conditions. Imagine a point where the entire city becomes tall. No one is going to enjoy the beautiful view anymore. So we have to be cautious about where we want to go really tall and where we need some kind of a mid-rise and a low-rise. It's a combination of high, mid, and low-rise which will be the future.
Further, as we are discussing about the pros and cons, there would be concentration of services, and the need required, if most of the buildings come up as high-rise, the need requires whatever the facilities, be it water, electricity, transportation, whatever it is, that would be concentrated, and there won't be a proper spread of it.
The resource management.
Resource management would be a challenge.
Big challenge, as the density improves.
As the density goes up.
And Vinod sir, this topic of maintenance came up. Maybe you have a perspective after the building is done or during. Is there a perspective on maintenance of high rises? How do you see that topic? Commercial buildings, maybe residential buildings.
See, maintenance, all high-rise would be having building maintenance units. That is for facade access and maintenance. So when we differentiate that between a residential and a commercial building, the usage pattern is different. For a residential building, you would have the age group or the people staying there is kids to old age people, their movement, their considerations of their movement is to be considered. Okay. When it comes to a commercial building, it is more of office-going people, mostly 18 plus, and who are capable for easy movement is possible. So for maintaining these kind of buildings, there are specific considerations need to be done that would be taken care by the architects and the building designers.
Great. Let's maybe take one, sorry.
Just to add a small point. Maintenance has a completely different perspective to it also. Generally, maintenance we think about, like there is a problem we want to avoid. Imagine we are having a curtain glass in a kind of a top class hotel. There, the goal of the maintenance is not to avoid failure, but to keep it completely clean. They would, like kind of top hotels in places like San Francisco, they used to clean their facade almost once a week. But once a week, you don't have a person climbing down. They have more advanced technologies to do it because they have a different goal. When it comes to a commercial building, there the goal is they are actually trying to portray their brand image. And when it comes to a housing, the demand is much lesser. You are just making sure there is no failure coming in, so you can almost decrease the frequency of your maintenance. When the maintenance frequency is much smaller, you can have more of a conventional cleaning system. When your cleaning requirement is much higher, you need to think about more expensive or alternate solutions.
I have to add one point. Generally, we from Arvindo Realty, we used to take care during the design concept level itself, during the maintenance. There is going to be, we will look into the how you are going to be maintained. That is a big challenge. So we always give the maintenance-friendly design.
So that is one more thing that I would also like to add. But when we are designing railings for a high-rise building for a residential versus when we are looking at railings in a refuge area for a commercial, the design entirely changes because for a commercial we have BMUs which are planned. For a residential, we look at it like people within the apartment will have to clean it once a week or once in 15 days. So yes. And when it comes to much high-rise apartments, we again have BMUs for that also. But when we're replacing the glass, can we do it from within the apartment is something that we always look at for residential. So there's always a difference when it comes to design for residential and commercial, which of course has to be looked at in the designing stage.
And I think that's a perfect entry into the design topic. Maybe we get into the curtain wall design. One line of thought I want to pursue with the panelists, and maybe it's more relevant across the whole panel. What is your thought on this entire digitization? I talk to a lot of investors who say, I want everything in BIM. I want Revit models. I want a digital twin of the building from the get-go, so that tomorrow when construction happens or when the building is operational, I know where things are. Now I hear that maybe once in a quarter from one investor, is that a trend that the panel sees? Is that serious in India? Does that add value? And if so, where? What are?
So it's definitely like what you mentioned, it's coming up like a trend in India. But if BIM is being effectively used, it is really, really helpful in construction, especially in clash detection, in proper planning. But what I have observed over the past 15 years, BIM has been used more like a drafting, Revit to be precise, has been used more like a drafting tool where you just create a model and save it for facility management purposes and all that. But ideally, if it is being used as part of design, where you design the entire building in BIM and in Revit, be it architecturally, structurally, or the engineering services part, and you do a clash detection, it really adds value to the project. A lot of reworks could be avoided, things could be planned in advance, and definitely does do a lot more than what we just call it as a trend.
Are there cities where you see this demand coming up?
Yes, definitely. There are investors who specifically ask for the buildings to be, their projects to be designed in the BIM medium.
And sorry, just
to add one thing only. The BIM Revit, whatever we are using, we are spending very little amount in comparing to the total cost of the project. But the value, what we are going to the return in terms of the rework, timing, and which one work, either the electrical guy has to be first or firefighting has to do the first. The sequence also will be derived, all these things. So particularly the high-rise buildings, when we go for the 4 basements and all, so many clashes will come. The widths of the tray will go more than 1.2, duct sizes will be high, and the fire pipes are also crossing. So many junctions are going to be created. These are all things can be addressed through the BIM and Revit. Maybe you can spend very limited little amount of others design. So all our buildings, what we are doing that we are adapting that BIM and Revit, ensuring that particularly saves the time and also the rework, particularly the rework cost.
So rather than for commercial buildings, let's say, if there are some buildings which are very complex in nature in terms of design. So for those kind of buildings, if we go for Revit from the beginning, from the initially schematic design stage itself, BIM actually kind of helps in the planning stage and mitigating a lot of issues that actually crop up during even construction also sometimes. So it is definitely helpful. BIM is definitely helpful because we kind of have been using it for past 6 years. If you see Mumbai and Delhi, most of the projects are going for BIM. So yes, we should definitely try that in Hyderabad as well.
Here we go.
I think most of the points are covered. Just to add to this, BIM makes you think of facade as a part of the holistic building. The traditional method of 2-dimensional drafting, whichever method you used, you always thought of the building, the structure, the facade, and any cladding as 3 different entities. That has completely changed when you do BIM. Right from the first step of modeling, you are thinking of integrating them. How do they work as a single system? And whatever analysis you do through BIM also forces you to think of it as a single system rather than an extension to something that is added to it. And we have completely now transitioned to BIM from an architecture standpoint. In case of a tall building or not, like the morning one of the school projects I presented, it's a very low G+2 building. But for each facade, I have to give close to 4 to 6 plans and 6 to 8 wall sections. This would be more time consuming in the kind of traditional method than using BIM. But the entire ecosystem has not fully migrated to BIM. Like still our consultants, some of them, the BIM is most useful when the entire ecosystem shifts to it.
Yes, absolutely right. In terms of the consultants also, if we have everybody together in terms of architecture, structure and services, and rather not wait for a BIM consultant to do it separately, that would be a added benefit actually.
So here I just want to, I think this is a call to action for the entire room, the entire industry. If everybody has to jump together to gain the benefit together. And I have a lot of discussions with architects, facade consultants, and here I must, I think, put the ball, and I've seen firsthand the experience, put the ball at the foot of the investor. Once they decide something, everything changes. And I have been part of a project where one of prominent global investor started the meeting with, here is a project timeline. The first panel will move on August 21st from the floor to the site. And the whole ecosystem, like you rightly said, looked in shock. Are you in Switzerland or are you in India? But on August 21st, the panel moved, because everybody was brought in line by the investor. And I can only encourage all the investors in the room and on the panel, push us hard, don't compromise, and like sir, you rightly mentioned, it's a small investment that pays off very quickly. Just keeping in mind the time, I think we can do design the whole day here. With curtain wall, I think there are huge opportunities. At Shuko, we see the facade as a living skin. And we have cloth facades, textile facades, printed facades. There's a huge unused space, and the facade just sits there protecting the inside, but really not doing much else. What is your view on that topic? How can we better utilize the facade to gather information? Lighting as a topic, I see a lot of focus on facade lighting. What are some of the elements that are coming from that angle, using the facade to get information, communicate information? What do you see from your perspective?
I'd start with facade lighting, because even though you mentioned it last, facade lighting was a trend that was very prevalent in the Middle East and the countries abroad initially. But it's actually pleasantly surprising that Hyderabad is also adapting to it, because that is something that gives your building, allows your building to make a statement. So especially in the night when everything else goes down and sleeping, if you have the right kind of facade lighting for the building, it just makes your building stand out like anything. So of late, the developers that we are working with, they've all been insisting for a very good lighting consultant, and they invest heavily on facade lighting so that the building definitely makes a statement.
From a facade consultant's perspective, so how do you see the topic of facade lighting, other aspects?
Yeah, particularly when we see in Hyderabad, almost most of the projects, what we do, there is a facade lighting consultant, and it usually starts from the initial stages, so that the integration and schemes are worked out earlier before even the panels go for installation. So there is a trend also which is moving towards having facade lighting, and that's a happening thing now.
Do you think, would any of the other panelists like to comment? I'm thinking, when I go to Shanghai or New York, I see the buildings are practically now advertising boards, not with those ugly billboards blocking the view, but integrated into the, so it's almost like you sit and watch the skyline, at night you're watching an advertisement from the whole skyline. Is that like a dream for the Mumbai skyline or the Hyderabad skyline?
That kind of ad revenues need to be generated. There has to be a market for where people are ready to spend the investment for that kind of facade with advertisement running is the initial costs are high.
Very high.
And they need to really work on ROI And if they are getting that kind of an return, then that is fine. But what we see here is that is still not picked up.
Also that these countries are more densely populated. When you're talking about Singapore and Mumbai, where you see ads, we have a building within, at least 5 buildings within each kilometer, or 10 buildings within a kilometer. But in Hyderabad, we have good amount of space in most of the commercial buildings that we see. So, like he rightly pointed out, whether we are going to get the revenues or not is something that we'll have to look at.
It always comes back to the money. So
This was, I was working on a project some 12, 13 years back. So we had done a study on this. The client was interested to go ahead with investing a video wall kind of a thing on a 45th floor project. But ultimately that was shot down only because they didn't see any ad revenues coming up.
We had, I think, Sushant talk about integrating photovoltaics in the building. And this is a question I didn't have, but because it came up, I wanted to add in. Is that a trend in the curtain wall high-rise design that you're seeing a requirement for? Is that something, given the amount of sunlight that we have, is that a topic of relevance for designs in India?
This is still, it is still catching up in India, but most of Europe, you see there are projects where they have done that. And even in India, there are a few data centers which are using this BIPV modules in their facade. There the requirement is they don't require any light coming into the building. The requirement is such that it has to be totally shaded. So there it is a better use, but if we look at any high-rise buildings, then there has to be a play made between the kind of glass what you use. There are different kind of modules available. Say 10, 15 years back, we had limitations on color, sizes, and other limitations. Or the ROI, the time was much, integration with the ESCOMs was not easier. So now we are at a stage where the market or the industry is ready, only it requires application.
Yeah, I think hopefully some of those buildings, because that adds up perfectly to the sustainability topic, making the building net zero. But I think as now the central theme is emerging, it's a question of, do you get the money back, right? You just have to time the market and wait for it, and God willing, that comes quickly. Just keeping in mind the time and the pressure on lunch, the last set of questions or the theme, construction and project management. We have these needs of sustainability, densely buildings, interesting architectural elements, options possible with curtain wall designs in high rises. What can we do to minimize the cost and the time of construction? What is required in the industry to change so that we make that step improvement and say, hey, we can get this project done in a defined timeline? What needs to change in the Indian sector? What does the ecosystem have to do differently?
The shortest answer is perfect planning. That's something that typically doesn't go into right at the start of the project, because typically everyone is in a hurry. In India, every project is a fast-track project. That's what we say. So certain projects, they tend to compromise on the planning aspect, where if you really plan the project out and then go ahead, you would not have much hurdles. You would save on the cost, you would save on the time. So definitely what I would pin it down is that the perfect planning needs to be done. You need to sit on the drawing board along with the consultants, along with the stakeholders, understand the requirements, clearly chalk out the plan, what we are going to do, how we are going to do, what are the systems that are going to be involved, and get the right stakeholders all together at the table and make sure that we are all clear about what we are going to do.
When we talk about the cost and the time and quality, we have implemented one of our commercial building with the precast. Completely our 25 floors building is completely used in precast, which is built in a year, the entire structure. The precast, you know very well, there's no manpower, very less involvement of the either mason, plastering, all doing this exercise. All slabs and columns, beams are manufactured at the factory and it has to be transported to the site and it has to be built. Most of the things will be used for the machinery. So there's a lot of time saving and also the quality. End of the day, the clients will look for the quality, whether the building is a quality. So it gives you as a value to the building, both in terms of the quality, time,
and the
cost.
And also sustainability.
This is one of the tallest building in India in precast, our Galaxy Towers in opposite to IKEA.
I would add a point both to this as well as your last question on like kind of photovoltaic cells. If you actually do an analysis of a taller building I mean a building which is typically placed in a part of a financial district, and you do a solar modeling, you would naturally get a lot of shadows from the neighboring taller buildings as well. And when you place a solar panel on a vertical surface instead of a horizontal surface, already you're losing about 30% of the tangential sun angle. So the photovoltaic cells works for certain buildings of certain geometric forms in certain locations. It would never become a general standard even in the future. Coming to the second part of the what needs to improve, a few things, like the complete ecosystem starts from the manufacturing in India. Like 10 years back, a lot of components were still imported. Today, fortunately, most of those components are getting manufactured through like direct or indirect manufacturers in India, right from the smallest component that is required to assemble it. The second part of it is how are you transporting? I mean, how efficient has the transporting become? Like despite whatever planning has been done, the execution time depends on the factory, transport, and final the skill required to assemble them and also the equipment required to assemble on them. So if India has not yet fully moved on to that ecosystem, the day we move will be, we'll probably be a completely, we would have changed as an economy. As of today, we are progressing towards that. I think we can see a difference from the last 10 years to now. And in the next 10 years, you will see more and more of this technical equipments also coming into play, which will change the cost and speed of construction.
Great. So the takeaways there from a planning, the construction and project management side, I think planning, I think we discussed BIM, how that flows into planning, looking at the building as one unit. I think you mentioned using new technologies like precast that speed it up, standardize. So I think that actually opens up a bigger bucket of how can we standardize our systems overall. And I think what you are saying is we can do all this, but if we don't use the right tools and equipment for that last mile, including the transport, all this is wasted. Because it's at the end of the day, somebody's tightening a nut bolt with their hands and a wrench, everything goes to waste. So I think, again, the ecosystem has a lot to do. I think the ecosystem is sitting in this room, partially at least, and we can only encourage each other to keep making that inch by inch forward movement. And like Sriram said, that one day will suddenly be in front of us. I'm sensitive of the time, so I'm going to just ask for final comments. We can do this the whole day. I think with this panel, there'll be a non-stop discussion. So any final thoughts, we can go in sequence on this topic, any key takeaways for the audience before we break for lunch. Any words you would like to say, challenges, what you would like the industry to do, what is important for all of us as a team?
Here, I would just like to recall your statement. By 21st of August, the first panel has to go. Okay, for that, there was a whole, the whole team was involved in getting the things done. So, my closing comments would be any project we do, a high-rise, a mid-rise, low-rise, the whole team has to work together so that we come up with the results.
Very valid point.
If we are actually designing a facade today in India, what is controlling the glass panel size is not the technology, it's not the cost, it's actually the manpower who is going to transport it. Manpower and the road. This is the practical difficulty. Technology has changed a lot of things, but there are still gaps that needs to be filled up. And once we close in the gaps, which I think is already happening, but once we are able to close in the gaps, we'll be able to see completely different types of buildings in India.
To add one thing, the skilled people, what you rightly said, the person is not using a right tool for the right particular thing. He's not a skilled people. So we, in particularly, India definitely required, there is a lot of training needs for the people who are working in terms of the, whatever the field they have, either mechanical or electrical, or there is a lot of training required for the people to get the better product. After doing so much, doing maybe prefabricated and done and doing the, finally end of the day, somebody has to be there and see that it has to be placed in the right location or not. So those training also required. There is a lot of lack of, or you can say the lack of manpower, or you can say lack of that efficiency, quality of work. So.
Yeah, I think we covered a broad range of topics, and I still am left wanting more. Topics of sustainability, I think topics of well-being, urban design, topics of how to better plan, drive digitization. And somehow when I listen to all these words, we just see that all of us are busy just building our nation, right, in our own small way. And I will end this panel, I think, with one of our investors who, after lengthy conversation at 7:30 in the evening, finally lean back and say, we are done. This is closed. Sham, desh banao, right? And I think at the end of the day, in our own small way, all of us are trying to do that. And I thank all of you for pushing us to do better, pushing the industry to do better. And I think this is a call to all of us to say, you know, let us all make that step forward and, you know, leave with hashtag Desh Banao, right? So thank you very much.
Thank you. Thank you.
Thank you. Thank you very much to this panel of wisdom from all across the board, from developers to architects, consultants. And I think it's been an excellent panel, Shyam. You moderated it really well. You've kept the topics interesting and got everyone to and juiced all the wisdom out. So thank you very much, Shyam. I hope the carbohydrates don't turn into lactic acid and make you like tired and sleepy right now. So a cup of coffee after that, I think, you know, everyone needs a bit of charging. So good afternoon, everyone. Good afternoon, everyone. Excellent. So we have an interesting session coming up. First up, we have Mr. Nitin Gupta from Arcop. We call Arcop the king of public buildings, and that's exactly what he's going to talk about. Facade for public buildings. Recently worked with them on the India International Convention Center. And there are a lot more public buildings that they've worked on. So I'll leave it to Nitin to take it forward.
Thank you so much. So let's hope the talk is energetic enough that, you know, after a good lunch, it is able to keep your energies living. So first of all, you know, the talk that I'm giving is on a project that is very much there in Hyderabad. So it's the police headquarters, come the Central Command Center building, which has come up at Banjara Hills, which, you know, I was the principal architect and designer for that project. So design vision, you know, I'm going to talk about the design vision, how we develop the form of the building, because that is what is unique. And obviously then facade as a system is, you know, follow-up of that. So design vision, now these are the 3 points that we got as a brief from the client. And when I say brief, the brief was literally coming from the Honorable CM himself and, you know, the Director General of Police. So it had to be a modern iconic building. The CM wanted a modern icon to be made in the center of Hyderabad. It had to be a state-of-the-art building, and it had to be a landmark building for the city. So these were very simple brief given by the government, but, you know, then the brief thereon becomes complicated when you start analyzing it. So what we started doing to start with, before even jumping into design, was that along with the client, we started researching as to what are the buildings around the world which convey the same philosophy. So we started looking at the modern iconic buildings that had been constructed and finished by that time. We started looking at the state-of-the-art buildings, which can be called state-of-the-art. We started looking at the landmark buildings for the city. So for example, Sydney Opera House is for Sydney. You know, the Kuala Lumpur Twin Towers are for Kuala Lumpur. So all of these buildings were very transparently discussed with the client. After that, what we did, this was one of the kind exercise that we did in Arcop, in fact, that we started devising what are the symbolic design parameters for the architecture of the headquarters. You know, what should be the parameters? Because at the end of the day, the worst thing that we wanted to do was that go into a direction where it, you know, demands criticism that somewhere it has become too fancy or it is not conveying the ethos of a government, you know, state building. So we started looking at the aspirational parameters. So the building had to be strong and powerful because it was a police headquarters. The building, because it had to be a unique building, a landmark building, had to be absolutely unique, you know. Third point, it had to be timeless and pure. So when I say timeless and pure, I think in our architectural parlance, this is something that is used quite often. So, you know, even today when I come from Delhi, even today when I came to Hyderabad driving from the airport, there are some very interesting buildings that I saw, new buildings and, you know, in the high-tech city. So credit to those architects. But sometimes, you know, as architects, we tend to go into our own fancies, sometimes do things which are whimsical. So those are the things to be avoided. Buildings should always be timeless, and more so the government state buildings. It had to be cutting edge technology. Then also tradition and culture, very important. The building was being made for state of Telangana. Building was being made in Hyderabad. So it had to somewhere get inspired from the tradition and culture of Telangana and Hyderabad. At the same time, one is expecting general public to come to that building. So it had to be simple and systematic. You know, we didn't want people to get, general public to get intimidated by the building or get lost in the building. It had to be obviously attractive and interesting. This is one of the debatable points, you know, which finally we did not adhere to in all its 100%, but, you know, this was a starting point, that building should be monumental and symmetrical so that, you know, it conveys. And finally, this is a point that, you know, Honorable Director General of Police, in fact, brought in, that the building should be sensitive and humane also. You know, he didn't want police to be conveyed as a very authoritarian, you know, symbol. So he said building should be sensitive and humane so that people feel that the police is for them, you know, and they are not to be intimidated by the structure. So these are the 9 parameters that we finalized along with the client. And then we did something very interesting. What we started doing was that various buildings around the world, we literally started marking them. You know, this was done as a very democratic exercise. Whomsoever were there as stakeholders participated in this exercise. And this was like a poll result coming in that on these 9 parameters, let us rate some of the buildings that we think stand up to you know, this test. So lot of buildings. Now you can see all of these are very interesting, you know, modern, cutting edge, state-of-the-art buildings around the world. They were all rated, literally, democratically, amongst all the stakeholders. And finally, you know, I'll show you. So we literally hunted for buildings that, you know, one could think of. So out of this, all the buildings which got more than 25 marks were compiled. You know, these are the buildings that got more than 25 marks. So they were above a benchmark, one could say. Now, what are the inferences from these case studies? That is what we understood, you know, that what should be done so that for police headquarters, what we develop and design, we stay within a framework, so we do not cross the lines anywhere. So we said the form, we realized should be gravity friendly. So when we say gravity friendly, I would say that, we didn't want an inclined building, for example. We didn't want a building that has huge cantilevers coming out. So, because that we realized somewhere or the other that would not convey the ethos of a state government building as such, which wants to convey like a police headquarters. Facade, there was a long discussion, prior to this, where why one should be using curtain wall facades, glass facades. So we realized that, a high-tech glass facade is something that will be very appropriate for the building. At the same time, the form had to be simple and pure. When I say pure, the idea is again of a unique form, of something that does not start drawing elements from some other project around the world. And finally, the expression should be contextual. Building had to belong to Hyderabad as such, and also draw inspiration somewhere from tradition. It should not become pastiche, that it starts looking like a monument, historic monument, but at the same time, get inspired from the tradition. So after doing this exercise, we started running through a lot of concepts. And believe me, I'm going to show you 4 options that were actually presented to CM and a group of ministers. And out of these 4 options, the present option was selected. But prior to this, almost 15 to 20 options were tested. And then these 4 options were arrived at. So I'm going to quickly present to you, all the 4 options. So this was option 1, which was, one tower. So the entire program of the project was combined into one tower with a podium and then the tower going up. All of these buildings, you will find that there is a helipad on top. So that was a prime requirement coming in from, from the government side. So this was option 1, which obviously now that this was not constructed. There was a lot of debate. Each option was debated very heavily. Then this is option 2, which is pretty close. So in a way, option 2 was the one that was zeroed in out of the 4 options. These are the site plan. Then this was option 3. So by this time, the concept of single tower had gone. It had sort of come into our mind that we want to do, at least two towers, twin towers. Idea was that, if you are able to trap the volume of the sky between these 2 volumes, then the building becomes larger than life. So that was the concept behind twin towers. But somewhere, I would say, so this was an option made as a twin tower, wherein, Vastu also was a very, very important criteria. As we all know, that is something that the state government wants to be followed. So southwest of the building was, kept higher and heavier. So you will always see in all the options that the southwest, the towers are not identical. The southwest tower is the higher tower. So this was an option also tried. Then the last option that was made was this, a pure twin tower, wherein again the southwest corner is the highest. So all of these 4 options were very heavily debated on. I would say not like a secret ballot, but virtually a voting was done in front of Honorable CM amongst all the group of ministers and the respected dignitaries. And after that, the final design was selected. So final design, as I mentioned, was, you could say, improved version of the option 2. So here in the final design, just to explain the basic configuration, this is the southwest tower, which is the highest and the heaviest. Then, the northeast tower is the twin tower. Other than this idea came in from, I would say, the police team itself, that why not make it like a 4 tower, even though the requirement is getting over in 2 towers. So virtually, there were 2 towers that were created, which are primarily elevator towers. So there is a set of elevators that goes up there, and then this mega bridge, or the mega, you could say, sky deck created above, has a museum which will be made for the city of Hyderabad and the police on top there. So public can take this set of elevators and go on top, just to visit the museum. And then on the diametrically opposite side, there is a set of elevators which come down from the helipad as a VVIP elevator system. So effectively, the tower became 4 towers, and somewhere it automatically clicked because it was coming from the Charminar. So Charminar of Hyderabad, the 4 towers concept started clicking in our mind also. What you see in the middle here is something very interesting. Now this is where actually the central command center is placed. So this volume has the data center, as well as it has this double height space, which is like, which has a video wall of multiple screens, and it is like what we see in NASA. Now this is still in the phases of completion. But this building is virtually floating in the air, connected as a bridge between the 2 towers. So from both the towers it can be accessed. It is symbolically and physically in the center of the project. From a security point of view, neither is it on the ground, nor is it, approachable from the roof. So the center can only be approached from the towers inside. So it's one of the most secured, facility within the tower. So this round central bridge form is actually the central command center. So this is the view from the entrance. There were a lot of thinking about, this is the way one enters the project, that, everybody gets dropped off here. Then there is a ceremonial walk that takes you into the central courtyard. And from there onwards, one distributes into the various spaces. So these are the further images. This is the, so that was the concept. Now just to quickly show you what in terms of plan actually it is. So if you notice, the site was an irregular shaped site. Now within this, purely coming from Vastu, the largest rectangular plot was carved out in the north-south cardinal directions. And all the towers then, the entire building is cardinal north-south direction. So that is where the fundamental, you could say, placement of the building came in from. In terms of floor plans, it starts as 4 towers from the ground. The rear one has the auditorium. Then, once it goes up, on the left-hand side tower goes up to 110 meters. So brief was to take it as high as one can. In fact, the aspiration was to take it to 120 meters. But because of the airport close by, we were not able to get permission for more than 110 meters, and that is what it has been taken to. This is the building elevation. Now, as I mentioned, we wanted it to be a green building also, go into a cutting edge technology. But, let me admit, I think this is something where we could not achieve 100% what we wanted to do. This facade that you see, the second skin, was actually meant to be a solar photovoltaic BIPV panel. And during the process of the project, this is something that we had to unfortunately compromise upon. Now it is just a glass of a different shade. I think somewhere this is what I would say, one point where we lost out. Now these are the external wall sections wherein the building virtually performs like a double skin. And as a part of the system of sunshade and screening, there were 2 elements used. One was the GRC screens, and the other was the aluminum louvers. These are some of the photographs during construction. So here one can actually see, the double skin structure being made, and then in front of this, we had to have the BIPV panels, which later got converted into a colored glass situation. Now this is a very interesting photograph. Probably not everybody can go into this space. This is the space inside the mega sky deck structure. So you can see there are bridge connecting all the 4 towers. This is the elevator tower. This is the volume that is going to be the museum, the police museum later on. And this, there is a diagonal bridge, which probably, yeah, this photograph shows the diagonal bridge at the intermediate level. So we also had an interesting decision to make as to how to create the soffit of the sky bridge, because one wanted a very clean soffit. One didn't want to see a lot of structural elements there. So literally, as you can see in this photograph, there is a hung aluminium mesh that has been put, and there is a full catwalk system, primarily to, in future, if there is a maintenance issue required, so one can approach the mesh from top, remove it and then replace it. So there is no need to approach the building from bottom, because at that height it was virtually impossible to look for any maintenance solution for these meshes. So these are some interesting photographs of that space inside. Now this is an aerial view of the site as the building has been finished. This is on the inauguration day when the building was inaugurated. This is one of the evenings before the buildings was inaugurated. Virtually a light show was being organized. So this was the I would say the presentation of the police headquarters. Now I'm moving on to a totally different project. In fact, this is not one project, but 3 projects. So we were fortunate, I would say, that we have been participating in design competitions for these state level aims. So these are All India Institute of Medical Science at the state level. So in fact, there is one coming up in Bibi Nagar, which is called AIMS Bibi Nagar, but it is practically AIMS Hyderabad. So that also we are doing, but that is, the construction has just started. So this was the first AIMS that we worked upon. This is AIMS Bilaspur. Bilaspur as in Himachal Pradesh. So this started in 2018. And now, as I mentioned, what AIMS as an institute, it has to be world class. We are looking at world class healthcare services. But at the same time, how do you differentiate? There is an AIMS happening in Himachal Pradesh, there is an AIMS happening in Jharkhand, there is an AIMS happening in Jammu, then there is an AIMS happening in Hyderabad. Do you want all of these buildings to be like a similar prototype buildings? Obviously not. So one wants that AIMS Himachal Pradesh, somewhere should look like an Himachali building. But at the same time, these projects had to come up in a period of 3 years. A complicated hospital building of an AIMS standard, 750 bed, with a mega medical college and hostel facilities on a campus of 200 acres, coming up in 3 years, one has to go for mechanized systems of construction and, for the entire thing. But at the same time, as I mentioned, as architects, we feel that we have to draw inspiration from the local architectural heritage. So this is the architectural heritage of Himachal Pradesh. As you can see, there is a system of doing masonry wherein the local stone is made in panels, actual walls, and then there are these wooden bands which are, braced. These are braces to support the masonry structure. And then omnipresent is the slate roof. The slate roof is just omnipresent all around. So coming from this, these are the initial images that started developing, that, why don't we look at a certain system where again that whole vocabulary is expressed. At the same time, modern buildings cannot have sloping roofs. You also want solar energy to be harnessed. So, this system we came up with, which we finally started adopting in all the AIMS, that, let's have a sloping roof expression, but then it is camouflaging the services on the roof, and then finally on top, it gets capped by the solar photovoltaic plant. So this is the image that started developing of the AIMS campus. That's the highway in the front. This is the Grand Arrival Plaza. That's the hospital building. This is the medical college building, and then the further residential campus. This is a steep hill it's on a very steep hill that we planned, this entire project. These are the images that, these are then the elevation drawings that started coming up. So obviously one had to look for, facade panels which were much larger in size, but at the same time how to create the same, traditional feel. So what the solution that we came up, in fact, this is a system that was then carried on in all the other aims also, that, why don't we make these GRC panels which have a kind of impression of the local stone. So these are actually GRC panels which, which I would say multiple samples were made to create the impact of stones. Sorry. Oh. Sorry, I jumped the, yeah. So, now this is the first building that we got constructed. So it is a GRC facade for all practical purposes. So within GRC, dry cladding GRC, we have created that, and then the roof on top, the slate roof effect is also from the GRC. That's the final project, as you can see. And yeah, these are the images of the project as of today. Then, after Himachal, we virtually, with a gap of 1 year, started working on AIIMS Deoghar. So this was in Jharkhand. Now, I don't know how many of us are aware, but Deoghar happens to be a pilgrimage point. In fact, for the eastern region, it is one of the most sacred pilgrimage point. So here, the temple itself became the inspiration for us in terms of the form. And, these are the kind of forms that we started developing, where the shikhar form of the temple itself becomes the inspiration for us. The overall glass and the GRC facade starts following that form. As you can see in this external wall section, the facade generally rolls up to the roof, goes up and supports the, these are actual photographs after finishing. These are work during construction, ongoing. Finally, AIIMS Jammu. Jammu has a rich tradition of exposed brickwork. So we've, followed that. These are the renderings for AIIMS Jammu. But again, to imagine or think of doing brickwork in a modern building is out of question. So we, again in GRC, we started developing these, brick panel look-alike and, finally come up with this. So thank you very much. This was a general presentation, I would say, on two very different approaches towards facade as to the requirements of the building. Thank you.
Thank you very much, Nitin. Thank you, Nitin, for an excellent presentation.
Thank you.
Very informative and, very good to see these different materials being used and using GRC, what you've tried to create across and the sort of thought process you've had across each project. Next, we have somebody who is known to all in the facade industry. He's the principal scientist of Dow. Dow is the front runner of using silicon sealants in India. We've used the first structural silicon kit in India back in 1995. And since then, we've only been using Dow. And Ravishankar is someone who I've known ever since I've started working in the industry myself. Right from back in 2010 when we both drove down to the factory when he was doing his quality bond certifications, I remember very, very well. And he was licensing fabricators and processors with best practices certificates of quality bond, which I think since then, he's had a long, long journey in Dow. And since being a techno-commercial man, now he's moved to pure technical R&D, and he's known as the principal scientist of Dow. Mr. Ravishankar, ladies and gentlemen.
Hey, thank you, Rohan, for your excellent introduction. As he rightly said, the relationship goes way back, from where his dad NK started. So we have been into the facade industry in India for close to 30 years now, okay? Whether we talk about the first building which was structurally glazed using a sealant, when conceptually nobody believed that an adhesive can hold the glass onto the building. From that, today there is no looking back, right? So there are heights like we are talking about a 60-floor building in Hyderabad. with a structurally glazed facade. So we have gone in a very long way, and today I'm going to talk about a slightly different topic, how though it is actually making it already a sustainable in terms of energy efficiency, watertight and airtight, as a material producer, we are taking more challenges to even make the product more carbon neutral. So that is what I'm going to really talk about, and I'm also going to talk about some of the ways how this adhesive can help you in reducing your material consumption, such as aluminum, so that it makes it more sustainable. So allow me to now take you through this topic on designing sustainable futurescape together. As you all know, we have a stall outside. You can always visit us. So Dow is a company which is close to $57 billion with 35,700 employees in 104 sites in 31 countries. We touch close to 170 countries in the globe by some or other means with our products. So we are famously known for many of the applications like structural glazing, weatherproofing, insulating glass, glass embedding, retrofitting, or photovoltaic. So we saw, the previous presentation, so he was a bit upset, we could not make a BAPV. So people are today very, very conscious of making the future more sustainable. This is not the last generation we are going to live in the planet. We have a responsibility to keep it that way. So, and what happens is, when you do it with a bonding technology like structural glazing, they have a durability of 50 years. Okay, we have done a study wherein the product has proven to that level. So you have a chemistry which can give you that durability, energy efficiency, water tightness, air tightness. But as a manufacturer, when we move ahead, what is that responsibility we are also taking beyond what we produce today and make it more sustainable? So Dow has got a very strong goal. So we are aiming for a carbon neutral production by 2050. So we are one of the largest chemical manufacturers in the world, whether you talk about polyethylene materials, polyurethane, acrylics, or silicon. So these are large 4 chemistries, and Dow has got thousands of products coming into the market every day. So when we are talking about it, there has been a sustainability goal taken by Dow long back in 1988, but when the actions were really started showing results from 2005. You can see that we looked at footprint, we looked at handprint, we looked at blueprint, and then we are looking at now how to make it more and more carbon sustainable. So all of this has got a sensible way of producing the material, and then the carbon reduction is very, very important, okay? So if I just take you through, so today I'm going to talk about a very interesting topic known as carbon neutral silicon sealants for facades. This is the first time ever a producer of silicon sealant has really talked about this as a topic and has produced something like that, okay? So we all have a responsibility. It is not one single person's responsibility to make it greener. So we all have a responsibility in terms of how we are using our resources to make it more sustainable. So we looked at our own process. So one is make that process more efficient, less energy consuming. If you are consuming energy, how do you make it from renewable sources? And then also make that material which is more safer to your environment, okay? So these are something Dow had really looked at over the period of time, and the silicons are giving you that property today. So we strongly support that Paris Agreement for climate, and where the 2-degree reduction, what they are talking about has to be taken care, but that cannot happen if we are doing the way what we are doing today. So there is a responsibility to make it, and as you all know, 39% of the energy produced or the carbon emissions happen from the built environment. Out of that, 28% comes from the operational, when you are running the building, making the building, and then operating the building, that's what it is. And the 11% comes from the embodied carbon. So when I say embodied, it is that material which is produced and that has been used on that building is carrying that carbon dioxide. So this is something, it has to come from manufacturers in a sensible way, because there are a lot of codes available today to take care of that 28%. We talk about green building codes, or we talk about World Green Building Councils, or Indian Green Building Councils, then the end of product life cycle. So there are a lot of codes available here. But what is that we have to also address is the 11% of embodied carbon dioxide. That is what Dow has been really doing, unconsciously building that environment. So what we did is, from 1988, we started developing a forestry in Rio Branco, Brazil. So this is a forestry wherein this is part of an Amazon, which was heavily deforested. So Dow took over, thousands of acres of that and then made a forestation. So 80% of this is habitable, in terms of the natural of a forest, and the 20% is where Dow started making a eucalyptus plantation, which was used for making certain coal and other energy-making materials for the production of silicon metal. So silicon metal is one of the components which is used for making the sealant. It is not only for sealant, for many other applications, but we are talking about sealant here because we are from the construction. It has to be sensibly made. That consumes a lot of energy. So how we made it is we made that forest, and then we took that from that, and then we have an audited charcoal made out of that. We have audited wood chips, which are being certified, saying that, okay, you are planting it again and again after once in 7 years. So that's the way of we are foresting it. And then that is being used to produce that carbon metal, even using renewable energies. So this is a sensible approach, because looking at the world environment, we need to be also making this initiative and then get this completely into our product with a lower and lower embodied carbon. Okay? So you can see that 45,000 hectares have been, of land has been used for this sustainable forestation. So these are not, Dow just cannot claim like this, because there are certifications which happens, so which I'll take you through in my further slide. So you can see today there is a complete imbalance by, it's not only for silicon, for any manufacturers who is producing today using fossil fuel or other ways of energies is really using a lot of embodied carbon. So when we did that, then we reduced our carbon footprint by going through that particular process of forestation. Then the footprint got reduced, so you can start balancing it. And then by the way, we are again planting it and then using the renewable energy, we could completely offset, and the result of it is the carbon neutral silicon sealant. So this sealant, what we are producing from that polymer produced from that plant, is giving you the carbon neutral. So this entire process is being audited. So there is a qualifying explanatory statement, QUS, coming from PAS 2060, one of the reputed institute and the certification agency which gives for the carbon neutral certification. So they audit everything. There are ISO documents available. They calculate the silicons, whatever we have been producing and consuming in terms of energy. And then they also look at the emissions, what we make, and the overall process. Then they give a certificate saying that, okay, the product you are producing and the energy efficiency, what it gives, so it completely gets offset, and this product can be claimed as a carbon neutral product. So now this product is available based on your project, depending upon your requirement, structural glazing, insulating glass, and weather sealing. You can get this product. So this will give you additional carbon credits from 2 to 16 numbers, depending upon the certification you are going through. This is globally available. And what are the products right now which are in this kitty? So we have in structural glazing, 3 of them. Insulating glass, we have another 3 products, and weather sealing, we have 4. So most of them are already used in India. So if you are really looking for a project with a carbon neutral certification, we can talk about it. There's a process involved, and definitely we can look at supporting it to get you additional carbon credits. So that was one approach. The second approach is really talking about how this silicon sealant, by a bonding solution, can help you to reduce your aluminum consumptions. These are very proven. There are already people doing it. Big windows, when they are going for it, they just bond a thin aluminum structure, frame onto that glass. Thereby, the rigidity is provided, and then they are able to manage it. So this concept is being used, and the same thing has been here mentioned here. So compared to a captive system where you are holding a glass with a mechanical clamping, and then when you are bonding it with a sealant, you can really reduce the carbon and aluminum consumptions, thereby reducing the carbon footprint on the aluminum. So, and also it gives you thermal efficiency much better than what you get from the capping system. So these are representative system for worldwide has been taken for this study. There is a white paper available. And then the same thermal performance was matched, and then identical glass buildup was taken, and same structural performance in terms of wind load was studied. So you can see that from 2.5 it comes to 1.93, and then from 1.6 it comes to 1.4 when you are doing a bonding applications against the captive systems. So there is a good reduction of 10 to 25% in thermal you can always achieve. And not only that, because of the bonding, you are able to get certain rigidity to the total system because it transfers the load to the frame. So thereby you can also design, because your capping is completely gone now, you can reduce the aluminum on your facade. So thereby you can really save close to 1,000 ton of carbon dioxide emission in a 30,000 square meter of facade. So by doing structural, bonding, and then by, really looking at a carbon neutral silicon, in overall you can save up to this level. So this is a significant saving, and this is going to be really looking at, you making your own building more sustainable. And if you really see in a glass bonded building, the silicon is used only on a perimeter with a very small amount. It's hardly a 10 or 15 millimeter. Okay, so that is holding a glass of 1.5 or 2 meter by 3 meter. So how this small amount of silicon, which is actually durably holding that, is also helping you to easily remove them by cutting that. Okay, so we have done it in the past. You also do it in your project regularly, where if there is a broken glass, you can cut the silicon and remove that material. So thereby you can, this enables you to remove those materials which can be recycled. So it is not that you don't have a system which completely damages that. So that is the beauty of it. A strong, flexible rubber, which is holding your glass to the frame, also helps you to remove them whenever you want them to be recycled or retrofit or any of the applications. Okay? So it is already proven that the product is completely an air and watertight seal. So it has a durability you can achieve for 50 years. So this is one study we have, rather two studies we have done, wherein there is a 25-year-old building. We removed the silicon after it has been actually exposed to weathering for 25 years, and then tested the silicon for the remaining strength. So as per the E-tag, if you get 90% of the strength, you can expect the life of 25 years for that product. So even after the use of 25 years, the product still had more than 90% of its mechanical and physical properties, which shows that the product can withstand for another 25 years. There was another study done in German institute, wherein there is a climatic chamber developed, like actually what it happens in the facade, and they subjected it to one cycle where it is compressed, stressed, it is subjected to salt spray, humidity, UV, and if you do that, that equals to 1 year of lifetime. So we did 52 cycles, and after that we again tested it, the product withstood the requirement. So that means it shows that the product can have a good durability of 50 years. So what you need to do is choose the right product, make a right design, and do a right application. So Rohan was talking in the morning about ICICI, which is like 15, 18-year-old project, which is standing tall today. And like that, many projects in India, which proves that this is a proven case history. So we didn't stop here. We keep innovating. Previously we were known as Dow Corning. We were only restricted to silicon. But coming to Dow from 2016, we started exploring the chemistry to the benefit of construction industry. Now we have products which are like paintable sealant. Silicons are not generally paintable because they give you excellent water repellency. So you would have seen a lot of paint companies showing a small silicon throwing water and it just repels out, okay? So that's because the beauty of that chemistry which is necessary for many of the applications. But in some of the applications like GFRC joint or a precast panel or fiber cement board, where you have a joint and you still want that to be painted, then we have now a hybrid chemistry which gives you the durability with paintability. We also have an embedding sealant for the balustrade applications. This is a 2-part PU. This can really eliminate mechanical fixtures and can hold the glass in place for your railing applications. We do have membranes from EPDM. It can be used for the coping, end of the facade, or the corner joints, wherever you need a good watertight seal around the window frames. So this is one solution which can again give you additional watertight protection, whether it is a thinner or a wider joints. We also have butyl, the primary seal. We were supplying secondary seal already for 30, 40 years now. So there has been always an insist saying that, why don't you make the primary seal? Now we have a primary seal. Sometimes if you have a primary seal matching to the color of the secondary seal, so the architect can get a cleaner finish when they look through the glass. There is also a peelable coating, which is like a challenge for putting a polyethylene film on the glass, which leaves an adhesive onto the substrate when you remove it, and you have to do it after every 3-4 months. So we have come up with a paint which does not bond to that, but has a small amount of force to hold on to them for 9 to 12 months. So during the construction, when you're installing your glass, the debris falling on it from the concrete or to the welding, that can be completely protected, and once you remove it, it will look very, very neat and clean and new. So please visit our booth, and I have all the products displayed, and thanks to Zak and Rohan for giving this opportunity.
Thank you very much, Ravi, and thank you very much for finishing exactly and precisely on time there. So next up, we have somebody, we have Ritesh Jindal from Arcop. Ritesh is somebody who has had experience working as a facade consultant in Singapore. And then he worked also with Arcop itself, where he was known as a parametric genius for his skills with geometric analysis and advanced computational methods. Since then, he came back to India, worked for an international consultancy here, and now he's leading the facade team at Arcop in India.
Thank you. Thank you. So good afternoon, everyone. A post-session lunch, but I'll try to keep it interesting. But very ideal because the previous group discussion that happened was regarding a lot of digital push. And some of the things that will be presented in this few minutes is about those tools, about the digitalization that we have been doing and trying to push in the market. But before that, just one interesting fact. Does anyone know the world's largest incomplete church? Thank you. So that's exactly Sagrada Familia, and it's been designed by Antonio Gaudio. And the thing about this church is it started in 1883, but has still not finished. And I'm glad that Arcop is part of this and trying to finish the dream that was actually designed more than 140 years ago, and it will be finished in 2026 at the 100th birthday of Mr. Gaudio. So just glad to be part of this kind of projects, and just a small statement from the foundation, the architecture director of the Familia Foundation, about the contribution that Arcop has been doing on that. Quickly about the firm, I won't spend much time. We are about 17,000 plus professionals across the globe, and we have 95 offices in about 40 countries. In India, we are actually doing all of the first vertical. So we are basically functioning in 4 verticals. The second one is a combination of India and overseas offices together, actually trying to provide services in India. The third one is very specialized services that we get from our overseas offices. And the fourth one is based on request. So we do a limited kind of service offerings just when the client requires them. In India, we have presence for over 40 years, some of which was from office when we had here, and some when we were functioning from overseas offices. We have finished about 200 plus projects in India. And the history about 2008, where we established the office, was actually related to Hyderabad, which is the project, the airport project, which was our first project as Arcop India Private Limited, and this is where our office was established in India. We have also recently finished the Statue of Unity, where we had provided various services, which included facade, electrical structures, vertical transport, fire, and it's just wonderful. It's just mesmerizing to be there, seeing the project live. So please do visit if you haven't. It's wonderful, and the campus they have developed in Gujarat, just mind-blowing. Again, another recently finished project, Zak World Center, where we had done complete facade design consultancy services on the job. It's still going on. There are some parts that are still pending, but the project is launched officially. Again, we have long relations with Hyderabad, and this is for one of our global clients, Salesforce, where we have given MEP, HVAC, and other services. Zak World Drive, Mumbai's first in-drive theater, and glad to be part of Facade on this job as well. And people who have seen 3 Idiots, Bollywood movie, that's the school that they show at the end, where Amir Khan is flying the drone at the end. And Arcop has actually done architecture as well for this job, and we have won 4 awards. The project has been sustainably awarded, Best of Building of the Year award. So quickly, coming to the topic, advanced tools and automation. So I initially thought, that probably I should go step by step, where we talk mainly about digital first and then slowly get into the tools that we have been using. So this is one of the projects that we are working on. And when the architect came to us, the whole complexity was do the cladding. And we were like, so what's the intent? And the architect said, you're free to do anything. Just make it as economical as possible, but as beautiful as possible. And that's when we started jumping into what type of cladding do we need to look at, what is the shape of the cladding that's going to be. And this is a project in Gujarat, so we had to think about climate, we had to think about insulation that's going to come inside this museum. So again, we started thinking about 4 different parameters. Now, one important thing about parametric architecture is anything that goes in has to have meaning then only you will get a good output. Otherwise, it's garbage in and garbage out, as simple as that. So setting up these parameters is actually very, very crucial at the start itself. And then using these parameters, we started jumping into different shapes, rectangle, square, diamond. Then again, we started doing a little bit analysis. How much is the wastage coming? Is it actually feasible in a shape like pyramid? Maybe not. So we went into triangulation. And even in triangulation, you have a square divided into 2 triangles. Then we have a hexagon, 6 triangles, and again a square into 4 triangles. So after a lot of permutations, combinations, we finally came, we started plotting it on the whole model, and we finally came up with an optimized geometry with almost about 870 panels and only 6 unique panels being used across the whole pyramid here. So that's the kind of value you can bring when you start thinking about these parameters, construction, fabrication, bringing them to site, how will they be installed. You think about all of that, and then you can optimize the whole geometry to be as simple as possible. This is another tower happening in the same campus. And again, from just the tower, the inclines are different, all at different angles, going up, somewhere they are meeting together, the lines have to meet, the architecture has to be perfect. So after doing, again, a lot of permutations, combinations, for the inclined areas, we have kind of come to almost about 3 panels, and for the vertical areas, 2 panels. So that's the kind of optimization we've kind of done. Another project that's very close to my, my career is Jewel Changi, which was my first project. And the whole dome was a project in itself where we had to do optimization and come up with the geometry in the first place. So the architect came up with this drawing. They said, we have to make this possible. And then we started digging down the information. How do we actually build this geometry? We started looking at ellipses, the angles, the radii, again, looking cross-sectionally as to how the curve will come up to. And this is called a spline, so it's basically a combination of different lines coming together. And we started ticking on the important points. Like previously said, garbage in, garbage out. So we had to be very precise on what numbers we were taking. We couldn't take 33.64 degrees. The reason for that is, you don't know in mathematics what is 0.64. It could be 0.639, it could be 0.645. So we had to remove all of those numbers, but only take exact, precise whole numbers for our design. And the important point is where actually the curve changes its angle, because that's where exactly the curvature continuity becomes very important. If you don't have that, that'll be your curve. That'll basically keep changing its own properties again and again. So we went back to the architect with the most optimized solution and the model that we had received. So you can see a slight blue line that basically shows the architect's line and then our line. And finally, the architect agreed because this was actually a properly geometrically designed shape and it could be fabricated easily. Again, now the 4 picture looks very similar, but when I see the cross section, you can see these boxes from left to right, and you will see the panels are actually getting shifted and they're getting optimized. So just by using some of the parameters, we could actually just save so much of material, minus 7.7% if you see on the glass, because the glass maximum width was 2.6. But we wanted to make it a standardized glass module between 3660 to 2440. So we started optimizing that, and there was a lot of permutations, and then finally we came up with that option at the end. So now, coming back to digital and data. Now there is actually a lot of data across us. We browse every day, we go to Instagram every day, we go to news every day, but does this data actually make sense? Everywhere there is data. Only when the data is actually organized in a certain fashion, structured in a certain fashion, then it becomes information. Otherwise, it's just lying somewhere there. Once you have this information, okay, you start organizing this information in such a way that you start learning from it. Yeah, that's when you start gaining knowledge. And to apply that knowledge is basically wisdom. Yeah, so in the next few minutes, I'll be showing some tools that we have actually developed using our own experience and how we can actually optimize and get better at work. So we have something called as tools register in Arab, and we have about 2,256 tools. And it's very difficult to actually sort this out. So I had presented this again in Bangalore. But then we had a feedback, that it gets very difficult for each of the disciplines to actually come up with what can I use? So we came up with a Power BI tool where all of the disciplines are on the left. On the center, you have all the parameters that basically relates you back to your tool. So you tick on any of these, and it will basically just shortlist all the tools that are on the right. So for example, I'm just using calculations for mechanical. All the automation tools are there. Even our Python scripts is what we upload within the Arab system. So it just helps us, it just connects us better globally, so we can reuse this information a lot, and then we just become better and better, and keep improving on that. So in the next 10 minutes, I'm going to talk about 5 tools, and in these 5 stages of a standard building life cycle. So in the concept stage, we had developed something called as Façade Canvas. Now, what is Canvas? Canvas is just a plain sheet. It's infinite number of possibilities that you can develop. And that's exactly what we thought when we actually thought about this concept. So in the concept stage, we want to be as open as possible, as exploratory as possible. And exactly this tool built in Grasshopper is doing that. It has all the different parameters, including transom, panel widths, and you can change anything you want. It just reflects immediately. And the best part about this is you can actually sit in the architect's office. And we talk about this, Do we need a shading? Do we don't need a shading? And then it just quickly completes the whole story immediately. And at the end, it links back to Karamba, which is actually an analysis tool, and it tells you whether this structure that you have come up with is actually possible or not. So since last year to this year, we have went further down to actually improvise this software and released a version 2. This is the first time I'm showing this in a public domain. Until now, we've been using this very secretive within the clients and architects. So most of it is actually, you can guide through these parameters on the left, including the gaps between your mullions, your stacks. You can increase the depth of your mullion. You can actually offset the system itself up and down, even out and in, how much your facade is actually sitting out and in. And the best part is you can actually change angles. And all of that can be done through just one script. And you can also check the deflection values, how the actual facade is going to span, how is it going to fan out, what is the difference when actually it's in the worst condition, what is the dimension that you have, whether your tolerances are actually sufficient or not. And you can sit this in a room with architect, with structural engineer, you can finalize this within minutes. So we did this on a project. This is actually a project example that we're building in Mumbai. Now in scheme design, where we go more and more in detail, we started thinking about, how can we come up with automation so that, we can make such quick decisions again when we are sitting with the client. And something that we developed is called Arab Solar. Now sustainability is again at Arab's core, and we try to, suggest the client as much as possible to use as sustainable design. So we developed this tool, which is actually called Arab Solar. Now solar actually talks about sun. So in just one platform, you can do a lot of things. So you can change the G values, you can change the glazing. It also tells you which is the highest temperature of the day, which time. It's taking all the data. And you can keep adding fins, you can do horizontal shades, and again, you can test what is the solar value. So just by changing those few elements, you can actually check, how much radiation is coming on your glass, how much energy is the glazing absorbing. And that also helps in your solar panels, which are at the top, because now you know how much actually radiation is coming inside your solar panels, which is the incident radiation. Yeah, so it just helps to make some quick decisions, whether we need sunshades, we don't need sunshades, is solar panel actually going to be useful or not useful on the project? Now, when we come to detailed design, we really have to dig down into details where we are making drawings, we are making specifications, we are doing everything else. And something that we had developed across the years is something called as digital BMU. Again, the panel was discussing about maintenance and how can we maintain things, why don't we use Revit? Some people are not trained for Revit. And this is a tool exactly there to actually help each one of us to actually design maintenance in a much proper way. So this is our traditional way of doing maintenance planning, where we just mark out, this is where the machine will transfer, this is where the machine will be located. But it was very limited information, only a few sections, only a few plans. But what happens when you do that in the most complex building? So this is GeoWorld Center, which we have shown earlier. And you can see the sheer number of different systems just in this building itself. It was such a complicated building. We actually thought, why don't we use Revit? We resolve each and every area We tried clash detection and everything, and finally we made out a full plan in Revit itself where it shows which system is actually functioning at which locations. And all the library has been built inside Revit, so all the system information is inbuilt, so you can just quickly flip some of the systems and you can find actually the solution that works for your project. Further down, we wanted to make sheets out of it. So we created an automated tool that just basically does sheets in just a few clicks, and then all the information, all the sections, plans get converted into sheets. Oops, sorry. So the idea basically was that we wanted to minimize the repetitive work as much as possible. Somehow this video has stopped working. But at the end, the idea basically was, that the whole drawing set can be prepared in a few seconds. So you just, again, open that toolbox from the top. You tick on the button that says create sheets. You set up the sheet, say print, go grab a coffee, and then share the PDF directly with the client. And trust me, with this, you can just create so many different documentation that you don't have to worry that you have left a place back. So just from that traditional 2D to 3D, our productivity increases, efficiency increases, change has become easy because now when an updated Revit model comes in, I just replace the central link of the model and run clash detection, and I know which systems are not working. Of course, it does need a starting bit of time when you're actually setting up the whole model, but then in overall, if you see the changes that happens throughout the project, it saves a lot of time for us. And again, I mean, the documentation is just immense. You can create sections from anywhere in the project. Now, remember we spoke about data earlier. We said, why don't we apply our wisdom? We know the data. We have the information. We know which systems are there. We know the area. So we said, why not we combine them together? We know the system. We know the area. We know how much days it's going to take to clean. Based on that, we went with a Dynamo script to create a calculation where it says, okay, if I do rental of a machine, it's going to take me these many costs in these kind of years. And if I actually purchase a machine and maintain it every year, this will be my cost. Now, this basically helps the client to make a call whether a rental is more suitable for him or probably just purchasing the machine is more viable. Now we are back to tender and construction in the 4th stage of the project. And this is actually a tool which can do a lot. So I don't know if there's any gamers in the house here, but I was a big fan of Counter-Strike, and that was built on Unity. And exactly this Arab Street is also built on a platform called Unity. I mean, just the sheer amount of work we can do, I will try to show in the next 1 minute what is the capability of this software through a video. In the first one, we are actually plotting all our details in this 3D platform, and all the details are basically in PDF form linked to which section it's pointing out to. So as soon as you tick on that, a big detail will pop out. The second one is you can actually also do your facade demarcation. So which facade is coming at which location. You can color them up. You can also put a drawing there so people can actually go back and reflect. This is the third example where we are collaborating all the drawings in just one platform, and whatever drawing you need, you can just search in the search bar itself. Also, you can show analysis of your sustainability assessments, your solar. This is for an airport project as to showing what the waves will travel if there is a bomb blast in front of that, how your BME operations are actually going to happen. And in case of very complex joineries, you can actually do those installation sequences. You can also do construction management, where you have those drawings placed, whether it's approved, not approved. You can show your CFD analysis in the same platform in just rotating way. You can also show rain simulations for complex structures like these. So it tells you, exactly where actually the raindrops are going to fall. So just immense possibilities, and we are still developing this tool. We are still exploring what else we can do with this. And in the last stage, during the operation stage, we have been appointed by the clients quite a bit for doing some inspections. And this is where we use the same Unity tool that we spoke about, okay? And then we created another tool where we could actually do a proper reporting, proper assessment of a building. So this is what we still used to do back then, where we take our drawings, we go on the side, we write some notes, we come back, we create a report. But then that was completely converted into just this model. And the best part about these models are you don't need Revit, you don't need any AutoCAD, you don't need any SketchUp. You can just install this app on your iPad or your phone. You can go on site and start doing your recording and storing data. And the best part is linked back to your cloud. So for example, if I'm doing the inspection, I'm uploading something, I need a review from the team, I can just say, kindly review this, and they can immediately review and respond to me within seconds. So just another quick short video of a project that we did. Oops. Somehow my videos have stopped working, so we talk about digital, but that's the problem we deal with. So this video is basically just rotating the 3D model and ticking on panels, and you can actually start storing data. Oh, thank you. Thank you. So for example, what this guy is doing is basically just ticking on the panel and actually storing images from on the side. And the best part about this software is you can actually, for example, if a contractor has repaired a certain panel, they can actually come back at the same point, click a photograph, record the information at the same place. So no matter who changes their jobs, the PM changes every time, the facility managers change every time, doesn't matter, because at the end, once you tick that panel, you have all the history along with you. So that's the kind of data gathering, data information that is possible using this tool. And of course, you can filter the data, you can check levels, you can also upload your drawings all to it, so it just becomes easier management. So when we had this data, our clients requested, no, we want a report. We don't like the software anymore. So we said, okay, we have the data, why not use it? So we created a C# script into InDesign. So it takes all the data from the model as a CSV file and then just uploads into this InDesign script, and then you can get your reports in minutes. So this is actually a live demo of the same thing. You can create reports in minutes if you have that data very well organized in that software. And the last thing I'm going to talk about is the drone inspections. So this is again a project that was started when I was in Singapore back with Arab. During that time, facade inspections was quite picking up. And then we wanted to make it as efficient as possible. And the idea was to have at least a full 100% visual inspection of a building. But if a person goes and start doing that, it's going to take a lot of time, and there's going to be a lot of data and how to process it. So the idea came about the AI inspection when we were actually just over a coffee, and I was just browsing through Facebook to show someone, and it says, oh, is this you? And I said, if an image can do it, if somebody can find me just by image data that Facebook has, why not a crack? So that's where the whole idea of drone AI workflow came in. And remember, all the tools we talk about, we have tried to integrate them because it just creates a very wonderful workflow and much easier for us to manage as well. So for example, the drone takes a flight. There's lots of drone image data. You detect the defect using the AI system, and then it goes back to mapping into the 3D model itself. And then what we did is, we had the Unity model, we have the inspection file already. So we said, why not we convert both of them together? Why not we sync both of them together? Because what a drone image gives you is the location point where the image has been taken from. So if the building is here, the drone is here, this guy takes a photo and it says, I've taken the photo from this latitude, longitude. And what we did is we just threw a Z vector to it and then just linked it to the same model. So that whole thing got integrated and then went into an automated reporting system and finally completing the whole story of the drone inspections along with the Unity model together. And the last thing that we recently did was actually linking our 3D models. So on most of the projects, we have all the BIM models. So we said, why not use the BIM model, same BIM model, to actually go back into Arab Street? And actually, the drone images can also link to it. I mean, is that even possible? So we went on to possibilities, and we realized that you can also put latitude, longitude in the Revit model. So we had all the information required. We just had information in discrete facts. We clubbed them together, and then this whole system was made. Just a couple of slides on how this drone defect detection works is basically once the photo gets uploaded, it gets divided into smaller splits, and then each of the split gets actually into the defect detection algorithm. So for instance, we took a project of this housing building in Singapore, and then that photo basically gets divided into 3,804, each then gets into 252 sub-photos, and the detection runs on its own, and then goes back because it remembers the information from the first photograph and tells you, okay, this is where your defect is. And that again remaps to your elevation. So this is again another project from Singapore. So this was very initial thoughts where some of the defects were wrongly detected. So there's a concept called true positive, false positive and false negative. So we started feeding the same information back to the AI, and now it gives a much better results. So just in short, what Arcop's principle is that we shape a better world, and this is just one of our principles to actually push the digitalization to the market, so we could serve our clients better, bring more value to the project. For any queries, please scan this barcode. So we don't produce cards anymore. Arcop follows sustainability to its core. So this is all the information you need, or you can drop us an email on afe.india@arcop.com. Thank you.
Thank you very much, Ritesh, for an excellent presentation on the digital transformation and the use of AI in facade technology today. I think that was an excellent presentation, and anyone has any further questions, you can contact him. He'll be there at the next coffee break.
Okay, thank you.
So ladies and gentlemen, I think everyone woke up after that amazing presentation by Ritesh. But I think next up we have Mr. Faizer Ali Dastagir, who's going to talk about, who is from Viva Composites. He is one of our sponsors and has been in the industry for a very, very long time. A long lineage he has.
Thanks, Rohan. Hello. Good evening. Good evening, Hyderabad. Good evening, Hyderabad. I don't mind losing 2 minutes of my presentation till I wake you up. It's okay with me. Because I can squeeze my data in that rest 18 minutes. I can do that. But you have to wake up. Otherwise, I'll keep repeating good evening every 2 minutes again. Good evening, Hyderabad. Much better. I'm getting a better response now. I'll check once and now and then between my presentation. Okay, I'm Faizer Ali Dastagir, National Head Viva Composite Panel. The presentation that I'm going to do today is basically not a presentation, it's just a knowledge sharing. It's an attempt to change your perspective about composite panel as a material. What I want you to feel after this 20 minutes is how reliable, how safe, and how durable ACP can be a solution to your facade. That's the whole aim of this knowledge sharing session. I would not call it a presentation. Just before I do that, I would first introduce my company to you. Viva is in this business of ACP for the last 2 decades. We started in 2003, but we put our plant up in 2014. So it's now been 9 years that we have our plant in Umbergaon. Today we produce 9 million square meter per annum. We can extend warranties between 10 to 30 years. One of our biggest strengths is our network, which is around 500 customer points. We make FR grade, Class B, A2, and A2+. I will elaborate on all those points in the slide as I move further in the presentation. We have 8 state-of-art production plants, and the biggest strength of Viva is the versatile shades. We have 300+ shades and textures. Basically, a small run back into history about ACP. ACP was founded in the year 1969. It was actually a product that was made by Aluvision, and it was not meant for the architectural industry. So ACP was basically made for signage. That was the real aim of finding out ACP as a material. But in the 80s is when people realized that it could be a cladding alternative, a cladding product, and then people started using it in the 1980s. And in 1990s is when the rampant use of ACP started beginning. It has gone through 2 years now. The product by itself has gone to 2 decades of evolution, but then it has seen its own challenges. ACP has gone through a very upbeat phase, and then it faced a phase where it went down because of too much usage. But the reason behind this is also that it was getting too monotonous. People were not finding anything new with ACP. So there was a big challenge that the industry faced, that they had to change the way ACP looked and felt, and to also make ACP a more durable and a more safer product. It's come a long way. When I started using ACP in the facade industry, it was basically solid sheets, metallic sheets, just the gray, champagne, silver, white. But now if you see, ACP has come a long way, and how that has been done is basically through a lot of interaction with stakeholders like you. to understand what you need in your cladding, what do you want to see in cladding in ACP. So if you want to see a stone finish, a metal finish, a cotton steel finish. So that's how we've closely interacted with the industry to find out what you need, and our R&D has worked on it, and that is how we try to bring out new shades and textures. So if you come to our booth, you would find to see the catalogs on our stone series, our metal abstract series, which is inspired from cotton steel. Then our tarnished metal series, which is our latest offering. This is one of our very, I would say, a premium offering, an offering which has now been very widely accepted by architects because it completely changes the paradigm of ACP looks and feel. So it enters a paradigm of metal composite panels rather than aluminum composite panels. Okay, so there we stop about understanding what we offer. Now let's talk about the challenges that ACP faced as ACP was used. As in Upendra sir's presentation, I also saw that he mentioned about Glefin. Glefin was a fire accident that happened in London where the entire building was gutted due to ACP being a reason to it. The reason was non-FR ACP was used. The core is LDP. You can understand that plastic will burn and plastic is combustible. So that's the problem. Now the video clip you saw here is basically a building in Surat that had the same experience. So there was a fire in the midnight. Thank God there was no loss of human life, but a loss of property happened because it happened at 2 a.m. in the night. So just perceive the same thing to happen during daytime, we be into a big fiasco. So as much as we all look towards having a good aesthetics towards the building, we also need to understand that ACP forms a very large part of the building and it has to be safe. So how do we ensure safety is now the challenge that the entire industry had. Just to give you a small demo of a non-FR ACP being lighted in a lab condition. So this is what exactly happens. The LDP will start burning. You will have two things that will start happening is one, it will start giving flame droplets. Second will be the toxic smoke that it emits. Now the toxic smoke that it emits is the major cause of human life, loss of human life, because smoke is that kills. Fire doesn't kill as much as smoke does in an incident. The experts here would agree on that to me. So how do we now solve this challenge that the industry had? Okay, we understand that the problem is fire and we have to work with fire. So if you understand the construction of ACP, as most of you do, the top surface is an aluminum coil, the bottom is an aluminum coil. The middle is the core. The core had LDP. Now the core was where the issue was and it had to be replaced. So the core was basically had to be replaced with something that is non-combustible. And what is non-combustible was a hydroxide compound that is magnesium hydroxide and aluminum trihydroxide. So if the core was replaced with something that was non-combustible, then we are creating a product that is fire retardant. I again mentioned the word fire retardant. It is not fireproof. It is fire retardant, meaning that it would not participate in fire. So now if this had to be done, then there had to be certain standards that have to be followed. Now worldwide there are a lot of standards that classify fire products, but the most commonly and widely accepted standards in our part of the world is the EN standard for classification. So the class B, which is mentioned there on the top, is basically a standard that is as per the EN. It is not something that a manufacturer has created. It is an EN standard, EN 13501-1, which says that the core of the class B ACP has to be a 70% mineral core and a 30% virgin core. That's what the standard calls for, and if that is adhered to, then the product falls under a class B classification. Then we have an A2 product which is completely non-combustible. Now the standard says you have to have a 90% mineral core and a 10% virgin core. So this is as good as a completely non-combustible panel. If you will have it on your spandrel where the fire is going to impact first if there is a fire in the building, still the building will not, the ACP will not participate in the fire. Now we are trying to create something that will not participate, not emit smoke. That's the aim. And sustain for a certain period of time, the integrity is kept. So if you see, this is a demo that we have created using the Class B panel as well as the A2 panel. So you see there is no combustion that you saw in the non-FR panel. In a non-FR panel, you immediately saw there was some amount of combustion. There was smoke. The flame droplets start immediately. Here there's nothing happening. Yes, there will be a little smoke on the class B, but still the smoke is not toxic in nature. So thereby it doesn't affect the inmate of the building. And when you come to the A2 panel in the clip later on, just now, you will see absolutely zero combustion and zero smoke. There it is. Right. Now this is me as a manufacturer claiming that my product is FR fire retardant. But you as a stakeholder, how do you validate the whole point? So you have two ways of doing it. One is you test the product, or then you ask for a certification. My plea to all of you is that only when you ask the right questions to your vendors, you will get the right product. If you don't ask the right question, then you will not get the right product. So there's a big difference between testing and certification. Testing is I make a sample that is the best I can, and I give it for a test, so I get the desired result. So somewhere I'm manipulating the whole process. But when I say certification, that means my plant is under an audit conducted by the third-party agency, in our case, which is Thomas Bell-Wright, on a periodic basis. Now the period is every 4 months, as per the standard that we have certified for NFPA and EN 13501, which keeps happening every 4 months to check if even if there is a minor non-compliance, it is reported to Thomas Bell-Wright. Frequent occurrence of minor non-compliance will lead to the certification being taken off. Now this is a very foolproof method. Here I do not have any ways I can manipulate. So you as a stakeholder of the building are very clear that you're getting a product that is completely safe. So this is our EN certificate. This is our NFPA 285 certificate. This is an NFPA test that was conducted at Thomas Bell-Wright. So NFPA is basically a test that is for fire propagation and entire assembly. So we create the entire assembly of ACP that is as done in a building, and at the extreme condition, the fire is lighted from outside. And these are the 8 conditions that the test has to pass for the product to be certified. Okay, moving forward, now that we created a non-combustible panel with A2 90% mineral core, we went into innovation and we created a panel that is a corrugated core panel where the core is also made of aluminum. Now we have an absolute panel that is 3 layers of aluminum. It's a very nice product in terms of value engineering, because where you have a solid aluminum proposition or a proposal of solid aluminum, this comes at half the cost directly. So there is a saving of 50% in terms of a developer perspective, a client perspective, which can be proposed. I'll show you a building where we proposed this and this has got successful. So this is the construction of a corrugated core panel. I would just want to move further so that I can cover up other slides which I wanted to focus on. So we also make up the honeycomb panel, which is 12 mm and 25 mm, high performance panels here in our plant as well. So this is where the magic all happens. This is a 13-acre production facility, the largest in Asia today, except China. The reason being, I said we had 8 state-of-art plants, out of which we have 3 coating lines and 5 lamination lines. This is a very important part of our plant, which is a PVDF mixing unit, where we do the entire paint formulation. So customization, matching of colors, RAL color, Pantone, wooden, can be easily done because we have this unique facility. This is coating line number 1, commissioned 4 years ago. This is coating line number 2, commissioned 2 years ago. This is coating line number 3, which was commissioned a month ago. So we have 3 coating lines, 4 lamination lines for non-FR and FR, and 1 lamination line for A2, corrugated core panel, honeycomb 12 mm and 25 mm. I just wanted to highlight more on the kind of projects we've done in Hyderabad, because the event is in Hyderabad, so it will be more relatable. This is the project we did at Raheja Mindspace. The wooden panels you see below the walkway bridge are basically customized wooden panels. So when this inquiry came up to us, we were given this wooden panel that was told to be customized ditto 100%. The client said, if you can match it, you take the order. So even till we dispatch and we send the photograph, the client was not ready to believe it was matched. So we dispatched 2,000 square meter. He said, still on the photograph, I see a difference. I said, no, sir, it is matching. 5 pairs of eyes of confirming it is matching. So please receive the vehicle and then reject if you want to. We did 12,000 square meters, 15,000 square meters on an entire walkway in Mindspace. This is Phoenix Centeris, 25,000 square meter. Again, a customized shade, which we developed. This is Hetero for Raheja again. This is our Desert series, a premium series with a shimmer, which is almost 25,000 square meter. This is a B-Hub, business hub for Phoenix Turner, which we've done one tower with almost 8,000 square meter. The next tower is going to be 12,000 square meter, which is going to be executed shortly. This is a project which I wanted to tell you about, A2+. The initial proposal for this project was solid aluminum sheet, 3 mm. Due to budget constraints the client had, the proposal was given by the contractor, the architect, to the client. The client saw the product to be a reliable product, a durable product, and then we ended up supplying 17,000 square meter of the product for a 30-story building in Mumbai. A few projects we've done in Qatar. Qatar has been one of our big export markets. We're doing projects in US right now. We're doing projects in Eastern Africa, Central Africa, Sri Lanka. We're doing projects in Nepal, Bangladesh. So this is a very interesting case study which I would like to finish. This is a customized shade of bamboo which we developed for Al Khor Zoo in Qatar, which is going to be housing the pandas inside. So panda and bamboo have a connection. So this is the spec that was given to us by Big Architects New York office. So we went ahead. We had no confirmation on the project. We just went ahead out of the quest to research. We developed the entire roller for that. We got the prototype in. This was a prototype we came out with and eventually ended up successful on the project. Thank you so much for being a wonderful audience, and I congratulate all the presenters before and after. Thanks, Zak, for a great event. Thank you.
Excellent presentation. Thank you very much, Faizer.
Thanks.
Right, the next presentation we have from one of our other sponsors. This man I have met him, I think, more than 15 years ago. And every time I see him at a conference or an exhibition, I get really happy because I know that I'm going to get some free chocolate. Because at every exhibition, you see him out there at his stall. He has 2 samples of chocolate, one with a thermally broken profile and one without a thermally broken profile, to show you how the conductivity changes accordingly. Ladies and gentlemen, Mr. Alex Danziguin.
Thank you very much. Chocolate's free today for you. Thank you, Faizer, for waking up the crowd after lunch. Good job. After the excellent presentation of Ritesh from Arup, I think we're going to take you back a little bit to basics, because it was too sci-fi for me, and I'm getting old, and it was so futuristic. Huh? Amazing. Amazing things you can do. So, let's see the clicker here. Today I want to talk to you about thermal insulation of your aluminum windows, doors, and facades. Also about warm edge spacers in double glazing. So, a little bit introduction of the company. We are a family business already in the 3rd generation. Company started in 1969, still a family business. And we specialize in high precision thermal insulation products. All kinds of extrusions. We don't do at all any kind of simple extrusions for, I don't know, irrigation pipes and things like that. We produce many things which are worldwide needed in different industries. I will show you a few in a minute. We are, again, globally present. So we have over 45 production and sales offices, of which 9 are extrusion plants for different products, and very present all over the world. Some of the interesting products that we do You can see, for example, here, I have to show here. This is a profile for deep sea drilling. You have some electric conductive plastic profiles, ceramic-based profiles. We do parts for the car roofs, the sliding roofs in many cars that you have from Volkswagen, from Porsche Cayenne, Maybach, many cars are from us. So different specialty products. Recently we are doing for BMW. Inside the door there are usually aluminum reinforcement in case of accident. And imagine that we are doing this reinforcement now in high strength plastic extrusions. So quite a diverse set of industries we work in. As I said, every kind of industry, whether it's electric conductive, electric or thermal conductive or not. But today we are going to talk about facades, doors and windows, and this is one of the challenges we have, and we're going to look deeper into that. Again, as I said, we're going to go a little bit into basics about the mechanisms of heat transfers, how heat and energy is moving from one side to the other. And this thermal bridging is 85% from the windows, because obviously the walls are well insulated, the cladding as we just heard, so roofs are also, but the windows are the weak point in a building. So we specialize in these two areas. One is the polyamide for thermal break of the frames, and the other one is the warm edge glass spacers for your double glazing units. This is a typical picture from a thermal picture from a house. And as I said before, you can see the roof and the walls are quite well insulated. But the weak points are the windows. And while the glass is orange, which is a leak of energy, the frames are even red. So this is really the highest flow or highest leak of energy. And it's actually one of the questions I always get. Why should I worry about my frame when 85% of my window is glass? So I have to worry more about glass. Of course, you need a good glass with a good U value. But energy goes through the weak point in a window. And the weakest point is the frame. You can see here in this thermal image, what we do is, this is the calculation of the U value, the energy flow from one side to the other. While the lines, the energy lines in the glass are constant or fixed or horizontal without movement, you can see the movement is always in the frame. And this is where you have the movement of energy and the loss of energy. As you explained, outside you can see very well our nice test with the chocolate. We don't have the rabbit today, sorry. But also with the ice. And you will see outside, when you have a non-thermal or what we call the cold aluminum frame system, it freezes completely. While the one with the thermal barriers, the thermal breaks in polyamide, they completely stop right there and then, even though the whole thing is open and energy is flowing anyway through, but you can see the power of insulation you get. The same on the hot side. I think our oven outside is around 110, 111 degrees, and you will see that one side the chocolate's melting while the other it doesn't. It's just a simple way to show and explain that. And why is that important? Because the energy, as we said before, 85% is going through the windows. Now, what are the ways that this energy flows? It moves from one side to the other. Well, 50% is through conduction, and this means through the material itself, through the metal, which is touching from one side to the other. 35% is through convection. Convection are the air cavities inside your window are where the convection moves. You're going to see it in a moment. And 15% is due to the radiation. As I said before, 50% through the material itself, directly, touching from one side to the other. That's why it's called a thermal break. We are breaking the thermal flow in a window. The second is through the cavities. So when you have empty cavities, the air circulation, hot or cold, the energy is heating or cooling the other side of the window. So this effect has 35% of the flow of the energy. And 15% is through the radiation from one surface, the warm surface, to the cold surface. So our specialty is really to get into the details of this and try to stop the energy flow or reduce it as much as possible. Again, as I showed before, the image with the thermal flows, if you take a non-thermal break window, the upper left, you can see, let's say, the U value of the frame. The U value is the unit by which we measure the flow of the energy. So we measure U values, sorry. Oops, it's going the other way. No. Sorry, wrong button. So you can see here if the heat is the red and the blue is the cold side. So in this case, you see the heat going all the way inside. There is no thermal barrier. And without a thermal break, the U value of the frame, so the frame measurement of the U value, is over 6 watts per square meter Kelvin. And this is the flow of energy from one side to the other. As soon as on the right side, upper right side, we put a thermal break, a simple 60 millimeter flat, we reduce this U value from 6 point something to 4 point something, which is substantial. But then there are things we can do to do it more and more. Lower left, you see, instead of 16, we put a 30 millimeter or wider strip, so we have more chance to break the flow of energy, and this reduced further from 4 to 3 and under 3, and we have more and more windows. These days, we have windows which can reach a UF of 0.8 with some of our partners, which you see. So this is what we are talking about. The UF is the frame thermal transmittant. If you see at the formula on the top, this is the U value calculation of the total window. It means there is the area of the glass times the U value of the glass, the area of the frame times the U value of the frame, and there is a linear coefficient which includes the psi. I will be talking about the psi later. This is the area between the glass and the frame. You can see it actually here. Sorry. Right here, this is the psi, we're going to talk about it later. Some of the U values which are worldwide in codes and requirements, you can see a little bit on the Europe side, for example, you have in 1.1 in Germany, in Spain a little bit less, 1.8, even in America it's 1.9, and we have here also in India, the ECBC is actually, last version was 2017, and it is saying that for an energy saving efficiency, you do not have to have the U value should not be over 3, which is still quite liberal, I would say. So 3 is not the most you can see compared to other areas in the world. It's not the most strict, but it's important to have already such a policy, such an energy efficiency code, and this is being revised. We are also in discussions and in the committee with the BSI for a new standard code. I see my partner in that shaking his head, which is going to come in India, a revision, and this will be dictating for all windows, aluminum windows, PVC windows, every window, what are the standards needed for an Indian standard. Why aluminum? We use aluminum because of all of these reasons. I'm not going to go through them, my time is running out, but basically it's structurally strong, recyclable, coatable, and you can reuse it, and this is the best thing for recyclability and our carbon footprints. Why do we use polyamide? Now this is interesting. Polyamide is very low conductive material compared to aluminum. Aluminum is 160 watts, while you can see the polyamide is 0.3 watts. So you have around 500 times less conductivity. That 50% we discussed, you have 500 times less energy flowing in that 50% already. It's structurally strong. We have inside, it's a PA66 GF25, meaning there is 25% glass fiber filaments inside, which is giving the structural strength. So when you combine it together with the aluminum, it's like one bar, it's like the same bar. So structurally, you have the strength for that. Bicolor is another option if you want outside of your building uniform, but inside somebody wants to have a wood finish or a special color. It's also possible because you have now two pieces of aluminum joined by the thermal break. We also have, coming to the presentation before, solutions for fire-rated windows and doors in thermal break. This is a good way to show the difference between, let's say, a basic non-thermal cold system, as we called it before. The UF, the frame only, regardless of what the glass we are putting there, is already over 6 watts per square meter Kelvin. Then when you make it a thermal break, you can have easily, as we saw before, 4 or 3.5, depending on a lot of things. It's not just the width. There are many other aspects in the design of a window. That's why you have specialists and window design, system design companies. And as I said before, we have 1, even 0.8 U-value, framed U-value. Some of the different finishes that we have, I don't want to go into details with those due to time. Also in curtain walls, it's the same concept. The curtain wall also has to be thermally insulated. Not only the glass, but the frames are what are catching the energy into the building. Especially the latest fashion, you know that we have this glass protective edge system for unitized systems. It's now every fashionable, every curtain wall, every facade has unitized systems. And when these are in polyamide, as you can see, it is the only place really that the outside environment and heat is transferred into your building. So these are also now all becoming in polyamide thermal breaks. A good example here is a building in Dubai, which was exactly this case where you have a unitized system with a polyamide glass edge profile. Now the second portion, as I said, we're going to talk about is the spacers, the warm edge spacers. A typical spacer, which is widely used in the industry and very well known, is aluminum spacers. Now it's good for the double glazing, but aluminum is a good conductor. We just saw the ice test and the chocolate test. And so it's not good thermal breaker. So what we have is a warm edge spacer. A warm edge spacer is like a thermal break for your glass. And the material there, what we are using is stainless steel together with polypropylene. It's a hybrid co-extruded system, which creates a better U value for your window. It works on the UW. In the PSI that we discussed, I will show it again. I'm not going to tell you what double glazing does. I think you all know that by now. What I do want to show is that this is the efficiency of the warm edge spacer versus the aluminum spacer. So you have much less conductivity. Here is a nice example. If we take a typical, let's say, a U value, a UW of a window with double glazing in with aluminum spacer, we have 152 watts per square meter Kelvin. Just leaving the same glass, whether it's double glazed with low E, whatever coating, the thermal break the same, the fact of just changing the spacer into a warm edge spacer, it's going down from 152 to 139. So it's a very simple and cost-efficient way to reduce the U value in your system if you need to comply to the specs of the building. Another way would be to put a wider frame with a bigger thermal break. I'm happy with that, but it's more expensive. Or to change the glass into double silver, triple silver. Again, it's more expensive. This is the best way to do that. Of course, we have also every certification with regards to the industry. Our products are also tested and certified for passive house usage. And this is where the PSI, as I said before, is taking a role. The PSI is where the warm edge spacer is. Just some buildings. These are all buildings here in the last 2 pages in India, all with thermal break profiles from us. So thank you very much. One last advantage, it's also helping sound attenuation. Because you're breaking the metal, all the sound vibrations which go through the window frame are now broken into this plastic, which is breaking the flow of the sound. So that helps also with the sound insulation. Thank you very much. Sorry, I am 1 minute over.
Thank you very much, Alex. Wonderful presentation.
Thank you.
Informative, and I think a lot of people will get inspired now to use more of your products.
We have our booth outside.
Okay, next we have Mr. Pradeep from Kinlong, who's going to talk about one of my favorite topics, which is designing using tensegrity facades, which is the use of cables and tension rods without the use of any members which are under bending and have a moment going through them. So all the members are either in tension, they could be cables, they could be rods, and he's going to talk about that. We've done a lot of projects with Kinlong, whether it's the Godrej one in Mumbai, which uses a lot of tensegrity facades, the Birla Centurion, and many other more. But I'll leave it to Pradeep to talk more about that in detail.
Thank you so much. And good evening, everyone. I feel honored to have a chance here to present in front of all of you. I'm Pradeep, representing Kinlong. And then for those who don't know about the Kinlong, we are into design, research, manufacturing, and sales and service of, and being one point contact for all the architectural needs. And this is our factory setup, which is of 6,000 square meter in China, with 16,000 employees working across the globe. And we have 67 subsidiary companies. Kinlong was established in 2003 in China, and then in India we had our presence since 2007 with only one Indian employee, and with the progressive growth we have a footprint in across 16 states in India, with 5 warehouses employing 300 plus employees in Kinlong as Kinlong India Hardware. And then our company is also registered into Shenzhen Stock Exchange in 2016. And this is our presence across the globe. So this is our presence across India, where we have 16 offices in major Tier 1 and Tier 2 cities, and 5 warehouses located at each and every corner of India to facilitate faster shipments. And these are our product portfolios for different category of projects like shopping malls, airports, IT commercial buildings, and then residential projects. Like we basically deals with every kind of project for a construction industry. You name it, we have it. And that was the concept of our company, to have or to be a one-point supplier for any particular person. And that was the concept. Since that concept, we brought it into a reality by having like a wide variety of products into our portfolio. So heading on to my first topic, that is concept and the principle behind the rod and cable facades. See, basically tension cable is the primary tension cable is the primary principle of cable facades. Loads imposed on glass are transferred to building structures or building frameworks as well. And since we are using cables here, this makes the cable facade more sleek and then have a minimalistic look, since cable acts as a primary supporting structure and which is having a very minimal cross section. And these cables are connected with the glass with the help of point-supported glass fittings, that is either spiders or clamps. And very basic principle of designing a cable facade or the concepts are stiffness and stability. Basically, cables carry only tension forces and transverse axial loads. These are the primary factors we consider while designing the cable facade. And here, if we have to talk about the bending forces due to movements, it is not at all considered, and it doesn't have to be a main criteria to design a cable facade. Oh, sorry. Yeah. So you can see here, I would like to explain how a cable facade works, or the principle of a cable works with the help of these 4 simple images. In the very first image, you can see that is a single wire rope without stiffness. So it deformed under the condition of wind load. And the second one has a deformation due to the dead load. It's not only the dead load, it is also with the live load. And picture 3 and 4, if you can see, that is already self-balanced because it's already having stability cables. So these are 4 different type of examples I could take to make it more simple. I mean, to make the concept more simple for you. With the first example, I would like to highlight a project, the historical project Dotton Arena, which was made in 1951. This roofing structure is made up of carrier cable, which carries the wind load. Whenever a project is having a higher wind load when compared to the dead load, this kind of principle is followed, where the carrier cable carries the wind load, and then the auxiliary cables give the geometry to the project. That auxiliary cable is the one which gives geometry to attain the shape. So the next one is the same single cable where live load is more when compared to the wind load. So here, if I have to take an example of Washington International Airport, here instead of, this is a similar concept of PT slabs, where cable is mounted onto the supporting structures of the building framework, and then the slabs are mounted, loaded onto the cable structure. This allows the engineers to design a minimal slab thickness for them. And then the third one you can see here is the self-balanced cable truss system, where there are 2 cables which is on top and the bottom, and these are brought into equilibrium with the help of middle supporting rods. And the basic concept here is, if you can see, there is a middle mast where it is supported with the top and bottom cable, and the outer framework, if you see, that is on the compression loads, and the cable, top and bottom cable will be under the tension loads. So this is one of the other application with suspended cable. Cable is used as a suspending member, where a gas pipeline is supported with carrier cable, that is suspended cable, and then the connection cable is vertical cables, and the stabilizing cables is horizontal cables. And here it is 24 Galfan cable, the dia of 24 cable of Galfan was used. And this is another application of Galfan cables, where Galfan cable is used for tension members as well. So 3 different diameters of 24, 27, and 30 was used. See, whenever a cable is exposed to the environmental conditions, where the cable is not only used inside the building, whenever it is exposed to outside environment, we suggest to have it Galfan coating, since Galfan is having a higher resistance to corrosion. Because Galfan is one such element which is composition of zinc and aluminium, which is having higher corrosion resistance when compared to the galvanized structures. The galvanized type. So we are not limiting application of Galfan cable only for stadiums, membranes, and bridge structures, or the other structures, whatever I have explained to you before. We can also use it for tension structures, cable nets, bridge applications, and trellis systems, balustrades, and artistic installation where it need not to be a structural cable. And going on to my second topic, that is engineering and construction challenges associated with design and construction. See, here we have various challenges when designing a cable structure. That is the cable stability. Cable will only perform better when it is having a higher stiffness, and higher stiffness always results in higher reaction forces to the member. So this load distribution has to be taken care very carefully by equally spacing so that aesthetical view is also not so disturbed. And then to have a better cable connection, maybe in the previous slide I was mentioning about the point fix hardwares. So it is not only the point fix spiders we are going to use, we can also use clamp systems. And then dynamic behavior of the cable has to be analyzed to make it more optimized solution with respect to the price, with respect to the forces which is exerted on the supporting member. And cable fatigue, anchorage designs, which plays a very major role, since the cable is under tension, it will have higher reaction forces when compared to the nominal, when it is compared with our conventional facade systems like FIN or MS. And then compatibility with the existing structures. If at all, if you are planning to rework on existing building, so designer has to take care of such aspects where he has to think whether the designed cable will perform well with the existing structure or not. And then impact of deflection and thermal movement will also have a major role in designing a cable structure. See, all those challenges can be resolved if at all, if you are having a robust design analysis, like each and every stage, if you are checking up for the performance of the cable. See, a cable is not only a cable is practically tested for the minimum breaking load, and then it is used for R analysis. So using of high quality materials, and then designing a construction sequence where stress concentration which is created by the reaction forces exerted by the cable should not cause any harm to the existing building or the framework or structure. And if at all, if you're following adequate, the specified standards or codes, that is well and good. And then periodic maintenance, where we suggest to have periodic maintenance of once in 3 years of first time, and then 2 times in the first 3 years. So that is all about designing a cable facade and what are the different factors to be kept in mind while designing the cable facade. See, cable facade basically, it is a trend that people follow only 2 types of cable, that is spiral cable and then the fully locked coil cable. These are 2 conventional systems where most of the cable facade, either vertical cable or the cable net, these are the 2 things which is being popularly used in the industry. I would not say it is a problem, but if at all, if you have to have a scheduled maintenance, because a dynamic response of a facade is very important to be checked in a regular interval, like I specified before, like once in first 3 years and 2 times in first 5 years. So when we are doing this in an occupied building where it is already operational, it is quite tedious for employees to do it. That is why we have already introduced one more new type of cable system, where this gives a real-time data of what is happening inside the cable. That is changes due to the temperature, and changes in the tension forces across the cable. So all this information can be gathered real time, and this is all achieved with the help of in introducing optical cables inside the cable strands. So this is one of the new trends which is there in the cable facade industry now. So this is the receiver control unit, where this can be connected to the cloud, and then you can monitor the dynamic analysis or dynamic response of a facade anytime, real time, sitting anywhere across the world. So heading on to my third topic, that is integration of rod and cables with the other facade elements. See, cables is not only we are not restricting it to be only for the facade applications or for the heavier structural applications. It can also be used as a decorative element. In this image, you can see this is what we refer to as a dynamic facade, where this is driven by wind. And see, this creates a artistic view where you can see the rolling effect of a wave. And this happens with only the wind which is blowing onto it, the wind blast which is onto the facade. So this is nothing more complex. It is just a vertical cable and then the group of sheets which is assembled together to form this beautiful view. And then, see, we are not limited with only one type of design, that is solid sheet or the perforated sheet. See, we also can do this with unique sheets of different shapes or the perforated designs. All these customizations is possible with the Kinlong. And different materials, if I have to say, we can do this with, we can do these sheets with SS304, 316, aluminium, plastic material, and also zinc. And any finish, any shape, or and it can be customized as per the user requirements. And the other application of cable is for decorative system. This is a non-structural cable where we can use MSGI cable or the steel cable with different strand configurations. And this is also capable of carrying a small dead loads like how it is shown in the image. And one more application of cables is with transparent LED system. This is a product from our sister company. As I said, like we have 67 subsidiary companies, and this is one beautiful product from one of our company called one of our sister company called Nexanova. So in current industry, we only have the LED strip, but this technology involves the transparent LED strips where we can see through the facade, like if you're standing inside or outside. And we also have variety of models which can cater each and every needs. So this helps you to digitalize panels, and then this can be used in glass railings, transparent facades, and models we have to suit for all seasons and reasons. So alternative to the cable structure and conventional aluminum systems, we also have introduced new models this year that is fine processed steel. This can be made into different shapes, and these are all the arrangements and the assembled nodal details. And the beauty of this is it has a good appearance and also sharp edges when compared to the other aluminum sections, and fine finish of powder coating or anodizing. And this is all available with the lower price because of its higher mechanical performance, since the material is of SS, MS, SS and 2 grades of MS, that is Q235 and Q335. Thank you.
Thank you very much, Pradeep. Informative presentation on your products. Right, ladies and gentlemen, it's time for our coffee break. Right. So I hope everyone's recharged after that little coffee break. So to start off this session, this is the last and final session of the day. I know people are tired, but we have, in this last session, we have one presentation and one very power-packed panel discussion with big-name developers, moderated by a facade consultant, and it's going to be a great session. So to start off with, we have Mr. Rajiv, who is going to talk about, he is a graduate from IIT Kharagpur, where he studied his architecture. He's the director of Design Horse, and has also started his own modular architecture company, which is called D-Pod. More about it when he speaks. Mr. Rajiv.
I think the number have been reduced, so after my presentation, I think the topic which I am will be talking about to have some reduction in something. Okay, so it is about the basically regenerative architecture. I think all of you have been well aware of the sustainability thing. Okay, so sustainability is the word which everybody talks, like the architect talks, and then all the supplier talks, all the builder talks about the sustainability. So whether sustainability is really sustainable for the today's context, that is what I'll be talking about. So I'll start with some of the images, basically, that what was there in the past and what is the current scenario of the environment, what we have right now, okay? And if you see that this is basically an image where basically Parag and Parana River, before and after the construction of this dam in 1985, okay, where 15,000 residents have been displaced. So what you see out here, is this, the whole of the water dam has been created and this settlement is there. Before that, there was no settlement in this whole area, whole green region. Now I'll move to the next slide. Again, this shows that the environment is changing a lot, okay? The first picture is like 1975 picture of Brazil, and basically, and the second picture is of 2009. So how much green reduction has been in the two pictures? You can see that. What is the significant green reduction in the two pictures? Then this is one of the most famous picture, what I would say that everybody would be knowing about this picture. Where exactly is this picture? Even I would have not written that Dubai, you would have understood that this is Dubai. So I wanted to highlight that what is the difference it has been created in these years in the two pictures, okay? So this is 2001, and in 12 years, this whole thing has been created in Dubai. Then some of the facts which I wanted to highlight here is 40% of the global carbon emission is due to the building construction. If you really look into that, the whole of the carbon emission, it is due to the building construction related activities. Okay, and then out of that, if you break that, it is 27% is the just from the operations per se. And then 6% is the building industry, and then 7% in the other construction industry, which is basically a figure which everybody should know about that what is the damage we are doing that, okay. Then this is one of the fact, which is that floor area expected to get doubled by 2060. Okay, so every month we are adding one more New York to the earth. So that is the figure which I wanted to highlight you, that that basically 23% of the concrete and steel and aluminum is the reason for the emission of the carbon. Then we have already, everybody here would promote their product with the term called as sustainability. Okay, now the real topic is about whether we are really doing anything related to the environment or how is it, okay. So sustainability is not basically doing anything, I would say that simply. Sustainability is like making a building which is less bad. The building itself is a bad, building anything is a bad activity, I would say that. But what you are doing, you are making a building which is less bad in terms of making it, okay. So we are not avoiding any kind of scenario. So here it comes basically the term which is regenerative, okay. So what is the regenerative building will be there? So I'll be talking about that part basically. So I'll give you some example of the ecosystem, okay. The ecosystem, the most ideal species on the planet is honeybee, okay. Honeybee stays on the flower. It doesn't harm the flower, but it creates many things for the environment. So the many things are like they pollinate crops, they balance the ecosystem, and they fully grow up the grocery stores, fill up the grocery stores. They produce honey, they make our gardens bloom. So honey bee is basically the ideal example we should be behaving in the environment if we have to do anything for the environment. So this is the example what I wanted to show, that the honey bee stays on the flower, but it doesn't harm the flower. Then what is regenerative architecture? Basically, in biology, regeneration refers to ability to renew, restore, or grow tissues in organism or ecosystem in accordance with the natural fluctuations, basically. So really, we are doing anything for nature, that is what needs to be understood. I'll give you a few examples of why this kind of regenerative architecture is needed, okay. In the today's context, basically, it is about just sustainability is about fulfilling the code, fulfilling the building code, whatever has been given, or fulfilling the norms to get the rating in our favor, basically. Or maybe the sustainability terms is being used to do the marketing of the product or the projects. It is, in real sense, it is not doing anything for the society, I would say that. Maybe the South fraternity, industry fraternity will disagree with me, but I have the proof of that, that apart from satisfying the building code or apart from getting the grading, hardly we are doing anything to get the sustainability done in the right way. So what do we need to do to get the certification? Do we need to change that code, or how it needs to be modified in such a way that we save the environment? So maybe I'll discuss about that few things in terms of basically getting the design done or how it is getting done. So it is basically regeneration also seeks to facilitate more resilient environment that can resist natural challenges. So ideally, something of this sort of things should be built that where you are not removing any of the green patches and you are just transforming the green patches to the upper level. So basically, this is the graph where a conventional method is like where you are destroying the environment, whole of the environment. And if we have to make something for the regenerative building, it has to be towards that side where the system and ecology balance should be maintained. One of the example where basically I would say that of the building where you can differentiate that why basically one building is really less bad than the other building is being good is I would give you the example of the code. Code doesn't say that if suppose I am making a building which consumes lesser amount of steel or concrete, my rating would go higher. Does any code refers to that, that if suppose I'm using half of the steel or half of the concrete, my building rating will enhance? I don't think we have that kind of mechanism or the tools basically to reduce that. And I can give you the example from my practical experience. I have seen this in one of our building where one of the structural engineer has given a building where almost like few columns were 1500 by 900 column size, and keeping the same number of columns, we did the building in that 1200 by 600 column size. So almost 50% reduction of the concrete and 50% reduction of the steel has come up with that. So this is what the parameter needs to be looked into that. If suppose I would have made the, basically with the previous, whatever the structural design was there, okay, in the same structural, whatever the consumption was there, I would have made two buildings with same kind of consumption of steel and concrete. So this is what that nobody is going to evaluate those kind of scenario in the context here. And basically the sustainability goal is indifferent in terms of getting the rating done. So the point is that even the steel is, so for basically I would say that the resources are limited. 60% of basically the building material consists of the concrete and steel. And we have no mention of reduction of concrete and steel in giving the coding or maybe the grading of the sustainability part. So this is one of the interesting building, I think it has been done by Arcop only, and where the facade has been considered as like the biomass basically. So what you see out here is the panel which has basically, you can say that it is a facade where biomass has been created, generated, okay. It is living in the facade itself, the biomass, okay. Algae is living in the facade itself, which reduces basically that heat, and then transformation of heat is going into the different portion like storage of the energy is also been considered in this. So this is basically the detailing of that facade, which has been done for that part. Then system thinking is, what is the system thinking? Are we really thinking about the system or the ecosystem which is present in scenario? Or just like that, we are just following that, basically I would say that most of the AC panels and those people are just here to sell their products, okay? And if suppose something is not required, okay, why would I put that on any of the building just to look the building as beautiful as what our intent should be? One of the real-time instance has happened to me where I was doing a building in Begumpet here itself, where Kim's Hospital is coming up. So there was a facade which was basically 3 sides we had the glass, north, east, and south we had the glass, okay. And towards the west side, they had the services, all the services are placed in that facade towards the west side, okay. So the client said that, let's put the glass on that facade as well. Then I argued that, do we need the glass on that side? If the glass is not required, why do we put the glass on that side just to look the building beautiful? So client argued like anything, and then they persisted me to do the glass facade itself on the west side. We said that we'll not do that because it is of no use to have the glass facade on the sides where you have all the pipes, everything is that maintainable thing is theirs. You cannot put that. Why I want to highlight that, basically, if it is not required on a facade, why will we put the glass on that side? So a few examples. Basically, this is I would say that the features of regenerative design. Here we talk about the net zero building. We just place that solar panels and then we say that it is net zero. I will give you the example where basically the glass is the largest wastage of basically the facade system. So are we having the control over the wastage, or are we having the recycling of the glass for the facade part? Okay, so that needs to be basically considered in terms of doing the design as well. Then if suppose we have to do any glass facade where we have to put it on the blank wall, why can't we explore that BIPV panel if really you have to do that glass facade on the wall where you have to do that? It has some sense. Otherwise, covering the blank wall with the glass is of no use. So that is the sheer waste of basically our resources. We are just eating away the resources. Then the water storage and the treatment plant, whatever we are planning to have, that needs to be, water will be precious after some time, and then there will be a fight for the water. So this is one of the example I'll give you that it is a real-time experience of mine, that how we basically control the energy. Everybody is having their in-houses, the fridge is there. Fridge door normally opens through the left side, okay. You notice it when you go next time to your house, and then you'll notice that you open the fridge from the left hand, and then you keep basically the stuff from the left hand, basically. You open it from the right hand, and then you keep it. But most of the heavy pans or pots are basically heavier. You can hold more on the basically the right hand side. So the fridge design itself is wrong, I would say that. You open it from the left hand, you put the pan, you would be saving millions of seconds and millions of the energy by doing so in the fridge design itself. So the design itself is wrong for the fridge. So we have to go into that kind of specific nitty-gritty to save wherever we are utilizing the energy. I will give you the example. I have been doing this for my practice of life, actually. So whenever I used to press my clothes, since my half of the cloth is going inside the pant, so I just avoided pressing in that area, because anyway it is going inside. So why would I do that? So this kind of detailing or basically the saving of the environment should have been done to really context, because whatever it is, basically we are wasting the energy, okay? Wasting the energy by putting the pressure first of all, and then we are not utilizing half of the portion of the shirt to just get it utilized. So why do we need to do that? Since we are not, you are not seeing my lower half of the shirt, why would we do that? So this kind of basically things should be understood from the architect per se, that why we are using this material, whether it is useful or whether it is for functional sense. So few argument happened when I was doing some conference. So people just said that we wanted a glass building, okay? And most of the lift part or the lift portion also have been covered with the glass itself. I told that, why do you need the glass on the lift backside? When you are not seeing through, why will you put the glass on the lift side? So people, it looks good. So I told them that, have you not seen the other building which is without the glass also looks good only? It is about the architecture. You need to look into that, how we do that design. So then some of the, basically that water storage and treatment, this is also one of the method we need to apply out here. And then the climate responsive, we have to have that. I'll just quickly, because the time is running short. This is one of the basically good building or good example where facade has been created by basically solar facade has been created. It's there in India only, this building. Then agriculture and assisting biodiversity should be there for the regenerating architecture. Then basically this point I want to have, like, if suppose the environment is not there, okay, it is about the interdependency, okay. So whatever building we are having, if the environment is not there, we don't have the climate to support it, or basically the ecosystem to support it. If we do not understand the ecosystem itself, we are not going to survive. Then this is the basically the living building challenges are there. Some of the basically examples I would tell you that this is Bosco vertical forest, where I think more than the building coverage, 10 times more than the building coverage, the forest has been created on the building itself. Here we see these kind of images just in the rendering for the purpose of marketing. In real sense, nobody is trying to do this kind of thing, or nobody is doing that. If you are not following that, then why are you putting on the brochure? This is the point, basically, needs to be understood. This is EcoSense Residence in Victoria, where I think net zero, this is a net zero building where they have done almost every aspect of the regenerative design in this building. Then this is of the Museum of the West. This is the same one. This is the building, the hive is there. It's there in basically Gujarat. So this has been done with the sustainability as a part. So basically, this is the conclusion. I would say that regenerative design in architecture is about taking accountability. So how much we are harmful to the nature. We are doing whatever we are building, we are harming the nature. So think about the next time, whenever you are putting the sketch or selling your product, you just think about that, how much harm we are going to put on the ecosystem. And then basically, that's at the end of the presentation, or maybe this was the presentation for the fraternity, or just the learning what I have been following. I'll be following up for my next decade of the design, actually. Thank you.
Rajiv, nice presentation. Thank you very much. So ladies and gentlemen, to the final session, we have a panel discussion, a power-packed panel discussion with two architects. We have two developers and moderated by a facade consultant. So we have Mr. Karthik Pashupati who is going to moderate the session. And Karthik, if you can come up. Mr. Ashok Bhairi of 96 Design Group. Mr. Sujit Kumar, Design Principal of 360 Life Design. Mr. Sandeep Kumar of My Home Constructions. And Mr. Vasu Prakash of Meenakshi Developers. So the topic of this panel discussion is futurism in facade architecture. Looking forward to a very, very interesting session.
Hi all, good evening. Today we are discussing futurism in facade architecture, and here we have great personalities with us, and hope we make best out of it. Sir, we start with Mr. Vasu Prakash Garu. Out of your experience, can you explain us what is facade industry is lacking in present days?
I think good question to start with. Good evening, everybody. Yeah, facade industry today, of course, if you follow a structured approach, that's the best way of doing it. But I think the big projects of doing, big IT campuses or IT buildings, definitely I think most of the people are following a structured approach. Unlike the small projects which go not having much of knowledge on the detailing of the facade or not paying importance to the facade, maybe going in an unstructured way. But irrespective of whatever it is, we as a Meenakshi developers, we follow from the day one. If you should have seen our Deloitte campus and the other projects which are coming up. And now we are doing on composite construction. So it's a behavior of the facade on the steel buildings rather than an RCC behavior. So those particular parameters have been taken care, thought well of from the start of the project.
Okay, sir. Sir, you want to add something else?
See, yeah, facade architecture has gone a long way from what we used to have. It has developed a long way. At the same time, yeah, we are always in the evolving stage. What we see is we need passionate facade designers to begin with, a proper, better understanding of what Mr. Vasu said of the detailing part. Understanding of cost and construction becomes very imminent if we see that, right from the design stage to the construction stage, how to make the facade really perform, not in only the energy efficiency sense, but overall the safety, well-being and other aspects also. So these are the things, and going to the future part, like, how do we develop that facade language further? We need the kind of understanding going to the basics of what, so that the designers to the contractors, the detailed understanding of the execution needs to be there in a more evolved way.
Okay. Okay, sir, with that we move to next question, Mr. Sujit. What are the methods or technologies which we can adopt to make that facade designs better?
Good to be here. Thank you for inviting me. See, the technologies have improved a lot. I'll just go back to the question that you had. We had different stages of facades coming up. The progress has been rapid. You had initially material-centric, then it came into a kind of energy-centric, then we came into people-centric, and now it is performance-based centric. So performances happens how you have to have the tools for that. So you have CFD analysis now going on. So from the past 10 years, if you see, the simulation has been advanced rapidly. You have daylight analysis, you have wind analysis, you have thermal analysis. So it is all giving you, the comfort of the person who is staying inside. So the use of these efficient tools has been progressed, and also on the construction stage, we do parametric designs, and now we are getting into designs like we do workshop drawings, whatever the sizes of the panels, we give them, so it is cut to size. Optimization is getting into that.
Okay, sir, Mr. Ashok. Nowadays, we are seeing most of the buildings, in a typical shape, rectangular or boxy shape. And how to break that stereotype in future?
Okay, I would start with saying in our college days or academics, we always used to learn form follows function and function follows form. So this form is basically the footprint of what everyone would talk about. And now that along with the footprint, it is the envelope what we are talking about. That's the topic. But the another quote is like form follows finance. So now it was earlier not in a right frame of work. Now the clients are aware of what the envelope means and what it makes a difference to the particular building as well as the context of its location. Here now, majorly what we miss in our current practice and current build form is the microclimate. So we always worried north, south, east, west, but what is the context is influencing that particular envelope. Okay. So hence, we always needs to be explorative of what is the right material to be used and what kind of material that can give a sense of the place. And that's where we have to, relook into our building language so that it roots to that particular, the context. Because I come from a background where I did my urban design. So being generally as an architect is egoist and he always wants his buildings to be, standing tall, standing unique. But as an urbanist, we would love to see the building should mix with the context. So that's where I always look into. For example, when I worked with Mr. Nagarjuna for Annapurna Studios, we proposed a brick cladding, simple brick cladding, and juxtaposed with glass, simple glass. And it instantly gave the complete campus with a new look. So that is how you change the atmosphere. That is how you can start a trend in the facade, the way we look into. So maybe these are the ways of aspect one can look into it.
Okay. Sir, Mr. Sandeep, your question.
See, actually, the future, actually from, as a group, what we see is, actually we are not, yes, cost becomes very important, but there are more parameters of environment, health, safety, ESG. Those are the also things which we look into beyond the profitability part, which has to reflect in the building, which has to reflect finally in the facade. When we are talking about deficit of energy and food grain crisis and the other aspects of sustainability, net zero aspects, facade becomes a very important. So that is becoming the beyond the function. We need to see on those fronts as well, so that we have a holistic approach. Beyond that, yes. And the next question is how to execute it. That is something where the design and the execution will come into the play.
Okay. Sir, Mr. Vasagaru. Sir, you are representing client and you are seeing the full cycle of project from day one to day end. So what are the challenges you are facing in related to facade execution, maybe execution or maybe procurement or maybe meter selection or maybe the full cycle? What are the main challenges which you are facing? You think, okay, it should be addressed immediately.
Absolutely. So this is a one valid good question where, because today the projects that are getting the facelift, gone are the days where we are talking of 5,000, 6,000. We are talking of volumes of 50,000 square meters of glass coming into a project. So unless until you have a structured approach, once we get the detailed design concept, schematic drawings from the architect, from there the actual role starts where we put in a facade consultant on the board. So he is there on the day one along with the architect and the structural consultants, not at the last time of the moment, so that he gets involved from the day, from the start of the project. So he understands what is the project, what is the requirements, whereas he can add value add. Basically, to arrive at the economic, when it comes to the final structure is over. So when it comes to the finishes, we get a constraint of the budget. What is the allocation? So if you do the analysis from the day one, what is required, what is not required, things go well. Today, including taking of the wind analysis studies, where the consultants, structural consultants, just don't design with 2.3 kPa. They really understand whether it is 1.5 is required, 2 is required, 2.3 kPa is required, or they play with that combination. So in our project, for example, we put our consultants, Aluvisions, on the job from the day one. So it was very helpful. So they get involved from the start in determining what is the size of the panels, what should the floor-to-floor height is high, how we combine. Then followed by the sections of aluminum, which is economical. So that, aluminum constitutes a major volume of the project. When you talk of 50,000 square meters, you are talking about 400, 500 tons of aluminum that goes. So the section detailing, rather than what you depend on what available sections, they design the sections so as to get economical approach. Then once post that, on the aluminum part, how it is to be procured, whether you go to get the right quality of the material, like going for billet, where billet section is one which is having good technical properties with respect to the tensile loads. So it gives a better product, and it works on economics. And also the selection of the process manufacturing, because once the sections are done, it goes to your powder coating. So what are the things to be taken during powder coating? Important parameters like what lifespan we are talking of. Today we are talking of, gone are the days where you should take 10 years. So today we are emphasizing for 25 years as the powder coating life, shelf life. And the do's and don'ts, precautions to be taken during the powder coating activities. Post dispatch, then we talk of the glass. Today we are talking of the glass system of DGU, where to understand what type of glass parameters, where we go for toughened glass, heat strengthened glass. Then also talking about the thicknesses of the glasses, economic of the glasses. Sourcing the right vendor and sourcing the specifications so that we get the right product from the glass vendors. Because when you talk of high performance glass, you check on the values of U value and the shading coefficients. Those important parameters are what is being emphasized and looked at in selection of the glass, so that, finally we don't land up in the cost going overrun. Every particular parameter is looked into it. And then finally, the last detail that comes is the installer. So giving the right approach to the installers, how the panels are fabricated, which panels have to come in, and where these sections are, utilized. Rather for your project, you can do a project in 30 sections, or you can also go for 50 or 80 die sections. So that's where the structural consultant or the facade consultant plays a very, very important role in getting on the job on the start of the project, where we can do a lot of value engineering and help in bringing the cost optimization for the project.
Okay. Mr. Sujit, apart from that existing, what are the materials available in the market? What is the material you want to use in facades or introduce to the facades in future?
Our design philosophy is we go in for more of sustainable approach. So instead of having glass facade, which is, I'm against the glass, there's nothing wrong in glass, but it's not suitable to tropical climate of ours. So what we do is that we use terracotta. So we have this double shading thing happening. So we have only single glazing unit, and then we propose, shading devices to that. And now we are, getting some prototype done for having a cooling added to that also. It's working out, we are researching on that. And I saw Rajiv, he was saying there is a R&D done in Germany where they have algae between these two glass, where they infuse this oxygen into that. Algae grows, and it forms a beautiful facade element also. And then they take that algae and then use it for, plantation things. So, and again, now you have building integrated with photovoltaic cells coming up, where you can use the energy from the glass and use it for your building purpose also. There is a research also which is going on where you have the reflective, they take the reflective of the glass with some SRI paints, and they claim to say that it can create 30 to 40% of additional rainfall, having the reflectivity. It's on progress. If that works out, then, these kind of, researchers has to be, is going on well, which is good for the future.
Actually, just to add on that, there are, yes, very true. There are certain researches where, on the tiles, with the help of UV, you can even clean the air before it, comes to the inside the building, which affects the indoor environment quality. So energy, air pollution, food, algae. So those are the things, which is getting researched, although it is not today in the market, but we hope that it is getting researched with the help of them, and someday we try to use them productively to go beyond the basic function of the envelope and to get into more positive advantages inside.
So like he was mentioning, we are experimenting in Delhi, where you have this titanium dioxide coating on the steel, where it converts the smoke, it creates this nitric oxide. Now, when you have this titanium dioxide coating, this is converted into non-toxic element. So this is, we are researching, we are also doing it. It's all still in the research phase.
Hydroponics, getting into hydroponics into the facade, where actually it generates food as well as clean air and the biophilic design, what we look into, what some slides were showing. So these are becoming reality. There are challenges. Many challenges are there. It is not that easy. At the same time, the thoughts are there, the research is there. We hope that in the near future, we get those into the market where we can actually implement it, reality.
So, just to add, glass is such a building material which has been controversial for many reasons, whether it is energy embodied material or the way it manufactured, the way it is being used in the building. So we always used to have a debate: if you're not doing a glass building, someone else will do a glass building. So ultimately, the people are oriented, the people are aspire to have a glass building. Now the question is, how much is the glass is the way it should be projected? So as you asked, what is the future needs to be looked into as these buildings? So I would personally feel that since we don't have any codes or it's purely aesthetical, so how much glass is to be operated or put in envelope so that aesthetically it is compensated with some natural material. So for example, if I were to design few of our buildings, when we do clad of the facade, besides that either we do brick cladding wall or put some stone wall or do a second wall. So these are the trends we should follow. Otherwise, if you see high-tech city Gachibowli, complete building, whether it is north, south, east, west, whether it is local microclimate, all sides are being used with glass. I always feel very sad that we should be compensating some material in such a way that aesthetically it's pleasant, and also we can cut short of some of the uses of glass. That's how one should relook into as an architect if I were to design any glass building. So that's where my take would be.
Okay. My next question is to Mr. Vasugaru. So this is your inputs are very important on this. See, why we are not encouraging eco-friendly materials on facades like terracotta tiles or green walls or some other eco-friendly materials? Why we are not encouraging those in facade envelopes? Why we are simply going with the facade regular glass and aluminum claddings or something like that?
So it's a choice by it is the generation change or drift. Now today people will ask why people are going and changing updation. Why are you going upgrading? You could have stopped the functionality. You buy a phone which has got hundreds of functions, but I watch there are very few people who will use all the 100 functions. I could have lived with that mobile which is having a less application. Ultimately, that is going to be used. So requirement of the day, we also have to keep changing. So this is the order of the day. Yeah, people are looking more towards the Western culture. It's the Western culture drift that is happening, more of the glass-looking envelope. But I'm not showing that, I'm not telling 100% that we are also insisting that though a building has to be designed, keeping in point of view of the climatic conditions, the west part which faces the heat or the sun, or where the services are there, definitely that it is not a glass, it's a component of a different clothing material like, maybe not, earlier we used to go for ACP, now it has been granite, and we are adding alternative materials for cladding. So it is a combination of cladding material followed by the glass envelope.
Okay. You have something to add, sir?
See, this is not glass versus any material, I feel. This is the basic understanding of the functionality, the site context, the usability of the building. Accordingly, you have to choose a material. Also, it depends on the height. Also, there are advantages, with glass, which none other material. So it depends on the usability, intelligent usability. It is not only glass or it is not only the other thing. It can be a combination. It can be like what Mr. Vasu said, depending on the orientation, depending on the height, depending on the views. Now the performance glass are equally very good. It is not that, at the same time, there are uses of other materials which has a character other than glass. The character part, the aesthetic part becomes very important as well. So that character aesthetics can be inculcated in the design as we use. So it is the context, functionality, cost as well. And it is not always easy to use stone or other material on a very high-rise building, unitized methods. So constructability, again, cost, structural weight, structural efficiency, implementation, everything has to be looked into. So I think the decision lies with the architect and the facade architect intelligently use material, not get stuck with the glass or the other material. We have to be judicious and intelligent with the system or the choice of materials becomes very important on the overall. Today, 10 or 15% of the cost goes for the facade, so you have to be very cautious about it.
Even the second skin is being very famous nowadays. So you will have a glass at the same time you have the second skin. I think my home has already displayed in there a lot of projects. The second skin add a lot of value and a lot of aesthetics to the glass building. So I think it is appreciable the way in which one should look up to.
See, because today the main industry is it's the volumes. Today earlier we were talking of G+5, G+6 was the max. So there you could have gone away with all the brickwork and the texture paint, that could happen. But today we are talking of 150, 200 meters height buildings. So those particular building technology, unless until you use the advanced method of doing construction, and today with the shortage of manpower, huge crunch of manpower. So every industry is going for automation. In construction industry, where we should do a building with, we started 30 years way back, you start a concreting particular thing, you should have 500, 600 people. Today you have got only about 1/10 of the people. And today, the reason of going for composite construction is because we are not getting skilled manpower. So when there is automation, definitely there is a different approach of materials that is to be selected for.
I just want to make it sure I'm not against glass. I do use glass in design. I'm just saying that the design has to be reflective or responsive to the context. That's the point.
Context, climate.
Context is climate also.
And aesthetics.
Yes, everything to be involved. So you have to do it with
the culture of the location. So all those has to be reflected on an overall basis.
So challenge is that, okay, nowadays we are talking about the green buildings and going net zero and all these things. So we need to move towards in that direction so that we need to change the designs of the buildings to accommodate or enhance that point.
No, to add it to that point, I think Saint Gobain has vouched for the glass industry to touch net zero by 2035-40. So that's the way they are spending a lot of money on research of the glass and trying to utilize maximum amount of glass on recycled products. The same way is for aluminium. So aluminium, I think we have seen we are going to find definitely by the way innovation is happening, we are definitely going to find an alternative for aluminium also. So these are the two major projects that is going into a facade industry.
Just to add on the net zero is a big word. That is divided mainly into 4 parts: energy, water, waste, carbon. Each one has to be looked into individually. So again, going to net zero, energy efficiency, performance glass becomes very helpful. And with the electrochromic glass, VIG glasses, the new development which is coming, vacuum insulated and all, those becomes very important, and BIPV. If you generate energy, then it becomes helpful in the net zero part. Now the water part and the waste part, yes, the waste glass, recycled glass materials becomes very important in your waste, and how do you take care of the waste generated during the construction time and post-construction and post-deconstruction. How do you take care of those things? Carbon footprint. So net zero is a big word, but divided into each part, it is again the choice of materials, including glass. I'm not excluding glass, including glass also, or any other material for that matter, whether it is agricultural material or any other material you want to use. So each one has to be looked into individually into greater detail, and how to, again, detail that out in a high-rise building. Now, Hyderabad is seeing a flourishing of skyscrapers. It is going to beat Mumbai in maybe 10 years or something like that. So we are looking into the futuristic building, the futuristic where, where the urban population is increasing, you have to respond to the current demands. So again, those materials becomes very important. How do you use it? And net zero is definitely, in our company, it has become very important, and we are very much adhering very strictly to that. So we are achieving those with glass or without glass, whatever we are trying to achieve that.
And the most important thing, one we should not meet was net zero. It is not only the material, okay, usage of the material, the minimizing the wastage of material.
Yes.
So gone are the days, I think, if you see the present generation or everybody is very much tech savvy. They are asking what are the norms, what are the consumptions. Gone are the days where people are asking for a 50-story building or 30-story building, not really worried about what is the consumption of steel, what is the consumption of cement. They are asking all the, the breakups where people are designing. One part is designing and next is the procurement. So procurement, you don't have, earlier you should never have a procurement team, never have softwares, never go into the engineering part of it. So you land up a project which requires, say, for example, 10,000 square meters. You don't have a proper planning. That is getting up 13,000 square meters. So we are wasting 15, 20, 25% more. But today, optimization on design, optimization on procurement is automatically directly adding to the net zero practice.
Sorry, one more point is technology. Technology is again what Ritesh showed and the optimization, whether it is in material, the shape, structural efficiency, the efficiency part. Technology, be it BIM or be it other parametrics, that becomes very important again in reduce, reuse and recycle. The reduce part, the first part, becomes very important to address. That also becomes a part of the whole story, where the technology comes into very handy nowadays with a lot of advanced methods where we can, optimize in the beginning itself, whether it is shape, form or material or, again, cost.
We follow the 3 L's in that format. It has to be the lesser, it has to be lighter, and it has to be leaner. This is, if you satisfy the 3 L's, we are somewhere near to the net zero. We can't be net zero 100%, but somewhere near to the net zero.
With that, we move to next question. And with the facades, what are the facades we are designing? Most of the time, we are considering only aesthetical part. This facade we are considering for as aesthetical part. How to involve this facade more into building life cycle?
Into?
Building life cycle. It means helping the building or helping the nature or contributing this, cutting down the heat or something like that.
See, the lifestyle, to start with, facade is not only about, like what I was saying, it is not, should not be looked into. Yes, it is an envelope which gives us protection from air, wind, and water, gives protection, gives, shelter. That is the functional part which is very important. But nowadays it is going much beyond it. Health, well-being, indoor quality. What is the amount of daylight? It increases my productivity. The shading devices, the glare part. All these things are being looked into. At least I think all the buildings, good buildings, are being looked into to provide a very comfortable and a productive atmosphere. Yes, going beyond it was some of these things like, so biophilic design. How do you integrate plants? How do you integrate small windmills on the facade? How do you integrate the air pollution, response to the air pollution or the different orientation of the building? Something like that, very basic thing of orientation, which is sometimes many buildings miss out, right orientation. So these are the things where if you see the sun path, the wind, the response of that, basically on that front. Nowadays there are membranes now, which is there in the facade, which mimic the animals or the lizards so it gets responsive based on the solar radiation. It reduces, it increases the ventilation part. So these are the things which will come, and it will again be more minutely responsive technology coming into the play. So this is going to definitely be more user-friendly, or that is what.
Okay. Mr. Ashok, what are your thoughts on using recyclable materials in facade?
I think we are not, I have not seen much of that exploration in the facade industry of recycled material. Most of the time we intend to use recycled elements or components on interiors, or the way you can, decorate certain aspects of it. But in facade, I doubt, because it is the part in which it is a statement, as Sir said initially, and you need to be iconic, you need to make a statement, and the recycled material to be used in facade, I see very little scope as such. But what I see in one of the question, as you mentioned, like future, because we are going ahead, we are trying to be compact city model in future, is because that's why we are seeing all these high-rise buildings. Most of the new developments are high-rise structures. So in that case, the conventional structures are gone. The PEB structures have come, the metal structures have come. So whatever is the cycle of the building, the envelope carries the same cycle of the envelope. So in order to do that more sustainable, more age-friendly, then these are the material that needs to be used. So recycled material, I doubt of being using much more on the facade front of it.
But to answer to your question, see, any recycled product, directly using it on whether being a facade or anywhere, I think it becomes difficult to define it. Any recycled product, it forms a byproduct. See, for example, if you take fly ash, once upon a time fly ash was a waste, right? 10 years back, today fly ash is a revolution. You don't get fly ash now. Fly ash you have to buy to get fly ash. So fly ash was a waste product in most of the thermal plants. They started with on the roads, now cement manufacturing, concrete manufacturing. So today fly ash is zero. So no material can be used directly as a product, it forms a byproduct.
Just one thing which I want to add is recycled is actually, I think it is possible. Now how? First of all, glass. There is a lot of percentage of glass getting recycled in the current glass. That is also recycling. Aluminum. Lot of aluminum is getting recycled to certain percentage of aluminum. That is one part which is currently available. Now, facade in general, to answer, it is not only a high-rise facade. So there are a lot of materials getting used in a smaller building, maybe plastic bottles, ceramic tiles.
In the building typology and the usage of it, where changes.
I understood so depending on the building typology, if there is a different building typology, even metal frames getting reused, windows getting reused in the facades, or shipping containers getting recycled as a facade materials. So bamboos. So there are many facades which can accommodate recycled materials. In the high-risers and other things also, there is a possibility. Let us not exclude it, is what my thing will. Yes, it is difficult. I understand we are coming in a very high-rise. At the same time, there are many ways to address the issue of recycling. So that can be done, is what I feel.
Okay. Mr. Vasagaru, with this question, we'll wrap up this. Where do you see this facade industry, or what are the developments or technologies you will expect by 2050?
I don't know. Sky is the limit. Today, if you see the way we are catching up, I think we are catching up very fast than any other countries. So earlier, we started our IT buildings 2004, 2005. We are only doing G+5. We are only, SGU, DGU, importing. Now everything is in-house. You touch Gulfan cables are being used. Now today we are using BIM, and today the insight, what has been used for AI, for design, review, maintenance. Sky is the limit. So I don't, 2050, we don't know what is going to happen.
Okay, sir.
Yeah. Sorry, I didn't get the exact question.
By 2050, what are the developments you are expecting in
2050? First of all, our country's vision is net zero. So we would definitely like to achieve that net zero part as and sustainability. See, as we move towards 2050, what are the issues? Climate, environment is an issue, and urbanization is an issue. So definitely, we have to address those. Going not 2050, but next, we have to make a program. What we are planning in-house is next 5 years, 10 years, 15 years, and then 20 years. So we need to address that. Yes, by 2050, the way facade engineering is progressing, it will be more sustainable, responsive, user responsive, interactive and user responsive, will be very key. And actually, carbon footprint has to be reduced. Sustainable, the embodied energy has to be drastically come down. The engineering part, the detail part, and some of these things, what we spoke earlier, I think the response, as we are maturing and evolving in Indian context, the response will be more creative, at the same time more sustainable, with more parametrics coming in, more curvilinear and other facades we look forward for, which is more interesting, more responsive to the urbanization. So those are the things, but it has to be more cost effective and sustainable as well. So it has to go hand in hand, is what I feel together. So it will be aesthetically more pleasing, more functional and climate responsive and user responsive that way.
One thing
Intelligent.
is for sure, I think it is going to be added in your course of studies. Earlier, facade was never there in your engineering, be it architecture or civil engineering or mechanical engineering. So I'm sure by the way the industry is growing, definitely there will be a subject being taken up by the college campuses, adding into their syllabus. I think with that, it will add much more young engineers throwing more light and making it a systematic, tailored way of approach and structured way of glazing. That's for sure what I can see.
It will be very interesting.
Yes. Mr. Jindal.
What he says is already in progress. There's a material called graphene. I'm not sure how many people know of this. This uses nanotechnology. It is something like your iPhone or your interface. So the material is going to be ultra thin. It's like something like a tensile structure. So you will never have walls. You sit here, you want to know, you touch it, it is raining in Gachibowli or it is raining in Kondapu. It is going to translate more data through the walls. So every building next to each other is going to translate this data, and it is going to be very responsive and immersive in nature. I'm a very futuristic person, so I'm thinking it's going to happen.
So sure.
I think earlier we had buildings, or we used to say buildings life cycle as 100 years. Now the building lifespan is becoming less. Every 10, 15 years the building is either demolished and rebuilt, or make a campus and make multiple buildings. So I'm looking into the future in such a way that if the building needs to be transformed after 10, 15 years, instead of recycling the material, you should devise in such a manner of the material, it should be reused so that the recycling cost can be compensated. The structure can be redesigned with the reusing material. Maybe that should be the motto while we go for 2050 or 2060. So the life cycle of the building is getting smaller. So because nowadays all the structures, as we are seeing, all metal structures. So anytime you can dismantle, you can reconstruct it. Maybe that is how you should be seeing the future, as reusable structures rather than recycled structures. Thank you.
Thank you. So with that, we'll wrap up.
Thank you.
I thought this was an excellent, I wouldn't call it a panel discussion, I'll call it a debate. We have two debating teams over here, the mighty developers versus the architects. I thought it was excellent. Yeah, of course, it's a healthy debate. Discussion is always good. Yeah. So obviously the topic had a lot of interesting perspectives from each side, and there was a debate of the use of glass, the use of facades, the use of materials, and how they can, are they sustainable, not sustainable? And I thought it was an excellent exchange of ideas where, there were two debate teams, and it's always. Yeah, of course. That comes to the end of our event. So thank you very much, ladies and gentlemen. And looking forward to seeing all of you at our next Zak World of Façades in Hyderabad.